found you when your heart was broke. I filled your cup until it overflowed. Took it so far to keep you close. I was afraid to leave you on your own. I said I'd catch you if you fall, and if they laugh and fuck them all. And then I got you off your knees, put you right back on your feet, just so you could take advantage of me. Tell me how's it feel, sitting up there, feeling so high, but too far away to hold me. You know I'm the one who put you up there, name in the sky. Does it ever get lonely, thinking you could live without me, thinking you could live without me? Baby, I'm the one who put you up there, I don't know why, yeah, thinking you could live 100 tries, just running from the demons in your mind. Then I took yours and made them mine. I didn't notice cause my love was blind. I said I'd catch you if you fall, and if they laugh then fuck them all. And then I got you off your knees, put you right back on your feet, to show you could take advantage of me. Tell me how's it feel, sitting up there, feeling so high, but too far away to hold me. You know I'm the one who put you up there, name in the sky. Does it ever get lonely, thinking you could live without me, thinking you could live without me? Baby, I'm the one who put you up there, I don't know why, yeah, thinking you could live without me, live without me. Baby, I'm the one who put you up there, I don't know why, yeah. You don't have to say what you did, I already know. I had to go and find out from them. So tell me how's it feel, yeah. Tell me how's it feel, sitting up there, feeling so high, but too far away to live without me, thinking you could live without me. Baby, I'm the one who put you up there, I don't know why, yeah, thinking you could live without me, live without me. Baby, I'm the one who put you up there, I don't know why, I don't know why, oh, yeah, oh, yeah, oh, yeah,
See here, kid, you gotta just go for it. Don't think about what comes after or what came before. You just gotta bend your knees, take a deep breath, and jump. And you might think,
Things we couldn't imagine a year, a week, a day ago. And now with AI, you can do even more. You can build new applications that move mountains and markets, that unlock insights and extraordinary customer experiences. Applications that solve real-world problems, navigate uncharted territories, blaze new trails. But you need the right partner. A partner that takes all of this and securely and flexibly unifies it, empowers it, connects it to a wider ecosystem, scales it to new heights, makes it more relevant, makes it more intelligent. A partner that puts developers first, so you can focus on the work that matters most. With AI, incredible things are possible, but only if developers are there to guide it.
Please welcome Global Lead Retail Solutions, Genevieve Broadhead.
Good morning, London. So exciting to be here and back in London for a landmark EMEA event for .local series. So we're actually going to 22 different cities across the globe this year, meeting our customers in different communities, seeing our developers and what they're building. I've actually just had the experience of going out to Asia, to Kuala Lumpur, Jakarta, Singapore, Bangkok, to see over 2,000 of our customers at events like this. We couldn't be happier that you're here today, and we're so excited to share it with you, product announcements, news, upgrades, announcements. You're going to hear it here first. So before we start, I just want to take a moment to thank our sponsors, so AWS, Google Cloud, and Microsoft, and all of our participating local sponsors here in the UK. And we've got a great day lined up for you, so it's going to be pretty non-stop. So 5 breakout stages all across this venue. We've got our industry experts, we've got our product teams, solutions architecture, some of our developers, customers like you also who are building powerful applications on MongoDB, so you can hear what they've done, learn from their stories. We've also got more technical hands-on workshops. If you want to get hands-on with some of our features, so Atlas stream processing, vector search, you can spend time with our devs and really get to know that new technology. And if you have questions for our teams, please go to the Ask the Experts on level 2. They're there to answer your one-on-one technical questions and give you a little bit more insight into MongoDB. At the end of the day, we're going to meet all back together for our closing reception at the Richmond Room. So I hope to see you all there so we can come together, learn some insights, and have a little bit of fun as well. So before we dive into the exciting sessions we have ahead into the rest of the day, we're here together to kick off with the keynote. So it's my absolute pleasure to announce to the stage MongoDB's Chief Product Officer, Sahir Azam.
Good morning, everyone. What an amazing turnout. We are super excited to be back in London. Oasis is back. MongoDB is back. Kind of like the same thing. But I wanted to kick it off with really a question for all of us. As technologists, we think a lot about what will differentiate truly great companies, our organizations, from our competition. And at MongoDB, we believe a key part of that will be the applications that you all build. We're talking about increasingly capable software that can change as quickly as the world around us. We're talking about applications that will create new business models or customer experiences that delight your customers. It's the mobile banking app that handles instantaneous payments with trust and reliability that our customers expect, or an e-commerce platform that guarantees real-time order processing and real-time inventory updates, even during peak events. Or the video game that has millions of concurrent players all at once having an immersive experience without missing a beat. These are the incredible experiences that we're building today and will continue in the future. But what stands in our way? Time and time again, as we speak to all of you, we hear that a big problem is the complexity of your underlying data architecture. We see outdated and costly legacy systems that drain your resources. The rigidity of traditional relational systems that hold you back from making fast, dynamic changes to serve your customers. And the fragmentation caused by the plethora of cobbled together niche technologies that need to be stitched together just to serve the modern needs of your applications. Each of these problems on their own is a significant pain point. But when you tie them together, they compound, and they hold you back from delivering those amazing experiences in a cost-efficient way. MongoDB was founded to help solve these exact problems. We set out to help developers build amazing applications with a database built from the ground up around a novel new data model, the document model, a much more natural way of working with data. MongoDB was developed to be easy to get started with, as well as easy to use as your application and your business expand. Over time, we expanded our native capabilities to serve a wide range of use cases. We give you the flexibility to run in 118 regions in Atlas, most of any cloud database in the world. But we also give you the flexibility to run in your own data center and develop locally on your laptop. We built a comprehensive developer data platform with the functionality required to serve a variety of operational use cases, from the most simple to the most sophisticated. And as the needs of modern applications have evolved, so have we. We've continued to add capabilities and to add strength to the core platform to make sure that we can serve and stay ahead of your most advanced needs. And as we've met with our 50,000 customers worldwide, we found that many of you are focused on 3 key priorities, either one of them or all of them. 1, enabling developers to build software faster, yet more efficiently. 2, finding ways to introduce new tools, new capabilities to create AI-powered applications as we move into this new era of technology. And finally, ways to modernize off legacy traditional applications and systems that drive immense cost and complexity. But like anything you build, the foundation of it has to be strong. And the foundation of any application is its operational database. And at MongoDB, we put a continual focus on building a strong foundation for your applications. We spend a lot of engineering time and resource on resilience to ensure your database confidently handles unpredictable situations. We enable scalability so you don't have to worry about whether your database can keep up with the ambition and the size of your audience or your customer base. We implement security capabilities that meet your most stringent requirements and protect your data without compromises. And of course, performance, so your database is always a tailwind, helping you capture your opportunities and doesn't get in the way. These are some of the key attributes of MongoDB that we continually invest in and we're constantly working to optimize and improve. And I am proud to announce today that MongoDB 8.0 is being released for general availability. We believe this is the best version of the database that we've ever shipped. It's optimized to handle all your real-time operational data needs for any use case. And here to tell you in detail what's new in 8.0, please welcome Tyler Brock, Vice President of Engineering at MongoDB.
Thanks, Sahir. As a developer, a user, and a former large-scale commercial operator of MongoDB, I'm incredibly proud of what we've accomplished with 8.0. And I'm excited to tell you about all of the features you can take advantage of starting today as the release becomes generally available. Let's dive in. Right now, customers all over the world depend on MongoDB to power their mission-critical applications. And with 8.0, MongoDB is more resilient than ever. We've made memory management more efficient, we're providing a greater degree of observability, and we're providing more powerful controls so that you can take action if and when you need to. So let's talk about what you get right out of the box just by upgrading. We're shipping 8.0 with a new memory allocator specifically built for modern platforms. It uses a cache per core rather than a cache per thread to reduce fragmentation. And it's able to leverage transparent huge pages to lower memory management overhead on systems with large amounts of RAM. And because databases are some of the most demanding users of memory, the end result is more predictable performance for your applications. So for the things we can anticipate, like needing to acquire memory, this new allocator is going to keep things running smoothly. But as operators, we also need advanced tools for when inevitably something unanticipated occurs. To handle those situations, you need ways to find and address bottlenecks in your system. So in this release, we added additional query metrics that provide better insights and enable operators to differentiate between queries that spend a long time queuing and queries that spent a long time running. So when the bottleneck happens to be a query that's consuming a lot of resources on your system, we're giving you more controls with the ability to block them using query rejection filters. By rejecting queries that match a particular shape, you can protect the rest of the workloads on your database without having to patch your application. And to limit their impact before you've had a chance to block them, we're also giving you the ability to set cluster-wide timeouts for read operations. And we believe these improvements are going to benefit MongoDB deployments of all shapes and sizes. We also recognize that the businesses and the applications you build on top of MongoDB aren't static and need to grow. That's why at MongoDB, our mission is to make developers productive with data at any scale. And why, from the beginning, we provided a consistent developer experience, whether you're running our database platform on your laptop in a coffee shop somewhere, or seamlessly across 10,000 nodes at a data center. But we wanted to go further. For customers just starting to grow, you asked if we could make it cheaper, faster, and easier to take advantage of sharding. And for this release, we're delivering 3 major improvements to make it happen. Embedded config servers, the ability to move unsharded collections, and faster resharding, all of which make this the best release of MongoDB yet for customers that are ready to grow. Embedded config servers reduce the cost of running single shard clusters by up to 50%, while dramatically lowering operational complexity. This makes sharding much more accessible for test and development clusters because they're just as cost effective and just as easy to run as replica sets. The ability to move unsharded collections allows operators to horizontally scale without needing to choose a shard key. This helps your database handle workloads that grow big without requiring application changes. And once you are sharded, we've made it easier to keep up with your application as it evolves by making resharding up to 50 times faster in 8.0. 50. This makes it much, much smoother when you just scale out, rapidly scale out to support demanding loads, or quickly scale in to save money. So as you can see, we're laser focused on scalability. And because our customers continue to grow and be successful with MongoDB, we also need innovative ways to keep all that data safe. So last year, we launched a new feature, an innovative, industry-first feature we're incredibly proud of called queryable encryption. We call QE for short. Our cryptography research team spent years developing this unique capability, proprietary to MongoDB. Here's how it works. When you enable QE, fields you select are encrypted and remain encrypted in transit and at rest, and critically while in use. So anyone managing your system, from your own internal teams to an employee at a cloud provider, and even MongoDB can never have access to that data. We launched QE in 7.0, and it supported equality queries, so you could find encrypted documents that were an exact match to your query. And we got great feedback on it. Customers told us that queryable encryption allowed them to trust the cloud for more use cases around their most sensitive data. Now, in 8.0, we made this unique capability even more powerful by adding support for range queries. So now you can run queries that find matches within a date or numeric range, all while your data remains encrypted. Pretty cool, right? So for example, a bank can now compose queries like find every transaction that exceeds 1,000 pounds, all while your exact amounts remain encrypted. Or a medical researcher could perform an analysis like find patients with a particular diagnosis within a certain age range, all while their PII remains fully encrypted. And last but not least, our latest release brings with it a truly incredible set of performance improvements. In 8.0, we've made hundreds of optimizations under the hood, and we've made this the fastest release of MongoDB ever by focusing on the workloads and operations our customers care about most. Low latency reads, high throughput writes, and the performance of advanced queries like aggregations. So how did we do it? First, let's talk about reads. An important role for any data platform is in consistently delivering low latency reads for your applications. And for a database to operate as efficiently as possible, it means we need to get to the query engine quickly and return results fast. So during the 8.0 development cycle, I had the engineering team dramatically simplify our command execution path. And in doing so, we were able to reduce the amount of instructions it takes to run latency-sensitive operations by an astonishing 37%. On top of that, we've added a new express query execution stage, purpose-built for returning results to simple queries quickly. For equality matches, this new stage is not only faster, it's also more versatile, supporting clustered indexes and matches on any field, not just ID. Now, when it comes to writes, MongoDB's primary responsibility is in making sure your data remains durable, of course. So by default, we only acknowledge writes once they've been replicated safely to a majority of your cluster. In MongoDB 8, we're now able to pipeline some of these replication operations and perform them in parallel. This improvement makes secondaries much more efficient and reduces the latency of replication. As a result, we're able to acknowledge majority writes much more quickly, substantially improving total system performance. And in addition to improvements for reads and writes, the team set their sights on improving the performance of more advanced queries, like aggregations and index $in. These operations are fundamental to building rich and powerful applications, and our testing shows that you'll see really impressive results when you upgrade. We also have something special in store for our time series customers as well. In 8.0, we're making use of block processing, a technique that allows us to work on batches of documents rather than working through them individually. By processing them in bulk, we're able to amortize the cost of expensive operations. And so, for example, this will help common use cases for time series workloads, like calculating a moving average or a roll-up of information over time. For queries like this, block processing has an impressive positive impact. All of these improvements mean that upgrading to MongoDB 8 can dramatically reduce latency and increase the throughput for your applications. We put it to the test with industry standard benchmarks, and the numbers speak for themselves. For benchmarks that exercise read-only workloads, we see MongoDB 8 perform 36% faster than the previous release. And in benchmarks designed to replicate typical web application workloads with a mix of reads and writes, we're seeing MongoDB perform 32% faster. For bulk inserts, we're seeing a 56% improvement. It's incredible, right? And for common time series workloads, we're seeing an incredible 60% gain with the introduction of block processing. So I'm really proud of the leaps we've made in this release, and you can expect to see more from us in the future. One more thing. Of course, improving performance and scale is not just limited to our core database. We've also made improvements to Atlas. So today, we're releasing several enhancements to Atlas that deliver up to 50% faster vertical scaling and up to 5 times more responsive auto-scaling. So this, combined with our ability to independently scale shards, allows Atlas to deliver unparalleled performance and availability for your applications. So that's all I can squeeze in to the keynote, but if you want to hear more about all of the improvements that we've made for 8.0, please check out the breakout session led by Garudi later today. Back to you, Sahir.
Thank you, Tyler. We are super excited for all of you to try 8.0 and check out all these new capabilities and improvements. They will not only power growth for the most ambitious applications you build, but they will also drive down cost efficiency. This is an environment where every organization is being prudent about how and where they spend money across their entire application estate. With this foundation in place, I'd like to turn first to our #1 priority, developer acceleration. In recent years, we've heard loud and clear that one major challenge that developers face is integrating real-time data into their application experience. This is true for sophisticated use cases, such as tracking vehicle traffic for a product delivery, or monitoring real-time quality control on a manufacturing line, or keeping user activity up to date in a multiplayer game. These are all complex use cases. But this is important for even basic brass tacks needs, like publishing application events across the enterprise, or outputting your operational data into a cloud object store like S3 for consumption by downstream systems. The real-time data that powers these types of use cases often lives in streaming systems like Apache Kafka. This information and data is naturally rich, it's heterogeneous, it's constantly evolving and changing. And in order for developers to leverage this information as part of an application, we've seen an emergence of stream processing technologies. However, the technologies today introduce pain points that make working with streaming data harder than it needs to be. They all rely on rigid schemas that are difficult to adapt for sparse and heterogeneous data, which is inherent to the information flowing through platforms like Kafka. This creates friction, causes errors, reduces agility, and creates additional data processing steps that creates more complex and complicated code. It introduces disparate APIs, drivers, and tools to the stack that make the developer experience quite fragmented. And of course, adopting a stream processing technology introduces yet another point solution to your stack, increasing operational complexity and cost. Simply put, working with streaming data is far more complex than it needs to be. We knew there had to be a better way. So last year, we introduced Atlas Stream Processing. It provides developers with everything they need to start working with streaming data natively in MongoDB. And over the past year, we've worked with hundreds of companies across multiple industries, and the feedback has been tremendous. One great example is Meltwater. They help over 27,000 customers worldwide manage marketing intelligence. I'm sure many of your organizations are customers of theirs. And they monitor online, social, broadcast, and now even podcast mediums by analyzing millions of behavioral and customer signals in real time. Meltwater leverages Atlas Stream Processing to ensure their customers have a real-time understanding of their brand, which is a competitive edge in this always connected world. Now, the reason Meltwater chose MongoDB Atlas Stream Processing is because of the document model. It's a natural fit for the complexity and richness of the data found in streams. We've extended our query engine to process streaming data in real time without ever having to persist it. And we've integrated it natively into our unified experience. All the same drivers and tools you're familiar with work seamlessly with Atlas Stream Processing. Please join Joe later to deep dive into more of the specifics. Now, our native stream processing capabilities are just one way that we're making it easier for developers to build. But it's certainly not the only thing we've been working on for the last year. To dig deeper into our efforts to support developer acceleration, let's talk about the robust collection of tools we provide. I'd like to welcome from our product management team, Melissa Plunkett and Max Marcone, to walk you through some of the latest.
Thank you, Sahir. When you build an application, you want to get it out to your users as quickly as possible. And of course, your business considers this imperative as well, because your ability to iterate faster than your competition is crucial. At MongoDB, enabling developer velocity is core to what we do. And the suite of tools that we provide reflects this. Let's talk about 3 key functionalities that we have some really exciting news about today. The first enables quick iterations and fast feedback loops in the process of building modern applications. To achieve this, last year, right here in London, we launched a local development environment offering for Atlas, launched from the Atlas CLI. Since then, we have incorporated a lot of customer and developer feedback right back into the product. And with that, we are very excited to announce the GA of our local experience for Atlas. It's available via the Atlas CLI, but also directly from Docker and Docker Compose. It includes key features such as Atlas search and vector search right out of the box so that you can build and test your applications with full text search, semantic search, and AI capabilities both locally and in your CI pipelines. And all of this is up and running in just a few seconds. In fact, Max, would you like to show us live just how quick this is?
Yes, I'd love to. Let me show you. So the first thing we're going to do is to create a local environment for Atlas. And to do that, I'll use the Atlas CLI. The Atlas CLI will guide us step by step through all the process. So let me use this Atlas deployments setup command and answer all the questions that the CLI asks me. So we'll say this is a local environment. We'll customize the settings a bit. So we'll call the environment local London. I cannot type. There you go. Then we'll select 80, and we'll give it a port that is easy to remember for later. Now we'll give this a few seconds. The Atlas CLI is pulling all the dependency, setting up the components on my laptop, and there you go. We are done. The local environment is up and running, and we can connect to it.
Now, that's pretty cool, Max. How about if we automate this with the script?
Yes, everything I just did interactively can also be done programmatically with a script. It's actually a one-liner that you can integrate with your environment. And for our customers who use Docker Run or Docker Compose to set up their development and testing environments, this is all available there too. Now, speaking of scripting, let me show a couple of commands that you can add to a script to put some data into your local cluster for testing and create some indexes. So for the data part, we'll use Mongo Restore, and we'll point it to the port that I configured earlier, and we'll give it an archive of data that I have here on my laptop. Ooh, forgot an equal sign here. There you go. Ooh, what did I do?
You're missing an E.
What?
An archive.
Oh, good point. Thank you for pairing with me. There you go. Data is imported. Now, we'll create an Atlas search index. And to do that, we'll use the Atlas CLI and apply it to the local deployment I just created. So to do that, we'll do Atlas deployments again. We'll say search, and then index, create. Now, we'll give the deployment name, so the local London that we set up earlier, and we'll point it to a file where I have my search index configuration. There you go. The index is now created, and we can start developing our queries.
Fantastic. Thank you, Max. With just a few commands and in just a few seconds, we have a fully functional test environment. But we're certainly not stopping there. The second key functionality that I like to spotlight helps developers design, test, and iterate over their queries. Starting today, we're bringing this workflow right inside of developers' IDE. MongoDB for VS Code now integrates with Copilot to make writing queries, scripts, and performing other database tasks easier than ever without leaving where you're working. MongoDB was a launch partner with Microsoft when Copilot's extensibility was revealed earlier this year. And now we're making it available in public preview for everybody. Max, would you mind showing us just how powerful this functionality is?
Yes, in fact, I've been waiting for a couple of months to give this demo. So first thing first, we're going to connect to the local environment we created a few minutes ago, this local London environment. Now here, I can browse my databases, I make my collections, even take a look at the schema of my collection. Now, let's see if we can create some interesting queries. This data is about taxi rides in London. And there are some customer reviews in here. Let's see if anybody talks about traffic jams.
Now, that sounds like a really great place to use Atlas Search.
Yes, this is a full text search use case, and Atlas Search is a great fit for that. Now, let's pretend I don't exactly remember the syntax of an Atlas Search query and see if we can get some help with there. So I'm jumping into the Copilot window. I'm a big fan of Copilot. I use it all the time when I build applications. And now let's see how it can help us work with MongoDB. So we've announced Copilot with a MongoDB chat participant. You can think about the chat participant as an expert in MongoDB tasks. And specifically, we're going to choose the query task because we are developing a query. Now, normally, I would type here the prompt that I want to use for my query. But for the sake of this demo, I'm just going to copy-paste it from this text file that I have here. So we'll say, Copilot, please write an Atlas Search query to get all the trips from trips collection where reviews mention traffic jams. And let's use fuzzy search just in case. Now, I'll send this to Copilot. Copilot thinks about it for a few seconds, and it actually realizes that I did not specify a database to use for my query. So it asks me a follow-up question. Let's say I want to use this production database, and now Copilot has generated the query. It actually looks about right. There's a $search there, and it's using a fuzzy configuration with 2 max edits. But if we want to actually verify that this is the query expected, we can actually run it with a button. There you go. We have the query. Let's check the review to see if it's what we're expecting. Oh, yes, this looks like the review of an angry passenger. I guess British-ish. And it does talk about traffic jams. So now, the beauty of this is that it doesn't have to stop here. With Copilot, I can keep iterating on my query. For example, if instead of just pulling the reviews, I wanted to count all the reviews that talk about traffic jams, I could use this other prompt. I could say, now I want to count the traffic jams cases, and use the collection trips and database production to use double specific. Now, a few seconds, Copilot comes back with a new query with the new criteria taken into account too.
What a huge time saver, Max. Instead of having to leave VS Code and going and read documentation, or going to a forum and asking a question, waiting for an answer back, you get everything you need right there. And I think it saved Max a little typing, so an extra added bonus.
Yes, this is what I like about Copilot in general, but now we've supercharged it with MongoDB skills too.
Fantastic. Thank you, Max. If you'd like to learn more about, let me put that back. If you'd like to learn more about VS Code with Copilot, be sure to check out Gaurav Ariel's lightning talk a little later today, Data Model Your Way to Success with MongoDB's Copilot extension. Now, the last functionality I'd like to highlight makes the full process of building applications even more efficient. We've partnered with our friends at JetBrains to augment the MongoDB experience and their suite of IDEs, starting with IntelliJ for Java. I am excited to announce that our official plugin for IntelliJ is now available in private preview. So snap this QR code right here and head to our website to register for access to this exciting new plugin. Now, with this plugin installed, you're going to get enhanced autocomplete and type validation for your MongoDB code. You can jump from your code right into the database console to troubleshoot your queries, and you'll see inline proactive performance insights, such as when your warnings when your queries aren't covered by an index. So let's take a sneak peek at this exciting new product. Max, take it away.
Yes. So you might be familiar with IntelliJ. It already comes with some built-in MongoDB functionality. With that, developers can connect to their MongoDB clusters, they can browse their databases and collections, and they can even prototype queries in the built-in console. But we wanted to take it one step further. We wanted to truly support developers across the entire process of building a Java application. So for that, let's imagine that we are building an application again on top of the data set about taxi rides in London. And in particular this time, we want to help operators address open disputes. Now, the first thing we want to do is to query for the pending disputes. And we're going to do that in this find all pending disputes by type var in the trip repository class. So pretend I remember, pretend I remember the syntax for my Java code, but I do not remember, or I'm not familiar with the schema of this collection. Let's see if IntelliJ can help me there. So we'll say filters, we'll use an equality filter here. And as you can see, IntelliJ is aware of the schema and suggests possible fields. So here I'm going to use status, and I'm going to say pending. And then add another filter. We'll say filters.equals, and now we'll say dispute.type, and we'll give it a 1 for the type var. IntelliJ here is actually trying to tell me something. It's aware of the scheme of the collection, and it knows that I used an integer where I was supposed to use a string. This is a helpful warning because it guides me towards writing the right query. Now, let me change that to the right value. That is type var, and the query is implemented. Now, if we want to check that that's actually the right query, returns the results I expect, with one click, I can jump into the console and run it there.
Wow, it's like having a mentor sitting right next to you, helping you out. It's a really great way to streamline application development. But I'm pretty sure I saw another pop-up back there. Can you go back to Trip Repository and take a check for the insight?
Yeah, let me see that. Oh, yeah, you're right. The IntelliJ is actually telling me that the query we implemented is running without an index. that is a very important warning, because if I don't create an index for this query, there's the risk that I deploy my application in production and I see some performance problems. And because making choices about indexes and schema in the early stages of building a scalable application is so important, you can expect that over time, we'll add more and more of these tips inside your IDE.
Which will be really helpful. Thank you so much, Max. As you can see, we're obsessed with accelerating developer velocity and efficiency. With these tools, we shorten the feedback loop during development and testing with the convenience of local environments for Atlas. We make queries and aggregations extremely easy to write and to troubleshoot with the Copilot-assisted development, and we speed up application development workflows by supporting developers right where you're working without that expensive context switching. Max and I, along with our entire team, are so excited to bring everything that you need to develop high-quality, data-driven applications on MongoDB right next to your code, right where you're working, truly accelerating developer experience. Back to you, Sahir.
Thank you, Max and Melissa. It was awesome to see those cool demos and how we're focused on empowering our developer community. Beyond providing developers with powerful tools to drive efficiency and productivity like you saw, we know there's immense pressure to also build AI-powered applications, to build the next generation of great applications. Therefore, we've been really focused over the last 2 years on ways to simplify this process. One of the principal ways we've been doing this is by extending the database and the document model natively to handle vectors. Vectors serve a unique purpose in AI applications. They allow you to create multi-dimensional representations of unstructured data, text, audio, video, images, which in fact account for 70% of the world's information. The power of AI embedding models allow you to create vectors from this unstructured data and make it understandable to application code. From there, you can leverage semantic search to find related and similar items based on their meaning, or employ a RAG architecture using the power of foundational LLMs to augment your proprietary enterprise data and create a compelling new AI-powered feature or application. Until now, developers have had two basic approaches for incorporating this capability into their stack. The first is to use a standalone vector database. There are dozens of options that have sprouted up over the last couple of years. Obviously, they give you the ability to store and query vectors. That's what they've been designed to do. But it's just vectors. You're missing the operational data, the metadata, the full-text search capabilities, et cetera, that are all critical for building an end-to-end application experience, which just means this introduces the additional burden of maintaining yet another niche component in your stack. So others choose an alternative path, which is to use a database that's integrated vector capabilities right into the core. This sounds encouraging on the surface, but the challenge with this approach, with all the offerings out there, is that it co-locates the vector workloads with your operational workloads. So your vector queries end up fighting for resources with your core operational queries. With MongoDB, we give you the best of both approaches and avoid those trade-offs. We brought powerful vector capabilities natively into the document model. We wrapped it in an elegant user experience, our query language and our drivers. And we also provide the capability to scale your vector and operational workloads separately, allowing you to independently optimize price and performance and isolate those workloads. Today, we're very excited to announce the GA of quantization in MongoDB Atlas Vector Search. This is yet another way we are optimizing our vector capabilities. Storing and searching through billions of vectors can be computationally expensive. Traditional methods using full precision vectors often lead to high in-memory storage costs and sometimes slower query times. This hinders the scalability and performance of vector-based applications, making it difficult to handle complex and large-scale requirements typically seen as applications go to large-scale production. This is where quantization comes in. It's a technique that compresses vectors for efficient storage while preserving their semantic similarity. This will significantly reduce memory and storage costs without negatively impacting the quality of the results from queries. Now, it's been amazing to receive industry recognition for our work in this space. We are honored that Atlas Vector Search has recently been named the most loved vector database for the second time in a row in Retool's State of AI report. But the most important validation comes from the incredible customer demand we've seen. Atlas Vector Search is the fastest adopted service we've ever built. It's used by companies ranging from innovative startups all the way to global enterprise brands. And customers in highly regulated industries are powering their AI applications with MongoDB, like the leading pharmaceutical company, Novo Nordisk. We're excited to be able to share some of the amazing work that they've done. Let's take a look.
We are all working towards the same goal of being more digitalized all around the pharmaceutical industry. We want to improve our efficiency and reach the patient faster with the products that we produce.
A major part of our digitalization is to increase the quality of the documents and produce them faster so we can get them submitted to authorities as quickly as possible. So now we've managed to go down from 12 weeks to 10 minutes to produce each document.
Automation is a way to free up time for people to do complicated things that need thought. So we should leave the tedious manual task to a computer. This is a first in industry thing that we achieved here. Together, in the collaboration with MongoDB, we developed something that hasn't been there before.
Apologies. Now, I am super excited to welcome Digitalization Strategy Lead Wahid Jawia, who you saw in the video, and Technology Lead Tobias Kropelin, along with Graham Siemens, Area Vice President MongoDB. They're going to get into the details of how we empowered Novo to build such an amazing use case. Take it away, guys.
Thank you, Sahir, and thanks, Wahid and Tobias, for speaking with us today. As Sahir mentioned, Novo Nordisk is a leading pharmaceutical company. They're headquartered out in Denmark and have over 70,000 employees globally. Now, as we all probably can understand, the pharmaceutical industry is highly regulated. Right? It takes months to prepare paperwork to support new drug therapy. It results in really high-stake business and getting data accurate. The filings go to the FDA, they go to the EMA, and represent billions of dollars in R&D. So Wahid, it'd be great if you can spend some time helping us understand that process a little bit more and how it's worked historically.
Yeah, sure. So in the pharmaceutical industry, we produce a lot of documentation. And for any new drug product to get market authorization, we have to produce something that's called the Common Technical Dossier. And it consists of somewhere in between 500 to 1,000 documents, anywhere ranging up to 10 million pages in total. And one of the key documents in that dossier is the clinical study report, which is the use case that we were talking about in the video. And this document takes anywhere between 12 to 15 weeks to complete. It requires a lot of resourcing. We generally produce somewhere between 60 to 90 of these documents a year, and it can take around 50 medical writers to complete all of those documents.
Wow, so a single document out of the 500,
yeah.
Right? And you do 90 of those a year. So, I mean, this process has been around for a really long time. What are some of the challenges that you guys are facing when you thought about how do we address this issue from being 12 to 15 weeks to complete one of those?
Yeah, so I mean, it's very challenging because the underlying data that we are using to create these documents is not necessarily delivered to us in a structured way. I think something that's been mentioned consistently throughout the other talks before. And from our perspective, we wanted to bring automation to this document because myself and one of my other colleagues who's also here, Louisa, we were actually in charge of a clinical submission for a new drug product. So we looked at the CSR as a core component of that, and we really wanted to kind of bring some automation to that.
Interesting. So what happened? I mean, how did you guys come about this idea of making a change?
Yeah. So that's an interesting story, actually. So the way it actually happened was I ended up having a discussion with one of our technical people to say, look, we want to automate the CSR. We have some ideas around that. And it was kind of pushed to the side. It was like, this is too much of a big task. It's going to require a huge infrastructure change, and we don't want to do that. So, but we're quite persistent and determined, right? So It's actually, I met up for dinner with Tobias actually that same day. And we kind of talked it through.
Wasn't it around COVID, right? Was it even allowed? It was around COVID, wasn't it?
Yeah, it was actually. Yeah, it was just towards the end of the final lockdown that we had. And I was actually walking to his to get a pizza. So we thought we'd sit down and kind of...
some person around.
Yeah. But we kind of said that I think the way people are looking at it is wrong. So we said, you know, if you take the document and let's split it out into different components. So the descriptions of the data as a different component, the actual tables, figures, listings, hyperlinks, cross-references, all of that as different components, and then look to iteratively bring automation to those individual parts. And then we kind of settled on a plan and started working on a very, very crude POC to start with.
Yeah, I think that POC was fundamented by a database that was called Microsoft Excel, right?
Yeah, exactly.
So at some point you had to scale. What made you decide to work with Mongo? I don't think you guys had that much experience with it before.
No, we didn't have much experience with it. And in general, in the pharma industry, we have a lot of experience with SQL databases. So we have 30 years of history, SAS analyzed. But we wanted to scale fast, and we wanted to have the best technology to support our use case. So we experimented, from Excel to graph databases. And it turned out that the document model was exactly what we were looking for. It's scalable, it's easy to work with, and it can scale into the unknown because we will onboard documents we don't yet know about. And the flexibility of the model will help us with that.
Right, so the two of you come up with an idea, you find MongoDB, and now you have to take this up against, the industry, which has never been really done this before, especially using Mongo. What type of cultural challenges did you face trying to bring in a new technology?
Yeah, so I think that was probably one of the biggest hurdles. So in the pharma industry, if you look at it in general, it's quite a technically conservative or technology conservative industry.
Yeah.
And there's a load of incumbent vendors that have been providing solutions for the last 10, 15 years. And they're kind of the standard, as Tobias said, the standard SQL and relational databases and things like that. And they haven't really been able to deliver the value, to be honest. So we wanted to do something different. We looked outside of our industry and really saw that Mongo was delivering the value and giving us the facility that we needed. But that required that we took those discussions then with the IT part of organizations to say, look, we really see the value here. We ran some tests with some of the guys that work in Denmark from Mongo, and we were able to show that, look, if we proceed with Mongo, we can really, really see value generation very, very quickly.
Yeah, I mean, these are billion-dollar tests, right? So you're spending so much money on it. Maybe you could talk about some of the savings that you materially saw with MongoDB.
Yeah. So the savings from a developer perspective is you just develop faster. You have a managed database, so you don't need to care for that. The document model is really easy to understand. So we have technical people as well as non-tech people interacting with the database. All of them can understand it. And it really helps in development if you have the computer-readable part, your vectors, all the metadata that are around that helping the content team, all in one view. It helps a lot if you don't need to join and think about where do I find what parts. So it speeds up development and iteration a lot.
And I think also from when we're talking about value specifically, I think there's also, if we look at just the hard numbers, right? I mean, we've been able to take down the authoring time of the CSR from 12 to 15 weeks down to 10 minutes. In terms of the resources that we're now using, so instead of that 50 resource count that you would need to write those documents, we have 3. So we have 3 really non-technical people that are able to interact with Mongo, use our tool, NovoScribe, and part of that is the Mongo Compass allows even non-technical people to interact with the database. So we've really seen a huge value generation in terms of that.
Yeah, so you've gone from 40 to 50 people down to 3. And then what was a 12 to 15 week process down to 10 to 15 minutes. That's really amazing. With a team that historically had never really had exposure to MongoDB or used it before, right? Even non-technical users.
Yeah, no, our tech team, in the beginning we thought we need to find people with long experience in MongoDB, but onboarding new developers, we saw they just pick it up. It's not that complicated.
It's really that easy, huh? No, that's really, really amazing. So when you think about the complexity of these documents, and you think about how many different types of data that you have to manage to go into those, could you talk about what that looks like and how do you manage that with Mongo?
Yeah, so I mean, in terms of if we look across that dossier that we're talking about, I mean, these documents can range from anywhere from kind of some interactions with a healthcare practitioner all the way down to individual listings on a patient suffering an adverse event. And in terms of how that data is collected, that also varies widely, right? So we get stuff in Excel sheets, TXT files, PDFs, SharePoint sites, you name it, we kind of get it. And I think using Mongo has really helped us structure that information and enable us to use it specifically when we're deploying some of the Gen AI models on that data. I think probably Tobias has got a more of an insight into that than I have.
Yeah, so, so the advantage in the use of generative AI, obviously, we are in text creation, so you obviously look into that direction. And it just works very simple. You have your vector databases, and all of our documents are very different. So we can make our database fit the documents, and we will be able to read thousands of them and generate new knowledge and information, or see these documents in context. I can't read all of these, but I can get the summary of my model, and I can make use of the output that is generated in this way.
Yeah, I imagine one of the big fears was how many different types of data were coming into these documents, right? Because it's coming from really, really complex tests that are actually evolving as well. So when you have a platform like Mongo, being able to leverage any type of data has made that really easy for you guys, right?
Yes.
Now, could you talk a little bit about and we're all curious about Gen AI, right? And you guys have used that and are starting to use that in a really, really aggressive way. Could you talk about some of the advantages you're seeing and maybe the role of Gen AI?
Yeah, so where we've really seen the role of Gen AI really help us is specifically in terms of scaling. So when you're looking at that idea around reducing 50 people down to 3, that's a lot of the heavy lifting in terms of the work that's being done by the generative AI models. And also in terms of when we're looking at onboarding new documents, the information that we're able to extract out of our historical documents using and providing some context to those using generative AI is really, really useful when we're expanding the scope of the tool.
Right. And from a technical perspective, right, using things like Bedrock and vector search, and it's kind of evolving for you as well, right?
Yeah, so it works really great in supporting and guardrailing our use of AI. As we know in our industry, we can't make mistakes. and Bedrock and well-done RAG with the right guardrails, while having the right data as corpus for the information stored in your MongoDB, makes this a really, really smooth process.
Yeah. Well, so this is one document out of 500. This is kind of now the early stage in the journey, and you've got all the fame internally. So what are the next steps for you guys? How do you see this really evolving for Novo Nordisk?
Yeah, I mean, we've already started to expand across the value chain. So we work in the development part of the organization, but we are already working on cases in the devices part of our organization, the product supply part of our organization. We're also starting to develop educational material for healthcare practitioners using the exact same system. So there's a huge scope for that, and I think we've really been encouraged and pushed by our executive management to now look across the value chain versus just taking that old traditional siloed view of saying, look at the area that you're in now. So we really see the future of the tool and everything that we're doing really expanding over the next couple of years.
I think we realized that we did not just develop a tool that can write a CSR. We created a tool with which we can fuse text and data in a structured way to write a high-quality document.
Yeah, listen, it's really inspiring, right? You took a really complex problem that's been around for a very long time that culturally had challenges, as well as just the regulations in that as well. And you've done something that's transforming the industry. So congrats, it's amazing. Thank you so much for sharing the story with us today. And they'll be around if you guys want to pick their brain a little bit.
Thank you.
Thanks for having us.
See here.
Thank you, Tobias, Wahid, and Graham. What an amazing high ROI real-world outcome. Our hope is to help all of you figure out a way to apply AI to these types of use cases that truly deliver value. Now, for those of you who are not on Atlas, I am thrilled to announce that we're going to bring that powerful capability of Atlas Search and Vector Search to MongoDB Community Edition. We are putting these key features in the hands of developers right from in the inception of their development journey, being able to run wherever you need, locally on a development system or on premises. Please stay tuned for more details around the work we're doing here early next year. Now, in order to address the broader needs of our customers, we developed a new program, the MongoDB AI Applications Program. We are working with leading partners across every layer of the AI stack to provide technology and expertise that you need to help build and safely deploy modern AI-enriched applications at enterprise scale. With MAP, we offer technical expertise to help build apps quickly, safely, and cost-effectively. We have pre-built sets of integrations with vetted AI and cloud partners, and a set of validated reference architectures for a variety of different use cases. In fact, today we released a new use case in collaboration with Anthropic and AWS focused on applying Gen AI to improve the efficiency of customer call centers. Only MongoDB brings together integrations with such an elite and open group of AI partners, including all 3 major cloud providers and the leading model development labs. You can find all the details on how to get started right on our website, mongodb.com. So, we've covered 2 of the 3 key priorities that you, our customers, have identified as crucial to your success in building applications that will truly differentiate your business. But for many of you, especially large organizations, application modernization is the most essential, yet the most challenging. We know that many of you are surrounded by a massive number of legacy applications that were built decades ago. To be fair, these applications serve a purpose in your organization, otherwise they wouldn't still be around. But as these applications age, it becomes a situation of diminishing returns. There's an increasing cost to maintaining an outdated tech stack. You may not even be able to get support or even security patches for end-of-life technologies. The knowledge, the skills of the people that built these applications may have left the team or even the company. Plus, these legacy technology stacks constrain your ability to innovate. They weren't made for today's modern requirements. Can you imagine trying to incorporate capabilities from like AI into a 20-year-old application running on a 40-year-old database? It just sounds ridiculous. And that's not the end of the story. None of this would be an issue if modernizing these applications was simple, but it's not. Taking systems offline is not an easy operation, and in many cases, it's not even an option. You have to line up a team and plan and execute an end-to-end overhaul of the application, which is extremely resource-intensive. Your team may not even have the skills or expertise in the old technology, so you may have to engage armies of consultants that cost millions of dollars and years of effort just to modernize a few applications. Plus, there's the opportunity costs. What else could you be doing with these resources in that time? You're stuck between a rock and a hard place. You have the cost and complexity of not modernizing on one hand, yet a different set of costs, complexity, and risk when you attempt to modernize. So what do many organizations do? They do nothing. They defer and begrudgingly accept this status quo. We believe this is an untenable situation. The reality is that delaying is no longer an option. And so we've been working hard on this challenge for you for years. Last year, we were excited to announce the general availability of Relational Migrator. It focuses on the database migration aspect of a legacy transformation. It helps with schema and data modeling, which makes it easier to figure out how to get your data out of a relational database structure into neatly mapped document structures. It then tackles data migration, which replicates the actual information from relational database systems like Oracle, MySQL, SQL Server, or even Postgres, and moves it easily to MongoDB, whether that's in Atlas or on-premises. During this migration, Relational Migrator translates the existing rows and tables into the document schema and ensures consistency from the source to the target. Right here in London last year, we introduced the ability to actually convert queries as well, taking SQL queries and turning them into MongoDB. Many teams are faced with hundreds of these queries, if not thousands, to convert as part of a complex migration. And so we started leveraging LLMs to take SQL queries and auto-generate MongoDB queries that match at scale. We expanded this to tackle stored procedures as well, by extracting those from your existing database and converting them to new code. Now, as part of our work on this feature, we saw firsthand how AI can simplify migration tasks. We were so encouraged by what we saw that we started experimenting and exploring how AI could help with other parts of the modernization process, moving beyond just the database and into the application code itself. We started first with application analysis, where we can use LLMs to analyze a legacy code base in order to understand its structure, its business logic, eliminating the need to get input from the original developers who have often moved on. We then expanded to test generation. We found that many of these existing applications don't even have tests in place. So we were able to auto-generate tests based on the live interaction of the application in production and generate functional and unit tests from that. And finally, we focused on code refactoring and conversion to automate the creation of microservices by breaking apart functionality from your existing monolith. After running some experiments, we took this to a couple key customers, applying AI to all aspects of their modernization problem on real-world applications. We had a hunch this could be really impressive, but the results have been astounding. We were super excited to partner with Bendigo and Adelaide Bank down in Australia as one of our pilot customers for this program. They help over 2.5 million customers achieve their financial goals. And we worked with them on an application called the Agent Delivery System. This is a teller application that's used in agent branches within non-banking businesses. So think of news agents and pharmacies across rural Australia. By working together on this application modernization project, we were able to accelerate the time necessary to modernize this app by 90%. We did a clock time study versus a manual approach, and at 1/10 the cost of what it would take to typically modernize. We've taken our products, tools, and processes and established a dedicated team here at MongoDB focused on guiding customers through these modernization journeys. Our goal is straightforward. It's to help you move off your legacy applications more quickly, with less people and manual effort, and requiring fewer specialized skills. And of course, MongoDB is supporting these types of applications for years, but now with generative AI, we're able to bring new levels of automation to the process, unlocking opportunities to tackle applications that were just previously out of reach. It was too expensive, too costly, took too much time. And now we're going to continue to invest in this area aggressively to help even more of you find this type of repeatable and scalable success we've seen at customers such as Bendigo. We invite you to download Relational Migrator. It'll help you get started at the data layer, or you can reach out to your MongoDB account teams to learn more about how we can help with that end-to-end modernization process. So we've covered a lot of ground this morning, but our products and technology are not the end of the story. We truly want to be partners with you no matter where you are in your journey. When you choose MongoDB, you join a global network of innovators building the next generation of transformative software. Our MongoDB community champions, many of whom are in the audience today, are experts on our platform and dedicated to helping you push the boundaries of how to use MongoDB. And our investment in education is woven into the culture and fabric of who we are as a company. We're so proud that right here in the UK alone, there are over 160,000 technology professionals who have listed MongoDB as a skill on their LinkedIn profiles, and it's growing. MongoDB University is our unique offering designed to help you get the most out of your experience with us. It features content crafted by experts, ensuring you can sharpen your skills and make the most of our latest releases. Whatever your level of expertise, our curriculum meets you where you are, with free self-paced courses, interactive labs, and comprehensive certifications. Our program adapts to your style. It adapts to your schedule, making learning truly accessible. And today, we're introducing 2 new Gen AI badges as well to help you get started with the latest capabilities, some of which you heard about today. And as a little bonus announcement, the rumors are true. We are rolling out dark mode to our documentation. It went out last week. We got a lot of feedback on this. You can thank us later. I don't need to tell you all how fast technology is changing around us. None of us can ignore how the advancements like AI are driving us rapidly into the next platform shift. One could be massive, as impactful as the birth of the internet, or connected networking, or the cloud, massive platform shifts. In this new era, developer acceleration isn't just a nice to have or a benefit, it's a necessity. It removes friction, provides the tools, giving engineers more freedom to create and innovate, as opposed to deal with plumbing. Building AI-powered applications will drive value and differentiation for your business. We heard a great example just now. And it allows you to create and leverage your organization's unique data in ever more dynamic ways. And of course, modernizing off legacy architecture means you are no longer anchored in the past, saddled with unnecessary complexity and cost. It's not just a technical upgrade. It's an essential evolution, one that gives you the ability to nimbly navigate the rapidly changing landscape around us and to respond to whatever the business brings you. The companies that create truly transformative software will win. Those that will be frankly just left behind. It's that simple. We are honored to be partners with you, supporting as you innovate and create these amazing new experiences. Experiences that will drive your professional growth and your company's success. We are amazing to see such a great turnout. Please learn from your peers. There are many MongoDB employees here. We're eager to hear your feedback. So enjoy the event. There's a ton of knowledge to be had and hopefully a little bit of fun as well. Thank you for joining us today.
Hello and welcome to the show floor here at MongoDB.local London. I'm Shane McAllister, I'm on the developer relations team, and after that amazing keynote, we're going to spend today following up on many of the key announcements during that keynote with individual speakers and guests throughout the day. So we're really delighted to have you all join us on YouTube and LinkedIn. Stay tuned all the way through to 5 p.m. or 4:30 p.m. this evening on YouTube and LinkedIn as much as possible. As you can see behind me, we're on the Expo floor. We have all of our partners here. We have many of the areas of MongoDB, our product, our community, our university, and we've got lightning stages left and right as well too. So it's going to be super busy. You're going to see a lot of action. But for those of you that couldn't join us in person, we're delighted to welcome you on board this stream. If you're not familiar with a .local, what is it? Well, MongoDB heads out into our community to bring our latest announcements and activities to our developer community globally. We used to only do this in a couple of cities, but now we're bringing it to over 20 cities worldwide. And today, we're in London. Here, you're going to discover the latest releases, the latest product announcements, get a sneak peek on everything that's coming out as well too, and explore powerful new ways to maximize the possibilities with MongoDB. We're going to be able to meet some experts joining us on the live stream as well, and fellow users and champions and clients and partners as well too. So look forward to some exciting talks as we make our way through the day. Coming up, we want to talk a little bit more about MongoDB 8.0. But first of all, as a recap to everything that Zahir, Genevieve, Tyler, Max, Melissa talked about on stage, we talked about developer accelerations, stream processing, the Atlas CLI, search and vector search in particular with a great demo by Max, and our VS Copilot integration. So we're going to discuss all of these as we make our way through the day. Indeed, we can't get away from AI applications. We're going to double down on a lot of what we're doing there. MongoDB vector search and the case studies, and indeed the map program that was also, we announced at .local New York back in May, and we're doubling down on the work and efforts that we do there. Application modernization was another key aspect of what we went through in the keynote, and there's lots to come on that. But the real announcement for us was 8.0, general availability of 8.0, and I want to dive a little bit more into that. So I'm really delighted to be joined by Garudi, Director of Product Management. And Garudi, welcome to the MongoDB live stream.
Hey Shane, how's it going?
Good. Before we dig into the details of what was announced in 8.0, tell us a little bit about your role in MongoDB and what's the day-to-day entail for you.
Yeah, sure. So I am a newly promoted Director of Product Management. I'm on the core database.
Okay.
So on the core database, I focus on the engine part, basically making sure that MongoDB is reliable and scalable. And a lot of the focus is making sure that the stability is there, that the scalability is there, that anyone that wants to run MongoDB, that the database is able to support the needs of their application. And so from that standpoint, it's about figuring out, what are our most pressing problems or biggest problems that are getting in the way of developers just basically building their app, making sure that the database can support that app. And so all the problems there and trying to figure out which ones to solve and how to solve them, et cetera.
Excellent. I am in awe of the people who work on the core database. I mean, I'm in MongoDB, I'm on the developer relations team, I use Atlas all the time, but to work on the core of it, the behind, under the hood stuff, it's incredible. How is that in terms of scale and the testing and the resiliency and everything else that you need to be careful when you're rolling out new features in the core database?
Yeah, so one challenge, with that is any little change you make, you need to thoroughly test. You need to also test it over a long time. For example, you might see an improvement over a day, but over a week, the output looks a lot different, over a month even. And so there we got to be a lot more conservative and more careful in terms of what we really do in the database there. And so that's one thing that's different, I think, than certain areas. So basically, our time for development is a lot longer. And so the opportunity cost of building the wrong thing is a lot higher in the core database. So you need to spend a lot more time making sure you have the right setups, the right testing, and so on, to make sure you capture the things you're trying to do. But not only that, we spend a lot more time doing research and making sure that we're tackling the right problem, like I said, because it takes, multiple months, sometimes even a year or two sometimes to solve certain problems. You can't afford to get those wrong. Otherwise, you're talking about 2-3 releases sometimes.
So we heard Sahir in the keynote talk about 8.0 as the best version of MongoDB to date. Talk to me a little bit about the key improvements that we've made in 8.0 that are now available to everybody.
Sure. I think we made a lot of innovation there, but to me, there are 4 major areas that we spent a lot of time on. The first one was performance. I think really we probably put half our team at some point on just performance, so that's what we spent a lot of time. We wanted to make sure that MongoDB 8.0 was at least as fast as 4.4 and preferably the fastest MongoDB ever. Wow. We're still doing final tests to make sure that we can make that claim. But in my heart, I believe that statement is true.
Good.
That's the first part. And then also, we spent a lot of time on what we call resilience, or what I call workload management. And so this is making sure that no matter what you throw at the database, no matter what kind of scale you throw at it, if you have a spike in workload or an increase in workload because your application got a lot more popular and folks are starting to show up and so on, that the database can handle that it doesn't go down easily whenever you throw more load at it. That's the second part we spent a lot of time on. A third part was around scalability. Especially, we did some improvements in vertical scaling, but that works pretty well out of the box. So we spent a lot of time making horizontal scaling more accessible to a lot of folks. And so reducing the barrier to entry there, whether it's making it cheaper, making it less complex, and also making sure that once you're there that you can scale a lot faster. Those are some of the things we spend there on scalability. And then we also spend some time on security, making sure that you have end-to-end encryption, if that makes sense. So making sure that once your database is there and it's scalable, that it's also safe at all times. And so not just at rest, but in transit, but also on the database, if that makes sense. Those are the 4 major areas I think we spent a lot of time on for 8.0. And I think with all the changes that we've made there, we can call it the best release ever because of that.
Excellent. So from a day-to-day perspective, as a developer using MongoDB, what would they expect in 8.0? We do a lot of, it's our developer data platform. A lot of what you've described to me there, Garudi, is stuff that will just happen automatically in the background. Better performance, better speed, easier to do certain tasks. So will a developer see this, or will they just have less headaches in their day-to-day workflow?
Yeah, and so from our standpoint, I think whether you see it or not, our goal is for you not to see it, as in don't notice us. It's kind of like a car's engine. If it's working fine, you don't have a problem. You don't notice when your lights go out until the second light goes out, for example. And so our job is to get out of your way. MongoDB's popularity is about being a developer, friendly data platform. And so what that means is you want to spend your time developing and less, fixing issues on a database. And so our main goal is to make sure we're not there, right? And the other part, the things that you will notice is, for example, if you want to scale, now you'll see how much faster it is. But all of that is all going towards being a magical thing that just happens and you don't have to even know about it, right? And so our long-term goal is to basically get out of your way and everything happens magically under the hood. And the only time you notice something is if you're looking for it. Otherwise, we're out of your way. So I'm perfectly happy with what we're trying to achieve there, being invisible and not being seen.
Right.
I think that if you ping us, that usually means there's a problem. And so yes, our entire goal is to make sure that you're focused strictly on development and not necessarily that you notice what's going on in the engine.
Okay, and I can imagine how much of the work that you do in this area is informed by feedback from developers, and how do you get that feedback from our wider developer community? In what ways do you get it? Is it through the support tickets? Is it through the forums? Is it talking face-to-face with developers who are using MongoDB at scale?
Yeah, I would say all of the above. I think that the beauty about feedback is that doesn't matter where you get it or almost how you get it, as long as you get it. And so there's a part where you have to filter through it and figure out, okay, what's actionable. So sometimes you'll look at support tickets, but a lot of times you always need to talk to folks.
Sure.
In product management, if you're not talking to someone about what they're experiencing, then you're not doing your job well. And so even when we go through support cases, or we get information from a lot of field folks, whether it's support, whether it's consulting engineers, whether it's solutions architects that are trying to pitch MongoDB, any issues that they run into, they bring back to us. So it's always good to go back to the primary source, the customer and the developer, and talk to them about what issues they ran into. And so you try to take that, you try to aggregate it, and try to see, okay, what are the minimum things I can do to basically do a sweeping pass and help as many folks as possible. So it's about how prevalent is that pain, how deep is that pain, basically how much harder does it make your life, the fact that this problem exists.
Yes.
So we always have to talk to developers and sort of understand what they're going through to make sure that we fix problems that are in their way right now that are stopping them from just essentially developing code.
And I would imagine with the extent of our developer community, it could be quite hard to maybe prioritize this feedback, prioritize the feature requests, etc. How is that done within the organization and the team that you're involved in?
Yeah, so it probably varies by product manager, by team, etc. But to me, the first part is being able to aggregate that feedback. And so that's why I say talk to as many people as possible, get as much context as possible, make sure you ask the right questions so you truly understand end-to-end what their problem is. So for us, we try to live in the problem space to try to understand what they're going through. And then from there, it depends. Some people use certain methods, like RICE prioritization framework. Myself, it's all about, what are the needle-moving things we can do. So there are certain problems, once you make it go away, it's very drastic and very visible that it's gone, right? If a car is shaking when it's going, past 80 miles an hour, or whatever, 60 kilometers, let's say, an hour, making that shake go away, might be more important than letting you go to, 100 miles an hour, for example. And so to us, we try to basically find what is the biggest, most important problems that we see? What are the ones we see most in common? What do they have in common? So the more people you talk to, the more you get anecdotes, the more you can sort of aggregate the data. And then we also have obviously data that we track in the data warehouse of how people use it, for example, on Atlas, and try to find how many people have that problem, right? So once you talk to about 8 to 10 people per problem, you can get a general sense of what the issue is. And so what you try to understand is, okay, if I do this, how much of an impact will it have? How many people? And so my method is always about trying to understand, how many people will it help and how badly will it help them, right? And see how much of a problem really is this. Also, do they have workarounds or not, right? Is this a thing that they can avoid? If you need a car to go to work, for example, then you cannot say take the train, not always for everyone. And so for there, okay, well, we might have to fix this issue because it's getting in the way of your system operating well. And so that's how I try to think about that when I'm solving problems.
And when you've released 8.0, for example, all of this feedback that you've gathered from, do you close the loop with the people who've raised these requests and go, hey, do you know what? We've now fixed that. We've improved that. It's faster. It's more scalable. It works better. Does that loop get closed, or is it just a constant iteration of working through those? Yeah, so the loop does get closed through a lot of ways. Sometimes, whether it's if they have customer success, to talk to them about it. They have presenters, solutions architects, and so on. Sometimes support saying, hey, your issue has gone away. I also close the loop. A lot of times, though, for me, it's more about continuous feedback. Yes. Sometimes what you build isn't quite there, and so you need a second cycle feedback to understand what's left, or did we solve it properly? Oh, maybe we missed here, this thing here. Sometimes you solve the problem and someone's like, well, it wasn't that big of a deal. So getting that kind of feedback is also very important. So there's always a continuous feedback cycle that's there. So it's not strictly about closing the loop, letting you know, hey, I solved your problem. That's part of it. You want to make sure that those folks that wanted it know, but they'll usually find out anyways. But it's more about making sure that you confirm that you did what you were set out to do, and that if there's anything missing or if they're happy with the solution that's provided. Perfect. So we went to yearly releases roughly of Atlas a while back. So 8.0 is out now, and any band releasing its record, for example, you've got to work on the next one. So how soon does 9.0 work start? So that's a 9.0 work already started, first of all. I think the question is, when will 9.0 come out? Yep. And I think that part is more a function of what we want to put in it, what do we want to say about the database. So whether that's 9 months or a year and a half or 2 years even, I think it will depend. I think that's what we're debating. I think the idea of just releasing every year at the exact 12-month mark, just to say we did it, we're trying to move away from that. Now we want to make sure that
whatever version of the database we release next, it's something that we're proud of and we can actually speak about. And so I think, with that said, TBD what the actual timeline will be for 9.0, but we've already started working on some improvements there. It's just a matter of how many things we want to put in there and what do we want to say about it. What is the identity of the release? So that will determine when it comes out, if that makes sense.
Excellent. Well, look, 8.0 on general availability now. You're saying the team don't get to rest. They're always moving. Of course. But for now, Garudi, thank you so much for joining us on the live stream.
Always.
Giving us a preview. I know you're talking later here at the show, but for everybody else joining us on the live stream, if you want to check out 8.0 right now, you can get at it straight away. Do join us in a few more minutes where we'll have another great guest, and keep tuned all throughout the day. For now, Garudi, thank you so much.
Thank you.
Enabling semantic search on user-specific data is a multi-step process that includes loading, transforming, embedding, and storing data before it can be queried. Now that graphic is from the team over at LangChain, whose goal is to provide a set of utilities to greatly simplify this process. In this tutorial, we're going to walk through each of these steps using MongoDB Atlas as our vector store, and we're going to use the AT&T Wikipedia page as our data source. We'll then use libraries from LangChain to load, transform, embed, and store our vectors, and then we can retrieve and query relevant data. To get started, you'll need a free MongoDB Atlas account and an OpenAI API key. And today we're going to be using Python, but this can also be accomplished using JavaScript and Node.js. First, we're going to clone a repo that has all of the code written for us to get started. And a link to this repo is in the video description below. So I'm going to go over to Code and copy the link. In VS Code, let's clone this repository. I'll select my location and open this up. The first thing we need to do is open params.py, and we'll add our OpenAI API key and our MongoDB connection string in these spots, and then save it. Now let's open up the terminal, and we're going to create a new Python environment. And let's activate the environment, and we'll install all of the requirements. Now we're ready to vectorize our data. We'll load it, transform it, embed it, and store it. And again, we're going to use the AT&T Wikipedia site as our data source, but there's no lack of sources of data. It could be Slack, YouTube, Git, Excel, PDFs, Markdown files, etc. And LangChain provides a growing list of integrations for these sources. So let's take a look at the vectorize.py file. The first thing that we're doing is loading our data, and here we're using the web-based loader that we're importing from LangChain. And in this loader, we are pointing to the AT&T Wikipedia site. And we can also load multiple sources like we're doing here with the Bank of America Wikipedia page as well. And next, we'll transform the data by splitting it. Now, it needs to be split into smaller chunks so that we can easily find relevant portions based on our search query. Now, for this example, we'll use the recommended recursive character text splitter, which again, we are importing up here from LangChain. To make this formatting look a little bit better, here we have our chunk size of 1,000. So that's 1,000 characters. We have an overlap of 0, and our separators. This is going to attempt to split on paragraphs with the 2 new line characters, the 1 new line character, and then sentences and words. So if a paragraph doesn't fit into 1,000 characters, it's going to truncate at the next word that it can find that will fit within that chunk size of under 1,000 characters. And you can tune the chunk size to your liking. Smaller numbers will lead to more documents and vice versa. Now next is the embedding. Embedding is the process of creating vector representations of data using an LLM. And there are many options to choose from, such as OpenAI and Hugging Face, and LangChain provides a standard interface for interacting with all of these. So here we're going to use the popular OpenAI embeddings. Now again, be sure you have your OpenAI API key set in the params.py file. And now that we have the embedder loaded, let's store our vectors and data. Now you will need a vector database to store your embeddings, and fortunately for you, MongoDB is perfect for storing vector embeddings. And even better, the folks at LangChain have a MongoDB Atlas module that will do all of the heavy lifting for you. Again, don't forget to also add your MongoDB Atlas connection string to the params.py file. So here we're going to connect our Mongo client, get our collection, We'll go ahead and clear out the collection if there's anything there. And then this is the MongoDB Atlas vector search method from LangChain that we are importing at the top here. So in this, we're going to pass our docs, our embeddings, our collection, and our index name. And we only need to run this file once per data source. So let's go ahead and run it. So back in the terminal, let's run Python vectorize. All right, it split it into 288 documents. Let's go over to MongoDB Atlas and check it out. So in our database, let's go to Browse Collections. And we can see that a database search DB was created, a collection search collection, and we have all of these documents. So each of these has the original text chunk along with the vector embedding.
I was the one that dealt with the old Dave Allen. Yeah. Apparently I was the only one smart enough.
Hey, I'm here, Matt Acey, with Peter Ulander, my boss. If you're looking at the screen and you're wondering why this guy doesn't look like Scott Sanchez, don't worry. He doesn't know why he doesn't look like Scott Sanchez either. Peter's been on the road for so long that he has no idea what time zone he's in.
Very true.
Or even who he is anymore.
Very true.
But Peter is MongoDB's CMO, and I was actually really glad that I got the chance to talk with him. And I wanted to ask him a little bit about 8.0, and then I have some other questions. So, Peter, why should a developer care about MongoDB 8.0?
8.0, sure. So, I think the most exciting thing about 8.0 is this is the best performing database we've ever come out with, right? When you look at the price performance, the speed, all of the new capabilities and what it's bringing to customers, we put in a relentless focus on security, scalability, resiliency, et cetera. But I think the bigger thing is looking at how we kind of reinvented the control plane so we could actually drive extreme performance out of the platform while reducing costs for customers. It makes so much sense for developers to be more interested in this platform than anything that came before.
So that's for, if I'm a MongoDB developer, what I'm hearing is 8.0, better performance, better security, etc. Awesome. But many developers have yet to experience MongoDB. Why should some random developer, I shouldn't say it that way, why should some developer who's not at this conference right now,
sure.
She's down doing her job at Vodafone or someplace else, why should she care about MongoDB?
Yeah.
Isn't it just a NoSQL database?
So, you know, it's funny. So I've been CMO now for what, 3 years? And I still remember before I joined Mongo, in my own mind, MongoDB was a really cool NoSQL document-oriented database, open source, awesome, niche for specific types of web apps or what have you. I think coming in and actually seeing just the breadth and depth of workloads that our customers are building on top of our platform. I mean, just on stage 15 minutes ago, we had Novo Nordisk talking about how this basically accelerates the way that they can bring new medicines, life-changing medicines to the market on top of MongoDB, right? You think about the play we have across all of the financial institutions. You always hear is it secure enough? Can it do asset transactions? All of that other stuff. And the reality is, 9 out of 10 of the world's top banks are using us in some element of their core banking system. So what's become really, really clear is that the origins of MongoDB might have been a niche NoSQL database. The reality is where the market has gone, it's far more general purpose in nature. It's designed for a lot of these new kind of scale-out architectures, and it's proven to be exceptionally valuable across all industries for all different types of use cases out there. So I think if you're a developer thinking about either what you're going to build your next app on, or if you're thinking about how do you modernize that legacy app that you're managing to take advantage of new innovations like AI, for example, MongoDB is the best platform out there.
So we didn't prep on this.
That's all right.
So I'm going to ask you a question that hopefully you have the answer. I think you will. So for a developer who's comfortable with Oracle, he spent his 20 years working with SQL Server or something. What's the best way for them to get started with MongoDB?
Oh yeah. So I think that there's a number of different ways. The good news is just the general nature of how MongoDB is architected and how developers work with data, it removes all of the complexity and rigidity that someone might have with an Oracle database. So there's not a, you don't have to go learn fundamentally new things in that sense. You can literally just kind of pick up and start going, because it's kind of the interface, or the interface is built to operate just like you're writing code or writing a general application. So it's already kind of in the core vernacular of how a developer builds applications. But I think one of the things we've done, and we announced this a few weeks ago when we were over in India, is introduced a whole new set of learning paths for developers, where they can get started quickly and easily and start experimenting with the platform, whether that be signing up and getting into our free tier, using the university courses to go learn how to build your first Hello World app, to actually digging in and coming up with learning how to build new Gen AI apps, right? You've been big on the hackathons out there, and seeing how customers can quickly and easily get engaged with MongoDB plus AWS plus LangChain and Anthropic as an example to build an intelligent Gen AI application. We're seeing developers having the ability to come in and do that in minutes versus having to spend a lot of time rethinking and relearning all of the ways that they're building their code.
Maybe I'll give a brief plug. If you go to the MongoDB website, you'll see what we call developer days. That's something that my team runs, where you can come and have a day's worth of hands-on workshops, get your hands dirty, and learn how to use it. And what we keep finding is when developers, they think it's, to Peter's point, they think it's something new, different, niche. When they start working with the document model, brains kind of explode. We actually have a customer recently sent their developers to one of our developer days, and they said our minds were blown by this. And that's the sort of thing that once it clicks and you see it and you're like, oh, this isn't some strange different thing, it's just a better way of working with data.
Yeah, absolutely. It's funny, you and I do have a history just from the whole open source world. If I go back 20 years of my career, yes, I'm that old, there was a moment where Linux was seen as not secure enough, not scalable enough, not powerful enough, not flexible enough. Pick your favorite derogatory term, and that was how everybody articulated Linux versus a Solaris or pick your favorite Unix. What's fascinating though is, if you go back to those days, when you're just looking at operating system to operating system or database to database, you can easily come up with a reason why you don't want to go somewhere. The tipping point, though, in that Linux Unix world was when the world went from vertical scale to horizontal scale. Scale-out architectures became the basis for everything. And we went from these big SMP systems to little pizza boxes that created these server farms that ultimately became Amazon, Google, Microsoft, etc. We're in that moment right now from a data perspective, right? Legacy databases built decades ago were built for these big vertical scale SMP systems. It was your system of record, right? There was limited access to it. It was the right thing at that point in time. Now we're in a world where, I hate to say cloud is mainstream, but 12, 15 years in, the reality is, for the longest time, it was still such a small percentage of the overall workload. Now every application that's being built needs to be built for cloud scale, right? Everything is being distributed across the globe because your customers are literally everywhere. And architectures, by how you build applications, right? The compute system has changed, the packaging system has changed, the networking system has changed. The one thing that has not changed for most developers out there has been the data platform, because of the fact that there wasn't that need for the apps to be, fully distributed, globally scaled, etc. Well, now we're at that tipping point, especially with where we're seeing Gen AI coming to life, because it's that unstructured data that represents 80% of all data in the market. It is, all your operational data is what actually enables you to move faster and build smarter applications. It is unstructured by nature. You think about it, it's video, it's text, it's sound, it's metadata, it's all of these other things that are basically driving that next generation experience in the applications you want to build. Don't let your data architecture hold you back in that sense. And to me, that was what happened in the early Linux days. It was like they realized we have to not let the legacy architecture hold us back, and we need to go all in on this new one if we wanted to meet the needs and the demands of the market. We're on that tipping point now at the data plane, and I think MongoDB is really well situated to help developers move quickly to adopt these new spaces.
So embrace all the new, but I didn't hear you say anything that made it sound like MongoDB wouldn't be just as good for relational data, structured data, because you can always model your schema.
Yeah. No, I mean, relational data, unstructured data, it's all about building new applications, new experiences, right? How are you going to innovate the way you're engaging with your customers? I think our powerful use cases and our customer roster and things that we enjoy on a day-to-day basis just kind of goes to show you that this is where the future is.
Awesome. Peter, thank you for being the new Scott Sanchez.
Thanks. Always happy to be Scott. He's much better looking and smarter than me.
Thanks, Peter.
Have you heard of the fourth industrial revolution? The first was mechanical, the second was mass production, the third was automation, and the fourth, we're in the middle of it, it's artificial intelligence. There is a fundamental change happening in the way we live and the way we work, and it's happening right now. While AI and its application across businesses are not new, recently generative AI has become a hot topic worldwide with the incredible success of ChatGPT, the popular chatbot from OpenAI. It reached 100 million active monthly users in just 2 months, becoming the fastest growing consumer application. The closest to this was TikTok, and it took 9 months, which is still really fast. So what powers ChatGPT? Large language models, LLMs. In this video, we're going to talk about how you can leverage the power of LLMs on your private data to build transformative AI-powered applications using MongoDB and Atlas Vector Search. We're also going to walk through an example of building an application that uses semantic search, machine learning models, and Atlas Vector Search for finding movies using natural language queries. For instance, to find funny movies with lead characters that are not human, that would involve performing a semantic search that understands the meaning and intent behind the query to retrieve relevant movie recommendations and not just the keywords present in the dataset. Using vector embeddings, you can leverage the power of LLMs for your use case, like semantic search, a recommendation system, anomaly detection, or a customer support chatbot, which are all based on your own data. Now, to do that, we first have to understand what vector embeddings are. Well, a vector is a list of floating point numbers representing a point in an n-dimensional embedding space, and that captures semantic information about the text that it represents. For instance, an embedding for the string MongoDB is awesome using an open source LLM model called
AllManyLM L6v2
would consist of 384 floating point numbers, and it would look something like this. Now, later on in this tutorial, we're going to cover the steps to obtain vector embeddings just like this. So now we know what a vector is and vector embeddings. Well, what is vector search? Well, vector search is a capability that allows you to find related objects that have a semantic similarity. That means searching for data based on meaning rather than the keywords present in the dataset. Vector search uses machine learning models to transform.
Welcome back to the show floor here at MongoDB.local London. That was great to have Matt and Peter on before us. Now, this is live, so it's a slight change to the advertised schedule. We were supposed to be talking about Kubernetes, we still will, but Luce is no longer the host. I'm the host, and Luce is the guest. Luce, you're very welcome.
Why, thank you. Thank you for demoting me from host to guest. This is going to be a fun one. Do I know much about Kubernetes? Not massively, but we can see.
You know more than I do anyway, which is the main thing.
That's true. When was the last time you wrote code?
Every now and then, if I
Okay,
have
yeah.
to. That's what the co-pilots are for, right? And we'll get into that, right?
We will, yeah. So just touch originally on what our guests were going to talk about. So
Mhm.
it's Kubernetes. So there's a talk on it later. If you're actually at .local London at, I think it's 1:30 p.m. There's a
Okay.
session on this multi-cluster Kubernetes support we've introduced. So if you're here, definitely go and watch that. Other people, if you're watching online, the recordings will be available later. But it's just basically bringing together the resiliency that you get from MongoDB and the resiliency that you get from Kubernetes, and just bringing it together so that you can have multi-cluster support. Because obviously resilience comes from multi-cluster. Kubernetes, I'll be honest, I know more about Docker than Kubernetes.
Okay,
But that is
that's
about,
fair enough.
I know about
Other products exist.
exactly, although I still question how much I know about either. But basically, it's just a really great, this kind of like new support is a really great like starting point and integration, and so absolutely make sure to follow up on that content, because it just brings together the scalability and resiliency that you get from both of them together. And as I said, there is a talk later on if you want to watch it, and look out for recordings. And that's about as much as I know about Kubernetes, but
That's okay.
that's the announcement of the day, though, that we have support for multi-cluster support for Kubernetes now.
Well, I think obviously, further to the 8.0 announcement, scalability, reliability, performance, for us, Kubernetes and Docker, we need to be in these ecosystems to make, as we said, and Zahir said in the keynote, developers' lives easier. It's about taking away the mundane tasks and letting them get on with what they're skilled in doing, which is creating the best applications, right?
Yeah, 100%. And so as a developer advocate, I write code on an almost daily basis. But I'm an expert beginner. I do not consider myself.
You're doing yourself down now, Luce. In fairness, I've seen some of the stuff you put together.
Oh, yeah, maybe, and I appreciate that. But for me, like this whole mantra that we have of build better apps faster and loving our developers is so true. And I just love all the things that we're seeing coming out like that. So having these things together alongside the other tooling announced in the keynote, just amazing. For me, it's like, oh yeah, you can get started. You can use it to learn. It blows my mind.
Now, you were speaking earlier this morning in one of the other breakout rooms, Luce. What was the topic there and how did that go?
Oh, it was great. So it was a hands-on showcase demo about our developer tools. So literally getting the chance to stand there and show people, if you're a developer, these are the different ways that we're trying to make it possible for you to develop where you're at. So if you prefer an IDE, or you prefer VS Code, or you prefer using GUI tools to manipulate your data, you can do it in your way. And we try to bring all those tools to people. So I was showing off things like the generative AI and natural language processing stuff that we've got in Compass now, and even in Charts.
It's really good. Charts was great, but you needed to know your way around. Now, the natural language stuff, like make me this chart to show me these, brilliant.
Yeah, and because you can actually do, and Charts is even more powerful than you think, because it's not just the visualizations, it's also, you can do pre-processing before you do the visualizations. Now, aggregations and things is what you'd use to do the pre-processing, the same as you would with the normal aggregation pipeline. I can't write those. Natural language processing is great. Like, I've used it for all sorts of things. And the other thing that excites me as well, which is related to Charts a little bit, is the announcement that we had from Melissa and Max, I think it was, or it might have been to hear about block processing.
Yes.
Because I have an hour ring on my finger, and I've actually got code that will get the heart rate from the API and then put it into a cluster, and then Charts point to the cluster so that I can see my average heart rate and how it's been going. But block
You'll have to
processing,
check today's heart rate now on the live streams, Luce, see how that goes.
yeah, but this is fun. We're just hanging out. Like, we're just hanging out with people online, with our friends on the internet, talking about stuff. Like, that's all good. But certainly block processing and being able to do like ongoing average rather than having to calculate it will be amazing.
So this morning you were talking about the developer tools. We saw Melissa and Max go through Copilot and what they've done there. That's amazing.
Oh, it is, and because we didn't want to spoil anything for the keynote and we wanted to save all that, I actually couldn't talk about it or show it in the keynote.
So you knew this inside and you're kind of
I've
going,
been playing with it.
Wait for an hour, wait for an hour.
Yeah.
Okay.
So I knew all these things, and it was brilliant because I'm as well as being a developer advocate, I'm a Microsoft MVP and a very proud one. But it means that I've had the privilege of having access to GitHub Copilot for a long time, and so I know how powerful and amazing it is. And so seeing, and hearing about being a launch partner for the new extension, or like the extensibility program, and then having an extension and being able to play with it, it's incredible. But I couldn't tell people about it, so that was very exciting.
And when did you first start using Copilot? Like, Maybe
a year ago, maybe a bit longer. I was actually very, very lucky as well. it won't sound lucky in the first sentence I'm about to say, but I broke my elbow last year. But one of the
I recall this.
Yes, one of the things that I was able to do, so I didn't keep working because we worked somewhere that was like, just take medical leave, it's okay, you can't really work. But I was bored. And Copilot for a while had Copilot voice, which meant that I could actually talk to it with a microphone and tell it what I needed and try and code that way.
I have not tried that. Wow.
I don't. Well, it was one of their projects. It wasn't even in public preview, and I got access to it. They just gave me some rough and ready code. So I think it's one of their projects that didn't go forward, unfortunately, because there's other ways that you can do it without needing Copilot voice. Like there's built-in stuff to Windows that will do it. But certainly, yeah, so for me, Copilot has played a big part of my life, not just for writing code, the chat and using it to help me refactor things, but also all the other things you can do with it. So seeing this extension, I'm like, oh, this is great.
And how much of your code writing have you well, at least the genesis of it offloaded to Copilot to give you that base then to which you're refining and
honestly,
building
quite a lot. It's a mixture of laziness, imposter syndrome, and efficiency.
Yeah.
Because I know how to do some things, but it's like, well, I can either write 3 words and say, make me this, and then it will just write it for me, or I have to write out the whole thing. Yeah. And we're busy people, it's a Copilot, it's there to help.
It's amazing to have watched the trajectory of all the code assistant tools over the last 18 months or so. So Copilot exists, but MongoDB have been involved in training Amazon Code Whisper originally,
which is
but now
Amazon Q. Yeah, I demoed that this morning as well. Yeah, so that was another good one. So like you mentioned, we helped train it. So those of us in Dev, I remember doing it last summer because I had to drive to Scotland, weirdly, so I remember it because I had to finish submitting my .NET sample client code, and I got to a hotel at 9 p.m. in Bonnie, Scotland. But yeah, so we got to train it. So obviously and they work kind of differently. So with Amazon Q, we actually provided them data to use to train their LLMs, and so naturally out of the box, you get MongoDB considered best practice stuff. With Copilot and the extension, obviously you can at MongoDB, and then as you saw in the keynote, you can do / commands like /query, and then use that to talk, basically, essentially under the hood, it talks to a MongoDB server somewhere that then gives back the information. So you're getting the best, which is, no matter which tool you use, you're getting the best of us and our best practice and the best advice we can give. It's just how it works under the hood.
Yeah, because all of these have been trained on all of the code and content that we have in our docs, a lot of the code and code examples that we have in our developer center, and then obviously the publicly ingested repos and things that they found as well too. So from that point of view, and we've been testing them, we use them, and so we can vouch for a lot of these tools, and they just keep getting better.
Oh yeah.
We also talked about IntelliJ in the keynote as well too.
We did, yeah. So as you heard in the keynote, like I mentioned, we've been working with JetBrains on bringing. So obviously, as I mentioned, we've always had the database integration, but now they're bringing it and making it even more powerful with this plugin. So they started with IntelliJ, so I've tried that out, and it's as great as you saw. It wasn't any smoke and mirrors in the keynote. Like genuinely, it was it's an excellent plugin. And then, but so I'm hoping they bring it to Rider next, because as a .NET developer that uses a MacBook for work, I love Rider and their products, and so seeing it in IntelliJ, like as a .NET developer, I felt a little bit gross writing Java code, but I know how important it is in enterprise. There's many things in the world that runs on Java, so I think it's important that, Java's important, but it definitely helped me to try it out, to have it there, because I couldn't have tested a plugin without some help, because I don't write Java particularly. But yeah, I'm excited for it to come to Rider, hopefully, and just play around with it and see what it can do, because yeah, like I say, I use a MacBook for work, and so the best IDE for .NET on a Mac is definitely Rider. Obviously, you've got VS Code and a .NET, a C# Dev Kit extension now, which brings an almost IDE-like experience into VS Code. But I still prefer to use Rider just because of some of the extra functionality, and so I'm really excited to see what happens with that.
Okay, well look, the real story is, regardless of what IDE or developer tools that you want to use, MongoDB are trying to make it easier on all of the platforms. And every cloud is a silver lining. We didn't get to discuss Kubernetes, but you got to discuss the stuff you couldn't discuss at your presentation this morning.
That is true, yeah, so thank you.
Luce, I know you've got some hosting later on as well too.
I do,
so
very soon actually.
Tune in on the live stream to have Luce back as well too. But for now, we'll take a short break when we've got a guest from a company, Kovi.co, join us to talk a little bit more about how they're using RAG and Vertex Search.
Have you ever tried to search for something, but you don't quite have the words? Or do you remember some characters in a movie, but you can't remember the name of the movie? Or have you ever tried to find another tracksuit, just like that one that you had back in the day, but you don't know exactly how to search for it? Are you using large language models that don't have the most current information? If you answered yes to any of these questions, vector search is exactly what you're looking for. Vector search is the capability of searching based on meaning. This technique employs machine learning models, often called encoders, to transform text, audio, images, and other types of data into high-dimensional vectors. Vectors, also referred to as embeddings, are essentially a high-dimensional array of numbers that captures the semantic meaning of a word, a phrase, or even an entire sentence. This is what a vector looks like. To a human, it's just numbers, but to an AI, it's knowledge. These vectors can then be searched through to find similar content based on multiple vectors being near one another in a high-dimensional space. Now, this can be a great complement to traditional keyword-based search techniques, but it's also seeing an explosion of excitement because of its ability to enhance the capabilities of large language models, or LLMs, by providing knowledge outside of what the LLMs currently know. In search use cases, this allows you to find relevant results even when the exact keyword isn't known. This technique can also be useful in a variety of contexts, such as natural language processing and recommendation systems. Now, as you probably already know, MongoDB Atlas has supported full text search since 2020, allowing you to do rich text searches on your MongoDB data. The core difference between vector search and text search is that vector search queries on meaning instead of the exact text or even fuzzy text match. And because of this, it can also search data beyond just text. So what are some of the benefits of vector search? First, semantic understanding. Rather than searching for exact matches, vector search enables semantic searching. This means that even if the query words aren't present in the index, but the meaning of the phrases are similar, they'll still be considered a match. Next, it's scalable. Vector search can be done on large data sets, making it perfect for the use cases where you have a lot of data. It's also flexible. Different types of data, including text, but also unstructured data like audio, images, and video, can be semantically searched. Now, while there are a lot of vector databases popping up during this AI revolution, you'll be able to satisfy all of your data storage needs in one place. MongoDB isn't just a document database, but it's a developer data platform. Not only does it offer unstructured data storage, you can also easily store your vector embeddings and use vector search, along with many other great features. You're going to gain efficiency. By storing the vectors together with the original data, you avoid the need to sync data between your application database and your vector store at both the query and write time. You'll also get consistency. Storing the vectors with the data ensures that the vectors are always associated with the correct data. This can be important in situations where the vector generation process might change over time. By storing the vectors, you can be sure that you always have the correct vectors for a given piece of data. And this simplifies everything. Storing vectors with the data simplifies the overall architecture of your application. You don't need to maintain a separate service or database for the vectors. And this reduces the complexity and potential points of failure in your system. And of course, it's scalable. With the power of MongoDB Atlas, vector storage and vector search on MongoDB scales horizontally and vertically, allowing you to power the most demanding workloads. Now it's show and tell time. Let's see how it works. If you don't already have a MongoDB Atlas account, it's completely free. There's a video right here that you can watch and it'll get you started. It will walk you through setting up your first free cluster. And we're going to use one of our sample databases that you can load, but it's important that you don't load the sample data yet. Just create the cluster. Our plan is to have OpenAI enrich our sample Inflix movie database by adding vector data to each movie. And then we're going to set up a trigger that runs every time a new movie is added to the database. This trigger function will generate the vector embeddings and add them to the document as it's inserted. We'll then set up a search index so that we can use these vector embeddings. And then we'll insert our data and then finally see how we can query our data using vector search. All right, so first we're going to create our database and collection so that we can create an Atlas trigger. So here under databases, I'm going to browse collections for this cluster. I'm going to click add my own data, and then I'll give the database a name. It's going to be sample_mflix, and the collection name will be movies. There's no additional preferences, and then we'll create. So now we have a blank database and collection here. Next, we're going to create an Atlas trigger that's going to call the OpenAI API whenever a new document is inserted into this collection. Now you will have to have an OpenAI account and an API key. There's a link in the description below if you don't already have one. And this is what that looks like. If I go over to my account and then view API keys, you should create a new secret and then copy the API key because you'll need it in just a minute. So let's create that trigger. On the left, we'll go over to triggers and then get started. The trigger type is going to be...
Excellent. Welcome back to all the viewers joining us on LinkedIn and YouTube. Once again, we have a great interview lined up. This time it's a change of pace where it's not a MongoDB person, it's a customer of ours. So Saravana Kumar from Kovi.co, you're very welcome to the MongoDB live stream.
Thank you very much for having me on the show. It's really excited to be here. Like I can see a lot of buzz around and a lot of things happening. Yeah.
It is. It's great. It's lovely to be in the midst of all of this and the noise that's going on around. It's great to see everything. And for the viewers who are joining us, you can't see there's two stages either side. There's live streams going on, so it's super busy. But listen, Kovi.co, tell our viewers a little bit of background to the company and what you do. And then we'll dive a little bit more about what you're doing with MongoDB.
Sure. Kovi.co, under Kovi.co, we have 3 different products. Like 2 of them are in the Microsoft space.
Mm-hmm.
So we come from a Microsoft background, and we have a product called Turbo 360, which does Azure cost optimization, cost management kind of things. And then we have the third product, which is the main product where we primarily focus and where the MongoDB plays a big role. It's called Document 360. It's a self-service knowledge-based product. So for example, if you want docs.mongodb.com, then it's actually, we provide the entire platform. So your documentation team only need to worry about writing content. We take care of the hosting, the search, and then the entire content management flow, everything. So it might look like pretty simple problem, been in existence for a long time, but nobody has solved it very well, and that's the space we are in. So we got some exciting clients like Airtable, Gong, Midjourney, and so on, like high-end customers using the product at the moment. Yeah.
Excellent. And I had Selva, one of your colleagues, join us on the MongoDB TV live stream a number of months ago, when he went through the Document 360 platform, and it was super easy, super intuitive, and straight to understand. So for that, like the solution behind the hood of Document 360, tell us a little bit more about how that's built. What's the technology stack?
Yeah, sure. I think you're absolutely right, because that's exactly the problem what we try to address. Because if you look at the space, one side of the spectrum, you'll see typically the documentation comes from a customer support product like ServiceNow, Zendesk, Freshdesk, etc. And they're it's so simple, but it's not really applicable when your company scales up. On the other side, it's a really monolithic old legacy systems where the power is there, but the usability and the flexibility is not there. And that is the gap what we found, and then we just built Document 360. Under the hood, I mentioned at the beginning, like MongoDB plays a very critical role, because if you look at a knowledge base, it all comes down to the data, and there we are storing those documents and how we are able to retrieve them, use them, manage them. So it's super critical for us to have like a really stable, scalable database underneath. So we evaluate a lot of things, and then we even went down the relational database side for some time.
That's okay.
And then we finally settled down with NoSQL, MongoDB, and we haven't looked back nearly 6 years now. So it's pretty.
And we announced vector search in MongoDB Atlas last June, so June 2023. But Kovi, we're early users of that.
Yeah.
We're very early on to prove that on the platform, which was the underpinnings of Document 360. Tell us a little bit about how that enabled you to build out Document 360 with our vector search.
No, absolutely. So we started the company. The company itself is very old, but the Document 360 was started back in 2018, and everything was fine. Like a typical document management, like a self-service knowledge-based platform.
Yes.
And once all this AI wave started to kick in, and then the OpenAI, and that changed everything basically. Like, so we need to jump on, and then we need to get in, because being a knowledge-based product, it's a perfect candidate for you to apply a lot of AI things. There's a lot of products, they try to put like a lipstick on the top of their product rather than it's a natural fit. But being a knowledge-based product, it is a natural fit for a lot of things.
Totally.
And we had to address some of the AI capabilities, and vector search it's kind of a backbone for us to enable us to do the AI stuff. So we need to do like a lot of the embeddings, and because it's a combination of our data plus the open models out in the AI space, like the ChatGPT, like 4.0 or 0.1 or whatever we're using. So it's very important for us to get our customer data into that system so that we get a cohesive search and AI capabilities built in, and that's exactly what the vector search is doing for us. And as we said, we are one of the very early customers to go on, and as a SaaS platform, and we are pretty intense users of it at this stage.
It's a great success case. And tell me a little bit about the RAG challenges. So you have a customer and they've got all of their documentation, different formats, different things, and you need to make sure that that's suitable for a RAG solution. So what are the potential pitfalls people don't understand when they're trying to implement retrieval augmented generation?
Yes, sure. I think, our data store is fixed. We are in MongoDB landscape for our primary cluster and primary data. And then, when you look at how do you address this RAG problem, and then, what are the vector searches available for providing the embeddings? There are a bunch of products out there in the market. We evaluated some of them. The challenge being keeping data in sync between your primary store and then the embeddings that goes inside that is a complex problem to solve.
Yes.
And once you bring somebody, a third party inside, then you're complicating the problem by 3-4.
There's a larger round trip. There's stale data in transit, everything associated
everything,
with that.
you need to worry about your data consistency between those platforms. And the security aspect, because you need to apply the same rollback security at the source as well as in the third-party store, and then it just complicates the whole thing. So here, it comes down to simple triggers. People are very familiar with triggers, and update trigger, add trigger, delete trigger, etc. Just helps us to just maintain the sync and makes it seamless. Yeah.
Okay, but the ability to have the vectors always be in sync and always up to date. Obviously, that just takes off a load of workload from a developer's perspective, and all of that concern, all of that resilience and performance issues.
No, absolutely, because if you don't have something like that, then it's a huge engineering effort on its own to make sure that that infrastructure is, the architecture is working efficiently. So, these days we are, as a company, always on doing more platform as a service model. Everything we do is, that's why we are on MongoDB rather than running our own servers and managing them. So we as a young startup, we are focused more on speed and how fast we can go rather than, utilizing our engineering resources on something which can be bought rather than, we keep on building something. So I think it works perfectly,
Okay, and you talked about, wide variety of customers. I think when we were chatting before this, 1,500 customers on Doc 360 at the moment. In terms of kind of use cases, or anyone wants to go find out something a bit more, where would you send them? Or do you have case studies up there? We have a case study with yourselves.
Yeah, sure. I think just go to document360.com. You'll get all the details. I think in terms of use cases, there are primarily 3 use cases. One is a public knowledge base. Any product or any digital business you will require, anything like help.yourcompany.com. We can actually provide the old class product for it. Or the second use case is an internal knowledge base where you can process documents, onboarding documents, and engineering documents, and whatever you can think of, it can be done. And the third use case is the API documentation. So if you have APIs, you need to document it. We provide, just give us the open API specification, and we'll build the entire knowledge base for you.
Okay, well, I mean, all of this is really core to a developer's experience of a product, but not necessarily core to whilst you're developing your product. So it's great to be able to offload it to Kovi.co to be able to do this.
Absolutely.
So it sounds like a great solution. Turning our attention to .local London, what are you hoping to get out of your visit here today? What's in it for you?
It's a combination of multiple things. I saw like a lot of breakout sessions, like a lot of things on AI and stuff going on. So I'll be interested to see a few of them. And generally, any events, I primarily focus more on networking, meeting new people, and what challenges they are facing. Because these days, the content is available straight away. I'm sure these things are all available in 2 days later. I prioritize myself on meeting people and then chatting to them so they will understand the real problems what they are facing. Yeah.
Perfect. Well, listen, I hope the day goes well. But Saravana, thank you very much for joining us, and I very much look forward to see what Kovi.co build with MongoDB Vector Search in the future as well too. But for now, it's been a pleasure to have you on the live stream. We'll be back very shortly with yet another guest, so do stay tuned in. Thank you.
Thank you.
Henry is the product manager for Atlas Vector Search. Welcome, Henry. Thank you for joining us.
Happy to be here, Jesse.
Awesome. So to get us started, let's maybe you could share a little bit about your background with our audience. What got you into machine learning and AI stuff?
Sure. So I first kind of encountered machine learning and AI when I was in grad school at Stanford in 2019. So this was sort of the onset of a lot of these things that are now large language models. The Transformer paper had recently come out, and there were a lot of these, like the BERT model was starting to become very widely accessible. I was in an NLP with deep learning class, and I, fine-tuned BERT on a small Reddit data set, kind of saw the potential for it. But I was in grad school for robotics, actually. So I worked at a robotics and machine learning startup called Osaro for a few years after that. And eventually made my way into sort of like the data engineering world, which brought me to Mongo as a software engineer, and then recently expressed interest in us putting forward a vector search product, and got involved with that. So that's sort of wind-about way into this search world now.
Nice. Okay, so robotics. My first thought is, are you going to build a robot with AI? How are we going to do that at MongoDB?
Yeah, it's. I think that our CTO, our former CTO Elliot, is like working on that kind of stuff now. He's working on a robotic platform. So who knows? Databases, robotics, machine learning. These are fundamental building blocks. I think there's probably some commonality between all these things that drive people that are interested in like systems and to be very compelled to work on them.
Nice.
It's very hand wavy, but I like to think that there's a common thread between these things.
I think so. I think they all go hand in hand for sure. That's pretty cool stuff. So before we get into why we're here, I like to do this little icebreaker thing. It's just a fun little game that I want the audience to participate as well. So it's gonna be really quick. I'm gonna say ask a question, and the first thing that pops in your mind, say it. Audience, get ready on the keyboard. All right. Android or iPhone?
iPhone.
Okay. Windows, Mac, or Linux?
Depends on what I'm doing, but probably Mac. Yeah.
Mac. Okay. All right. I go back and forth between Mac and Windows. Not much of a Linux person though. Sorry. All right. Your favorite code editor or IDE, and this could make or break our friendship here.
If I'm working on a big project, PyCharm is pretty nice. If I'm like hacking together little scripts, I really like Sublime. But pretty much anything with like basic syntax highlighting and code search is good for me.
Okay, I'm the OG Sublime text editor guy too. Right now I love VS Code, obviously, but that's great. So when you're actually coding, tabs or spaces?
Tabs.
Tabs. Okay. Generally, I'll just go with whatever Prettier throws out there. But yeah, pretty much tabs is so much easier. Okay, last one. Coffee or tea?
I wish I could be a tea person. I feel like they've got like this like Nirvana vision of the world, but I'm a coffee person.
Yeah.
1 a day now. Used to be 2 a day. So at least I'm growing in that respect.
Okay. Yeah, I have to have my one in the morning, and then sometimes I'll skip the afternoon. Just depends. Awesome. All right, let's enough of that. I see a bunch of comments from the audience. Thank you all for playing along as well. Looks like we've got a bunch of Android, Windows, VS Code, Nokia. Somebody's using a Nokia and a Mac.
Okay.
Awesome. Okay. All right. Let's get into what we're here to talk about today. I'm going to go ahead. Let me know when you're ready to share your screen, and I'll bring your screen up, Henry.
Go for it.
Okay. So here is your slides, and go ahead and take it away, and we'll ask questions. Audience, if you have any questions as we go, ask them in the chat. We'll answer them if they're applicable to what we're talking about. We also have moderators who are going to be helping to answer questions as well. And oh yeah, one last thing. This is recorded. So if you're not able to stick around for the entire thing, come back later. Video on demand, you'll be able to watch it. All right, take it away, Henry.
Awesome. Yeah, so I guess before going into any of the content for the slides, just to set the stage a little bit. So in my work as the PM for vector search, I spent a lot of time talking to customers and sort of walking through what the product is, what it can do, and sort of this big distinction between like exact nearest neighbor search and approximate nearest neighbor search. And I have like a few like sides that I show in my tech demo, but there's always this thing of like, how does this index that you guys use called hierarchical navigable small worlds, or HNSW, it'll be written out in a future slide, so you don't need to like memorize that for now. How does this actually work? Like, what are the mechanics behind it? What it's like a good like intuition for how to think about it? And I never have enough time in these calls to really get through it. So I'm really hoping to like, when I was thinking of a topic for what I would want to share with as many people, this was like the first thing that came to mind.
Nice.
But yeah, basically, just to give a quick review for those that couldn't attend Prakul's talk, where he quickly went through this as well. Atlas Vector Search is a capability within MongoDB Atlas, our managed data platform. So going to do a little review over some of the functionality before I get into the actual indexing nuts and bolts. At a basic level, we believe that you can do vector search directly on the documents that exist within a MongoDB collection. This is an example of a document where you might have a call transcript from an earnings call with a set of metadata. But really the more important thing is this content field, which is, it could be a really long, chunk of text, depending on the max sequence length of the embedding model you can use. You can have thousands of tokens, which get passed to an embedding model and produce some fixed length vector of floating point numbers, which we can then define a vector index for, define a similarity method to use. So when you're comparing a query vector to a bunch of your index vectors, like what geometric comparison do you want to use? Is it Euclidean distance? Is it dot product? Is it cosine? Typically, the embedding model you use defines like which one of these you might want, as well as what metadata do you want to filter on. That's another thing we offer. And then recently we updated this, so folks that are familiar with Atlas Vector Search might have used this dollar search syntax. We recently announced the dollar vector search syntax, and we put out a lot of documentation very recently about the distinctions between this and dollar search, but it's essentially using an MQL filter and adds additional parameters that make things that are relevant to HNSW, which I'll explain, easier to configure.
Yeah. Now, like Henry mentioned, last week we did a stream with Prakul, and he went into more details. So after this, if you want to watch that one, if you haven't watched it yet, go back. It's on the YouTube channel, and you can get a deeper dive into how all of this works.
Awesome. Yeah, but I think, and then this is a new sort of like example of what this query syntax might look like. So typically you would, take a plain English query, embed it into the same embedding space that your index data was embedded with, and then request a certain number.
Welcome back, everybody. Once again, we're live from the show floor. It's getting super busy behind us, with a lot of things going on left and right, so hopefully the audio is coming through clear for everybody. We do appreciate all you joining and staying with us. Slight change of guest, but the topic and everything else is roughly the same as well, too. I'm delighted once again to be joined by a client of MongoDB's. In this instance, it's Typhoon, who's an enterprise architect with Accenture, and Typhoon is here to talk about a few different things, so we've only got 10 minutes, but hopefully we can cover them all. So Typhoon, welcome to the show.
Thank you very much. Very excited to be here and excited to be with you guys and share the stuff that we're doing.
Excellent, excellent. I'll just get you a little bit closer to that microphone there, Typhoon, because it picks up the background noise. So, a little bit about the day-to-day role as an enterprise architect in Accenture for you. You were talking to me briefly before we came on air about more of building products to show clients, to show them exactly what you can bring. So you're involved in the healthcare space, and tell us a little bit about the products that you're building in that area.
Sure. So on a day-to-day basis, I actually work as an enterprise architect as well as a software engineer, so I lead different teams, so I wear different hats. Along with these, I also found a couple of innovative products that we want to showcase to our clients to see what we can do with emerging technologies.
And one of these you brought along with you today there. It's just over on the desk there. Yeah. Tell us a little bit about that. Sure,
I'll show it in a minute. Let me give some context. So one of the products or set of products that we're building is under an umbrella called Neurodynamics. And what we're trying to achieve with that is to bring biosensing data, so things about your brain, things about your heart, or things about your body into the platform to make them enterprise ready. For this, we use devices like this one. This is one of our partners, Mendy, and it's something that you put over your head, which might make you look like you're either out of a tennis game or martial arts, but it's actually what it does. It listens to your brain, tells you things about your brain, and collect that data. So building different platforms to showcase what we can do with this insight.
Okay, and the reason behind building these showcases is to illustrate, what can be done and kind of open up paths of conversation for other work for Accenture and your role as an enterprise architect, right?
Yes, that's correct. So we identified a couple of use cases. In fact, one of Accenture's Tech Trends 2024 is about our electronic bodies, so what we can do with the insight that we can gather. So think about, let's say you're watching a horror film in VR, and we have some sensors that can adjust to the quality of the video content you're watching. Or think about that I'm trying to design a new product, and I want to understand how engaged you are with that product or how well you're doing. So all of these things can be enriched with the data that we can gather from wearables, and then we can make sense of them. So that's all the context that we're providing. One of the excited areas that I'm involved a lot is about mental well-being, and a number of products we built under this called Brain Gym.
Brain Gym. Okay, tell us a little bit more about Brain Gym and what that does.
Sure. So what a physical gym to an athlete, Brain Gym is for the talent. So we've been building this so that you can pretty much build your brain muscles. Brain doesn't have muscles, disclaimer, but it's just to create that exercise so that you have a healthy mind, healthy brain, so you can be more productive at work. But you can also balance the stress, the burnt out, so you have an overall improved wellness in your life in general.
How does Brain Gym work then? Is it an app with like puzzles and things to solve along with sensors knowing how that's working?
Sure. So we're building a platform and we're integrating with different partners such as the one I showcased, Mendy. So it comes in two aspects. So our platform offers the integration capability where we can drive the data, drive the insight, and integrate with partners out of the box. The other aspect is, if you go to a gym, you have a coach, and with your coach, you can ask questions like what to eat or what to do, things like that. And this is also we provide with Brain Gym. We have Brain Gym Coach, which is powered by Accenture's Jumpstart GenAI application, which is also developed in partnership with MongoDB.
Excellent, and a very good segue. Well done. Tell us a little bit more about Jumpstart. How long have we been collaborating with Accenture in Jumpstart, and what does that mean to startups?
Sure. So Jumpstart is something we've been working together with MongoDB over the past year. And it's just to really accelerate your GenAI journey, so just jumpstart it, pretty much, right? So we realized that GenAI space is very fast changing.
Sure, super fast.
Every day. But at the same time, the foundation technology, the class first principles are the same. So what we did, we put all of our expertise, Accenture's and MongoDB's, together into what we call the containerized application. So you can deploy this application out of the box. It is cloud agnostic. It supports multiple LLMs. It offers you different chunking methods. We recently introduced a new feature to include knowledge graphs. We'll also have a talk later today. And the idea is really to give you value, so you focus on the value instead of kind of dealing with the intricacies and the complexities of GenAI. We take care of that, and we give you that package.
So essentially a suite of templates to get started quicker, to get your proof of concept quicker, your minimal viable product, etc.
Yeah, exactly.
What sorts of successes have you seen out of Jumpstart? How has that worked?
So for me, again, I take it back to the brain gym, because that's one of the really passionate areas I'm involved with, because we're looking for use cases where, and we're investigating how we can support the talent, us basically, on a day-to-day basis. So with the coach, you can ask questions like, oh, I'm feeling stressed today, what can I do?
Right.
So Jumpstart has a rich knowledge base. It can understand the question you're asking. It has your data as well.
Okay.
In a way that, you know,
it's grounded.
So it can interpret how you've been recently. So it can give you more personalized feedback and tell you about, okay, maybe you can do these things based on this research that looks at relationships. So if you're sleeping lately or sleeping poorly, it can make your suggestions on that ground.
Okay. And so you said you've been working in Jumpstart over the last years. You must have been super early adopters of MongoDB vector search then in that instance, right?
Yeah, that's correct. I've been working with MongoDB for over a few years now, in fact, and it's been really that kick effect where we can just start developing fast is what really hooked us in the first place. And then it is scalability, it is security, it's all things that kind of makes it a perfect solution for us, or partner for us to go to. Because we can have everything under the same hood. We can have our vectors, we can have our operational data, we can have our time series data, which is pretty much most of this biosensing data.
Yeah, all the IoT stuff. Yeah. Wow. And if somebody's interested, where do they go to find out more about Accenture Jumpstart?
But they can come to us.
All right.
They can directly come to me, or we have an Accenture/MongoDB booth here at Local. They're easy to find.
Excellent. And you talked a little bit, touched on it earlier, that you're doing a session later. Tell us a little bit about what that'll entail. What are you talking about there?
Sure. So our session is, I think, at 4:25, and we're going to talk about Jumpstart, how we built it, what it enables, and more excitingly, the recent features that we've added, which is around knowledge bases and knowledge graphs. So it's all about relationships, how we can create relationship in a knowledge base. And then when you ask a question, you don't just get a linear answer back, but your answer gets understood and investigated in relationship to all the other things that might be relevant, and you get a richer response back. And this comes out of the box, which is quite nice.
Brilliant. So it's broadening kind of the question answer into more memory, more prior knowledge of kind of the questions as a whole to give a better solution, a better answer into that knowledge space. Excellent. Well, look, I think these are amazing, the products that you've... I would imagine most days are pretty entertaining and fun if you're playing around in this startup space, in the healthcare space. Have you worn the brain analyzer yourself?
Yeah, I've been using it quite a lot, actually.
Yeah?
I have sessions, brain gym sessions, if you will.
Okay.
And it really helps.
It's fascinating.
I can talk a little bit about how it works.
Yeah.
So basically, it's a bit like, you put one of these devices on, I have a headset that looks like that, and what it does is you can play a game. So think about that game as one of your devices in a gym.
Okay.
So let's say you're on a treadmill, you have an exercise routine, and you build your muscles. With the app that comes with this hardware, what you can do is you can play their game. So it is consisting of a ball on the app, and you can control that ball with your mind power. And the game is designed...
Really? Where that ball is in the app with no tilting of the phone?
Yeah.
That's pretty scary now, Typhoon.
It's good, because it doesn't necessarily really look at like what's happening in your brain, but it is focusing on if you're focused on the game. So the more focused you are, the ball starts going higher,
Okay.
You lose focus, the ball goes down. And the game is designed in a way that it works out your brain muscles. So it knows when to drop the ball, when to make the ball go higher. And if you do it, say, 10 minutes a day over 2 months, for example, you'll have improved brain activity, which is quite cool. And this is just one of the many variables you can have on the space. Some of them makes you more productive. Some of them shows you how to do meditation better. Some could be more about physical health. We're combining data from heart rate monitors, for example. You can even think about glucose monitoring and see how it affects your day. So it's a very, very exciting space.
Excellent, and I love it from the perspective that, you know, we are being very mindful of wellness, mindfulness, digital detoxing, etc. But in this instance, we're using the digital tools to help you be more mindful, more well, and train your brain and monitor that. Well, listen, fascinating. I look forward to maybe trying it myself later on and catching up. But Typhoon from Accenture, thank you so much for joining us on the live stream. We'll be back very shortly again with another client of MongoDB to figure out they're using MongoDB Vector Search. So do join in. But for now, Typhoon, thank you so much.
Thank you very much.
Hi, my name is Carolina, and I'm here with my colleague, Ainoa. We're both cross-industry specialists under the Industry Solutions team. Today, we'll be talking about usage-based insurance, and then running through a fun and quick demo. Let's get started. So let's dive into the numbers a bit, and why you should care about usage-based insurance in the first place. The usage-based insurance market size was valued at around $19.6 billion in 2021 and is projected to reach $66.8 billion by 2026. That means there's a huge market potential in the sector. But you might be asking yourself, why? What is usage-based insurance, and what are the drivers? Usage-based insurance is a relatively new approach to personalized quotes that may soon become a new golden standard for vehicle insurers. In contrast to traditional insurance, UBI relies on current behavior patterns rather than static data like age, location, and accidents reported. The shift toward usage-based insurance can be attributed to the following two factors. One, there's a huge amount of IoT data being produced, and insurers are grappling to manage such data. On top of that, consumer expectations are continuing to gear towards personalized experiences based on driving behavior. Given these two factors, what are the challenges of UBI for insurers? Car insurers have several operational needs that legacy software can't fully cover. For example, real-time data processing, whether you need to calculate a quote or provide customer assistance. It's critical for an insurance solution to be able to quickly process input data from different sources and provide accurate results in real time. Another challenge is data types. Today's roads are filled with vehicles equipped with IoT sensors, telematics, and advanced driver assistance systems. All these technologies gather and generate tons of useful data, like geometric data, vehicle state parameters, and driver behavior data. Yet, not all vehicle insurance solutions can properly handle these types of data. And the last challenge is AI and machine learning integration. If you want to integrate AI and machine learning platforms to your database, you'll be faced with complicated joins. Given these challenges, let's dive into the demo and show you hands-on how quickly MongoDB solves these challenges, and Ainoa will walk you right through it. Let's get started.
Let's step through an example of what a digital data processing pipeline looks like using core MongoDB Atlas features and a machine learning platform like Databricks. Imagine being able to offer your customers personalized usage-based premiums that take into account their driving habits and behavior. To do this, you'll need to gather all of the data from connected vehicles, aggregate the data into a data platform, send it to a machine learning platform for analysis, and then use the results to create a personalized premium for your customers. You'll also want to visualize the data to identify trends and gain insights. This unique, tailored approach will give your customers greater control over their insurance costs while helping you provide more accurate and fair pricing. Now that we have a high-level overview of what the process looks like, let's dive into the architecture of our usage-based insurance model. We'll start with data generation. To simulate the data that we would get in real life, we've utilized mLocust. As you can see in our screen, we start with empty collections. With mLocust, we start to generate our customers' driving behavior, for example, distance driven. Now you can see on the screen all of this time series data coming in. Now if we go back to Atlas, look at all of the documents being generated only in a couple of minutes. A point to mention here is that Atlas offers native support for time series data, such as the one we're using for this demo. This means you can eliminate the need for a time series database, such as InfluxDB. Now let's dive into data aggregation. All of the generated time series data is aggregated at the end of each day and each month in daily and monthly buckets, respectively. For the demo purposes, we've sped this up. As you can see in Atlas charts, you can easily and quickly visualize your customers' driving behavior. Without usage-based insurance, insurers have to utilize insurance underwriters to best calculate new premiums. However, with MongoDB and Databricks, you can automatically calculate these new premiums. Let's see what that looks like visually. As you can see, we can automatically calculate new premiums, saving insurers incredible amounts of time.
Welcome back, everybody. I do hope you're enjoying the live stream. Thank you all for joining us still on YouTube and LinkedIn. Again, we have another guest. This time it's a partner, Ben from Superlink. Ben, you're very welcome to the MongoDB live stream at .local London.
Thank you, Shane. Great to be
How's
here.
things been here so far? Have you seen anything yet? Or have you been around much? Or you just raced in for the interview?
To be fair, not yet, but it's exciting to see so many people, so many exhibitors, so many interesting content, so I'm looking forward to it.
Excellent, excellent. Well, look, it's great to have you join us. Superlinked is a recently announced partner of MongoDB. It's great to have, a great partner ecosystem. For those that don't know about Superlinked, tell us a little bit, top level, what Superlinked is all about, the history of it, the founding, etc.
Absolutely. So we are a US-based startup. Recently raised our 9.5 million seed round from Index.
Congratulations.
That's great.
Congratulations.
And hired a bunch of super smart ML engineers to build the infrastructure, what we would say the infrastructure for machine learning of the future.
Okay.
And what does it mean? Vector search, now popularized by ChatGPT, large language models, is an amazing tool which we think is underused by developers, right? It's relatively easy to use. You don't need to train your own model.
No.
Right? You have a bunch of large language models that you can use. Using vector search is pretty easy on its own, but to use it into multiple different use cases, you need to feed it with the right data.
Okay.
And the idea, what we are building is basically a platform to turn complex data into vector embeddings in a smart way and query those vector embeddings using just simple vector search. And the partnership with Mongo, of course, is a very popular database within the developer community.
We'd like to think so.
Absolutely, absolutely. And Mongo has the MongoDB Atlas, which is the vector search capability. And we build a native integration to it, leveraging all the capabilities of that vector search, but also making it super easy for the developers to use MongoDB vector search in their applications.
Okay, so you mentioned complex data there earlier on, Ben, and even in our keynote earlier, Zahir mentioned that 70% of the world's data is unstructured, and we even had a really good slide around that too. Talk to us a little bit about the complexities of enterprise and company data as you're finding it with Superlink.
Absolutely, and by volume, totally agree with you, 70% is
probably
unstructured.
More.
But if you think about a table of data, even a table in Mongo, right, that has the structured and unstructured data, by number of data points, you'll probably have more structured than unstructured data.
Okay.
This is all about user IDs, products they bought, preferences of those users, timestamps, activities, etc. All of this is structured data, right? Now you have a lot of unstructured, right? Product descriptions, for example, images, videos, audios, amazing. Yes. And now we have great models to deal with those. But how do you run a query over that unstructured data that takes into account the metadata, the additional structured data that is actually important?
Yes.
So if you think about e-commerce, for example, and you want to build a recommender system, like images work great in e-commerce, and we actually have a production deployment of e-commerce recommender system with Superlink. So images work great.
Okay.
But
Because they're what's attracts you when you're shopping,
Absolutely.
when you're browsing, image heavy, right?
Yeah, you look at the image, and so when I'm going to recommend you similar products, I'm going to take into account the image.
Okay.
But I also want to take into account the category, right? You know, you might be shopping for a female jacket. I don't want to offer you male jackets, so I need to make sure I don't offer you those.
Yes, yes.
I also want to make sure this is within the range of the price you're looking at. If you're looking at a £100 jacket, does it really make sense to offer you a £2,000 one, right? So you know,
depends if you're getting paid shortly or not. You know, this is how much budget you got left.
Absolutely, and you know, maybe I even have a flag in my database saying this user is a bargain seeker. And now I have jackets on sale. Hey, I want to recommend them. So how do I take the unstructured data, the image, the product description, alongside those signals that actually make the recommendation better? Right?
Okay.
And so, you know, with our e-commerce deployment, we saw 15 million increase in sales, right? So roughly about 10% across the platform by offering recommendations which are first of all real-time, but also very much personalized for the user and for what they're looking in the current session.
Because of the broader knowledge from the unstructured data that isn't necessarily categorized well or captured, Superlinked helps that.
Unstructured, absolutely, but also with the structured data, right? Okay. And the challenge is many e-commerce organizations have great engineers, but might not have enough machine learning engineers, data scientists. Sure. With Superlinked, they don't need to, right? The regular AI engineer, and we're going to be talking about this in the panel in the afternoon, right, can basically use Superlinked to use those large language models without need to train any re-ranking models or fine-tuning those models.
Okay,
okay.
Because that is, you know, re-ranking, fine-tuning, that's an awful lot of effort. And I suppose coupled with that being a lot of effort, but also coupled with the LLMs being, you know, new ones coming out every few days or every other week at least, you're kind of going, well, is that wasted effort? So in this instance, Superlinked, there's none of that effort in that instance. No fine-tuning, no re-ranking. Superlinked is taking care of that.
Yeah, and it's a little bit more than just effort. It's also capability and capacity.
Yeah, and understanding, the knowledge to do it correctly, right?
Exactly, exactly.
Okay, you mentioned e-commerce. Is there other use cases for Superlinked, other areas that you have expertise in?
Absolutely. I mean, PDF RAG is definitely one interesting area. And again, we are working with a couple of financial institutions looking into querying their PDFs. Now, there is a kind of trivial or the basic approach of stringifying the whole PDF and then feeding it into the large language model. But then how do you answer a query like, oh, which of the companies that I have in my database increased their revenues over the past 5 years by more than 20%?
Right.
It's impossible. It's impossible to answer. What Superlinked allows is actually storing separately the structured data that you care about, for example, those revenue numbers organized by years, separately from the text of the document. So you can still ask questions like, oh, which of the companies that work in this particular industry and have offices in those places, right, which will come from the text, have that revenue increase. So we give you the benefit of both. You can ask questions around the structured data, but also the unstructured.
Okay. We talked a little bit about, you know, AI and the generative AI space moving so rapidly. How does Superlinked keep ahead of this? You know, with all the new developments, all the changes, everything else. Like it must be a tumblewheel of, this is a new feature, we got to add this, we got to have this. How do you guys keep ahead of that?
Absolutely, and we definitely, I wouldn't say suffer, but let's say it's definitely been a challenge of knowing where to stop, right? Where to stop developing and adding new features. And one of the things we did, for example, is building a custom space. So, we might not support every model, every type of content, every new thing that came out, but we provide an ability for you to provide a part of the vector. So if there is a particularly new thing that the developer wants to use, they can still do it with Superlinked. So we provide that language and that infrastructure, and we really focus on taking applications to production. Right? Because a lot of them kind of get stuck in the POC or pilot phase.
Yes. And that seems to be the issue. I always see really good POCs, very exorbitant demos that are really cool, and you're kind of going, I want to see something at scale, I want to see something in production. So this is the missing link, this is the step that you provide.
And we invested a lot in doing it. But to your question around the new features, we have that, should we add this before we release, should we add, right? And so we decided, okay, we have a good set of features, good set of models that we support and data types. Now let's make sure we help people get into production, so we invested a lot in the whole infrastructure and kind of easy one-click or one-command compilation to the cloud, to Spark, etc., to support that scalable deployment.
Okay, and talk to me a little bit about your MongoDB journey as a relatively new company. Did you have experience of MongoDB? Did the founders have experience of MongoDB before this, and that was a natural choice, or did you audition all the databases, all the vector stores?
We actually did look at the vector search capabilities. We were looking for the ones that used by clients that we support, so more enterprise clients, right, that combine the structured, the unstructured data, and have a vector search that supports the kind of capabilities we're looking for. Okay. One of our benefits is that we allow you to weigh and give more weight to different parts of the vector. I care more about users that are bargain seekers, I'll give that more weight, that signal more weight. Okay. And so that was enabled by MongoDB, and working with the team, obviously the team is very experienced in working with those integrations, so it's much easier than working with, let's say, some of the newer vector search providers.
Excellent. And if people want to learn more about Superlinked, where can they go? Just to the website? Is that the place to go?
Website for sure, but we also build Vector Hub, which is our educational resource, mostly community-generated articles, right? We generated a few recently as well, more kind of putting Superlinked within the context, but community...
That's okay, that's okay.
Yeah, but we want people to build with vector embeddings, and so we invested quite a bit in getting those community articles up there. So if you go to the website, you click Vector Hub, absolutely, or just superlink.com/vectorhub.
Okay, excellent, sounds great. What do you hope to get in the rest of the show today?
Well, I hope to meet AI engineers who are interested in building with Superlinked and get more of those pilots and POCs into production.
Excellent. Listen, sounds like a really good plan. Let's hope that happens for all our visitors here in person. And for those of us you joining us online, obviously you can go to any of the websites, etc., that are mentioned as well from any of our guests. But for now, Ben from Superlink, thank you so much for joining us.
Thank you very much.
Take care.
Pleasure.
Enjoy the show.
Thank you.
We'll be back.
The MongoDB for VS Code extension is now generally available. There have been some amazing updates, so let me show you what it can do. At a high level, the extension allows you to navigate your databases, collections, and documents in MongoDB. You can get a quick overview of schemas and indexes. You can use playgrounds to aggregate and to write scripts. It's great at rapid prototyping. You can edit documents and save changes to the database. It has intelligent auto-completions. The MongoDB shell is built in, and you can even export queries and aggregations from your playgrounds to other programming languages right from inside VS Code. First, install the MongoDB for VS Code extension if you haven't already. You can search for MongoDB in the Extensions panel in VS Code or use the link in the video description. After installing it, go to the new MongoDB tab on your sidebar, and let's connect to a database using our connection string. Now, if you need help setting up a new MongoDB Atlas cluster, take a look at this video, which is linked in the video description. You can also connect to a local or self-hosted MongoDB database. Now that we've connected, we can see all of the databases associated with this cluster. We can expand one of these and we can see the collections in it. This collection, for instance, has 24,000 documents. And we can quickly see how the documents are structured by looking at the schema. This is extremely useful when you're trying to build out a query, since it lets you quickly identify which fields you can query and what the field types are. Now, the schema is inferred from a subset of the documents in the collection. You can also see indexes on each collection and even add indexes without leaving VS Code. This makes it easy to ensure that the query that you're writing is covered by an index. We can even open one of these documents right here in VS Code to get an idea of its structure and we could update and save the document back to the database if we wanted. And we can also easily see the different types of collections based on their icons. Here I have a time series collection alongside other regular collections. But one of the best features of this extension is the MongoDB Playgrounds. Playgrounds are JavaScript environments where you can run any MongoDB shell command, and they're really great to prototype queries and aggregations. Playgrounds also play nicely with JavaScript tools like ESLint and Prettier. So let's go ahead and create a playground. Now this is just a file, and it comes with a template that shows examples of how to use the playground. So again, this is using standard shell commands. So here we're using the MongoDB VS Code Playground DB database. Now, I don't currently have that database in this cluster. We can go over to the MongoDB tab, and we can look at this cluster and see that it's not there. So when this playground is run, it will create this database for me. And next, we're going to get the sales collection and then insert several documents. And then we're going to execute a find and then console log the sales count that occurred on April 4th, 2014. And then finally, we're going to execute an aggregation pipeline, which looks at all of the sales for 2014, and then we'll see the results for that.
And hello from .local London. We have Gaurav with us. Gaurav, could you introduce yourself to the listeners?
Yeah, I'm Gaurav Ariel. I am a senior product manager here at MongoDB, and I specifically work on developer tools. And even more specifically than that, I work on the MongoDB shell and our ID extensions.
Nice. And I'm Richmond Alake. I'm going to be your host temporarily for this segment. So, Gaurav, what are we talking about today?
Yeah, so today we have two exciting things that we announced at the keynote. One of them is the IntelliJ plugin, which is now in private preview. And the second one is the VS Code Copilot extension, which is now in public preview. And both of them we've extensively worked with our partners at Microsoft and at JetBrains to develop, so we're super excited to kind of have the word out.
Nice. That sounds like a lot of productivity tools for our developers. Could we take a step back and could we explain what exactly these extensions are or copilots are?
Yeah, for sure. So I'll start with the IntelliJ plugin. The IntelliJ plugin, if you're a Java developer, IntelliJ is something that either you're actively using or you have definitely heard of before or have tried it before. So really the goal was to meet you as a Java developer, meet you where you are in your journey in developing your application. And ultimately what we wanted to do, so IntelliJ already had this ability to kind of connect to your MongoDB cluster, browse your data, etc. But we wanted to go kind of a step further than that and see how we could help you in your application development journey to make that faster and more efficient. So that was effectively the underlying goal of why we wanted to build the IntelliJ plugin. And today, in private preview, we announced some capabilities that we've already built, which are autocomplete, type validation, and being able to run queries, your Java queries, directly in a console so you don't have to translate back and forth going from Java to shell syntax when you're testing your queries. And then finally, having proactive performance insights. And the one that we demoed at the keynote today was being able to see queries that are missing index that may potentially be slow, and being able to proactively warn you about that before you hit production with something that may potentially be slow.
The demo at .local was very brave, and it was also very interesting. And it seems like, obviously at MongoDB, we love our developers, and we really think about developer productivity. Could you also talk about the VS extension as well?
Yeah, for sure. So yeah, the second part to that is obviously the VS Code extension, and more specifically what we announced today, which was the public preview for the Copilot extension in VS Code. And for the Copilot extension, we've seen Copilot kind of emerge as this like default IDE assistant, in-IDE assistant over the years, or past couple years especially. And we wanted to once again follow that theme of meeting developers where they are. And we wanted to supercharge Copilot to have this MongoDB domain-specific knowledge and domain-specific capability. So we deeply integrated the Copilot extension with our existing MongoDB VS Code extension so that you can do things like talk to Copilot to create queries from natural language. And because it has this deep integration with the extension, it is able to kind of know your collection schema and produce an accurate query that you can then run directly using the extension within the Copilot chat, which is super, super amazing. So I think what we really prioritized is we're going to let Copilot do its thing with LLMs and anything related to generative AI. But what we want to do is bring in the user experience that will really complement that and not kind of like force AI into our workflow, but rather see where AI can complement our workflow that we've already wanted to do for our developers. And I think we did a really good job accomplishing that. So some of the things that we introduced today are being able to talk to our documentation chatbot directly from Copilot, being able to generate natural language to query, and also being able to explore your collection schema directly with Copilot. So I'm super excited about those features.
That's so exciting, and I can imagine the productivity gain for developers here to do everything within the IDE and not have to leave the IDE to go read some documentation or some functionality. You get everything within your development environment. What is the call to actions for the people listening and watching?
Yeah, for sure. So the call to action is for the IntelliJ private preview. We have a form, we have a website on mongodb.com for IntelliJ specifically. You can go and sign up on a form. As we have more slots to onboard private preview users, we're going to be slowly rolling that out to you. And the key here is that we really want to partner with you and build together something that is going to improve your workflow in terms of building applications drastically. So that's one. And for the VS Code Copilot extension, it is available in public preview today. You don't have to sign up for anything. You just go and download our VS Code, MongoDB for VS Code extension from the VS Code Marketplace. And with that, if you have Copilot installed, the Copilot extension should just exist there, so you don't have to do anything else.
Wow, exciting times ahead, and I'm looking forward to see what developers do with these extensions and these integrations as well. Thank you for your time, Gaurav, and it's been a pleasure talking today.
Absolutely. Thanks for having me.
Thanks.
The MongoDB for VS Code extension is now generally available. There have been some amazing updates, so let me show you what it can do. At a high level, the extension allows you to navigate your databases, collections, and documents in MongoDB. You can get a quick overview of schemas and indexes. You can use playgrounds to aggregate and to write scripts. It's great at rapid prototyping. You can edit documents and save changes to the database. It has intelligent auto-completions. The MongoDB shell is built in, and you can even export queries and aggregations from your playgrounds to other programming languages right from inside VS Code. First, install the MongoDB for VS Code extension if you haven't already. You can search for MongoDB in the Extensions panel in VS Code or use the link in the video description. After installing it, go to the new MongoDB tab on your sidebar and let's connect to a database using our connection string. Now, if you need help setting up a new MongoDB Atlas cluster, take a look at this video, which is linked in the video description. You can also connect to a local or self-hosted MongoDB database. Now that we've connected, we can see all of the databases associated with this cluster. We can expand one of these and we can see the collections in it. This collection, for instance, has 24,000 documents. And we can quickly see how the documents are structured by looking at the schema. This is extremely useful when you're trying to build out a query, since it lets you quickly identify which fields you can query and what the field types are. Now, the schema is inferred from a subset of the documents in the collection. You can also see indexes on each collection and even add indexes without leaving VS Code.
I'm going to bring on my colleague Dominic and also from AWS, Igor. Welcome both. How are you?
Well, hello, Shane. Long time no see, Dominic.
Hey, how's it going? Good to be here again.
Hey.
So for our audience, I suppose, Igor, you've been joining us before. Dominic is always on our AWS Cloud Connect, but maybe for the audience that mightn't be familiar or new people, Dominic, why don't you just introduce yourself and tell us what you do here in MongoDB, and then we'll jump to you, Igor.
Sure. So, hi everyone. My name is Dominic. I've been at MongoDB for roughly 3 years now. I originally started as an engineer, which is still kind of like my focus, but I'm part of the developer advocacy team now, closely working with AWS, which is why Igor and I reappear together on our streams. Yeah, and that's your transition, Igor.
Oh, is it? Oh, I was thinking like some metaphor, like a bad penny. You keep turning up, Dominic and I, or two bad pennies. I don't know what to do. What you say over there, overseas. Anyway,
Well, we do hold a record of probably the longest episode of MongoDB TV Cloud Connect. I think we did 2.5 hours building our Leafstroids game. So if the audience want to go back and go through that, it was great fun. That's why it took so long to do. It was great. We built it. Dominic and Igor built it from scratch. So do have a look at that past episode.
That was a big one, yeah.
Anyway, I'm going to introduce myself, Shane, right? So Igor Alexeyev, Partner Solutions Architect at AWS, working very closely with MongoDB. And I'm happy to be a reoccurring, repeating guest. Yes, I was on that Listeroids inaugural show, Death March, you can say, which we survived. But Dominic did not come out unwounded, unharmed. But
yeah, well, out of that episode, yeah, but not from the next episode that we did last week at the conference. So I might still sound a bit like my nose is not in the right place, and that's why, yeah.
Cool. So shall I share my screen, or should we just continue talking?
Yeah, no, well, look, as I said in the introduction, we're going to... Welcome back again to the show floor. It's getting busy. It's lunchtime, so there's a lot of background noise. We do hope you're not picking too much up, but hopefully it won't distill this interview with my guest. Igor, you've been on the MongoDB TV live streams lots. You've been previously on the live streams that we do at .local New York. Igor, Principal Partner Solutions Architect from AWS, you're very welcome.
Thank you, Shane. Thank you for inviting me. I almost feel like a TV star.
Well, you pretty much are now. We'll have to give you a badge for repeat performances and returning performances.
I'll need some sponsorships. Finance.
Well, listen, it's always great to have you on board. Yeah. In the context of our MongoDB ecosystem with AWS, there's so much that we can talk about.
Yeah.
We've only got the 10 minutes of our slot, unfortunately. So let's double down on a couple of the more recent things.
Yeah.
Talk to me. Obviously AI has been the topic of most of the interviews earlier today as well too. Talk to me a little bit about Q, Amazon Q Developer.
Right. So Q Developer, yes, you're right. It's a big focus, and it's focused for you because you want your developers to have the best experience, and developers, in particularly on AWS, you want to have the best experience. So I know you, Shane, worked specifically with us to train and fine-tune Q Developer on data sets specific to MongoDB code. The code so the code we generate now, it has approved patterns from you. Look, you've supplied the data set. We've done a first iteration, and I think that we announced at, I think, at New York event, right?
Yep.
And now we're talking about, like, as MongoDB evolves, you are supplying new data sets. So it's more of a kind of becoming an ongoing process.
Yeah, and look, the training and fine-tuning of the foundational models never stops.
Right.
We're getting better at it. We're getting better at giving you better data. It's great. And we've had a really good collaboration with the Q team in AWS. And now we're able to look forward to other things. Talk to me a little bit about migration and modernization, etc., using AI in the likes of Q.
Yeah, I know you guys are working on developing the tooling needed for modernization and migration in the apps. In Q Developer, there is a way to do processing of the data, processing of the code on a multiple file basis. We're hoping you're going to use that in your tooling. So Q Developer, you can, for example, ask it to look at the repository, see what's going on there. Or you can say, I want to migrate the whole project. At the whole project level, you can migrate. So yeah, and then we're working on kind of integrating with your tools and that. So that's something yet to come.
Yes, yeah, but it makes a lot of sense because I suppose the code assistants originally are there to help developers speed up the process, etc. as well too. And this is just the next level of that.
Exactly, exactly. So like you said, originally it was mostly around code completion. So how as developer types something, we can predict what they want to type next, and we'll provide those inputs. You can cycle through them using arrow left, arrow right keys. But now we're going into the next level of working with you to help customers migrate and modernize their applications. Q developer support several patterns right now, like Java migration from one, like version 7, 8 to like more modern, more recent versions. But the same process can also apply to taking a relational backed application, relational database backed, and migrating it to something more modern like MongoDB Atlas.
Excellent. And taking, I suppose, the AI products that AWS has a little bit for, like you've got Q for Business.
Yes.
And also Bedrock as well too. So first of all, Q for Business. Explain it, because it's relatively new, right?
Yes. So our stack consists of 3 layers, and the highest highest layer is the most abstracted away. It's focused more on the end user experience, meaning a user comes in, they don't necessarily need to choose a model, they don't need to know which models are which. It's abstracted away from them. They primarily doing configuration and supplying their data. And that allows users to create an application that can do some function. We can create a chatbot in a few clicks. And that's the higher level analyst type configuration, mostly no coding or little coding application.
As little as possible. Yeah.
As little as possible, exactly. So the idea is to quickly start. Now, if a developer persona wants to create an application and they want to choose a specific model, they want to control the data sources, how they ingest it, and maybe even and have there are some other features like you can add guardrails, for example, and you want to control what's in those guardrails. Then it becomes more of a Bedrock situation. Bedrock is a serverless service. You interact with it primarily via APIs, so it's a developer coding, making API calls. There are specific APIs, but you do not. You have choice of a model. You even you have exact control over the prompt. You like in the generative. We call the first layer. We call them generative AI applications. And those you might not even have control over the prompt. It is handled for you. Here you have exact control over the prompt with Bedrock. And that's where we see primarily developers kind of focusing on. Okay. And then we can also drop one last layer. It's where it's all about optimization. You want to optimize like if you want to reduce your latency, you want to control how inference is done on the model. You want to roll your own model. At that point, you would have data scientists involved.
Yes.
Yeah, it's more of a data scientist plus regular application developers working together, and it's a much heavier investment to build an application.
And as far as Bedrock is concerned, MongoDB is a vector store in Bedrock. You can choose MongoDB as your
Absolutely, yes. MongoDB is one of the few vector databases that is used in Bedrock. And that kind of feature, the Bedrock knowledge base, is done primarily to help with automating the RAG application creations, where Bedrock will take care of data ingestion.
Yes.
They will take care of chunking. You can supply different chunks. Like you see a lot of discussion. What chunking strategies should I use? Like in a higher level, like Amazon Q, you don't need to worry about chunking. It will do it for you. In Bedrock, there is an option.
Yes.
What strategy you want to use. But then ingestion, as long as you have data on S3 and some other sources are coming, you don't need to worry about anything else. You just configure it. It will run a job. It will scan it. It will ingest it. It will push the data into MongoDB Atlas, and it will be available, and then you can add this to your application via APIs. Okay. You can start interacting with that application, making API calls, and it will use MongoDB Atlas under the hood.
Excellent. So, as a solutions architect, I know that you build a lot of demos, you build a lot of things, and you're out there talking to clients, talking to customers about what they build. What are some of the challenges you see I talked earlier in one of our previous guests, there's lots of nice proof of concepts out there.
Yes.
What are the challenges in taking a Gen AI app to production?
Yes, yeah, you're right, absolutely. Developers take a model, take a prompt, take user input, mesh it together, send it to the model, yay,
Gen AI.
done.
Yeah.
Okay, so next, what happens next? They send it to the executive. Executive types something, it gives them horrible answer, some hallucinations, who knows what, and like, oh, this isn't ready for production. So the challenge is controlling hallucinations. Then the data that developers hook in, if you don't have the right lineage, like if you don't track the lineage, primarily responses in a RAG, retrieval augmented generation system driven by the data that you provide, if you don't know where the data comes from, you will not be able to control responses.
True. Yeah. You open yourself up to, inaccuracies, outdated stuff. Not necessarily hallucinations, but you haven't controlled the data.
That's right. You need to be able to trace, like, this response was based on the data. Where is the data coming from? If users are saying this is not correct response, you have to be able to fix it, and for that you need lineage. You need data. I mean, traditional data in analytics type of processes of governance, lineage, data quality. All that has to be in place. Additionally, I see the trends where you've created a system like we just described, right? You need to have some sort of guardrails, controls.
Yes.
You need to be able to evaluate your response. Is it a good response? Is it not a good response? And you need to have that layer. Maybe you want to filter out some things. Maybe, or at least as a minimum, you should track to have some kind of feedback loop to get that information back into the product. It might even involve building a custom model that will be capturing the output of your conversation from the user. The responses that are sent to the users need to be maybe even graded by a human, and that will allow you to accumulate a label data set, and maybe that model will be sitting there and just kind of tracking, is everything happening? And that kind of means that application that you're building is getting more complex.
Yes, yeah.
And you've heard probably agentic systems recently.
Of course. We don't have time for that conversation.
No, the most interesting part.
Talk to me. So we published a blog post on our Developer Center this morning that you co-authored.
Yes.
It was essentially Anthropic, AWS, and MongoDB. Talk to me a little bit about that, the concept in there.
So it is Anthropic in, like I said, MongoDB Atlas, and we used several models. We used Titan embeddings from AWS, but the heart of the application is Anthropic Claude 3 Haiku model.
Okay.
So that's the model that does, it's the brains behind. And it's an agentic product. So in that product, we have several agents or tools, sometimes they're called. They're doing various functions. So in that, for example, when you work with RAG application, actually it's a misconception. People think you need to always have semantic search.
No.
Not true. No. It's about retrieval augmented. How you retrieved is another story. You can augment with a direct lookup. True. You can do semantic search. You can do lexicographical search. You can do graph. All of these are possible in MongoDB Atlas. So in this particular architecture, we used a lexicographical search combined with a direct lookup and combined with semantic search. And we created several agents, and depending on the user query, Haiku, Claude 3 Haiku, decides which agent to use.
Okay.
And that agent makes either a call that does a lexicographical search to MongoDB Atlas, or it does semantic search. And then those responses can be combined. And this is, I see it as an evolution of current generative AI application. That orchestration layer is getting more complex.
Sure.
There are more tools involved, or agents. They're doing specialized tasks, because if you know exactly what you want to do, if you know the exact query pattern, it's better be done by agent, not by like a semantic search, for example. But if it is a question which can be asked many different ways, that's why semantic search fits in better.
Perfect.
So in this architecture with Anthropic, we kind of focused more on a call center, customer service kind of area. We've created this. It runs on Lambda. It integrates with Lex, and Lex has ability to integrate with Amazon Connect, which is our customer support customer support product. So you can create a custom flow and how users will be interacting with the application, and you can add it to your either chat interface. You can also add it like to your voice prompts, and then help customers basically augment the customers, if I may say, customer service reps. Yes.
Yeah, I mean, there's a lot of moving parts to this as we get more complex. And as you say, the orchestration piece behind the scenes is super important. And that's, you know, if you want to have a look at that post, it went live on our MongoDB Developer Center, developer.mongodb.com. We'll get you there. And it probably should be top of the list if you go to the tutorial section, because it was published this morning. We probably published another few announcements this morning, but you'll find it pretty easy, or just search. For AWS at the show, and I know there's a stand and a few of your colleagues down there, what are you most looking forward to seeing today?
I'm looking towards interaction with developers, because you have a lot of developers here. They have interesting ideas how to build the applications with MongoDB Atlas, so that's exciting. Exciting to hear those ideas.
Excellent.
And there's my session a little bit later, and we actually have a lab.
Okay.
Yeah, where people can build an application with hands-on experience.
Great.
You should stop by.
If I'm not doing this job, I definitely will. Perfect. Igor, as ever, thank you so much. We'll have to get you like a badge or something about a repeat guest.
Sponsorship.
Yeah, and actually, before we go, you're a MongoDB champion
Actually,
now as well,
yes.
right?
I did get some swag. I have some wonderful shoes. I wish I was wearing them today. I can put it on the table.
Yeah, we
here.
don't get those shoes. Yeah, you'll have to show.
Can I put my foot on the table?
You're not. So, as a MongoDB champion, what does that mean to you?
As a MongoDB champion, I am promoting MongoDB within AWS. I want to make sure all the account teams on AWS are aware of what you can do with MongoDB Atlas in the context of AWS. Yeah.
Perfect. Very succinct, very detailed, very direct. So keep doing that. You're doing a great job. As ever, Igor, it's a pleasure to have you on board. It's always good to do these streams with you. I look forward to whenever we're doing the next one, which I'll probably twist your arm to do pretty soon as well.
Sure. Thank you for inviting me. Always a pleasure.
Excellent. Thank you, Igor.
Cheers.
Tune in shortly. We'll be back with more guests just after this break.
So this is kind of a walkthrough for using LangChain with MongoDB to build Q&A rack-based architecture. So first step is setting up the environment, right? Like you would set up your MongoDB variables, etc. You enter into that data preparation phase that we talked about. So in this, we are basically using a LangChain document loader to get the PDF, in this case that GP4 paper, 2 lines of code, you got a document, then you want to do this chunking. So in this case, we are using a method in LangChain called recursive character text splitter. So what it does is essentially like, allows you to set up what chunk size you want. In this case, it's like 500 tokens, like you can define a certain chunk overlap. In this case, it's 0. Typically, I recommend having a certain overlap that improves your accuracy between different chunks. Once you define that chunking strategy, you would basically just do it over the retrieved data. In this case, docs is where you will get like an array of these like chunked information. And then once this is done with the chunking stage, and the last stage is essentially like embedding it and storing it into a vector database. So that is happening in this step, right? So we have a LangChain native construct for MongoDB Atlas Vector Search. We are initializing it with these documents that we retrieved. We are specifying an embedding function. In this case, we are using OpenAI embeddings. And we are basically telling it which collection in MongoDB should it go into, and what would that index name, Atlas Vector Search index name be. So with this construct, it will take that all the documents, that all the chunks that we prepared, and create embeddings for it and store it into Atlas Vector Search.
Nice. So all of that
essentially
complex stuff we talked about at the beginning, chunking all that, LangChain really helps with that.
Yeah, exactly. So you have like 10 lines of code, and that's whole process is done. So then we talk about the query process. So you would do this once on all your data, and then ongoing basis you would be doing your data query. So in this space, we are initializing that connection to our vector search, right? So now all that information is sitting in your database, and anytime you have a downstream application, you initialize it. So you provide the connection string, MongoDB URI, database name, what embeddings you want to use. And then essentially using this vector search construct, you can start feeding in the question. So now the question, going back to that one, is how much better is GPT-4 in reducing hallucinations over GPT-3.5? We provide that question. We initialize like a large language model. In this case, we're using OpenAI's chat model, providing it the version, GPT-3.5 Turbo. You can plug and play different models here. And this is essentially your prompt, right? And then we essentially use this QA chain, which is a retrieval QA, is one of the chains that LangChain provides. In this case, it's beneficial use for like this Q&A kind of a setup. So as part of the retrieval QA chain, we provided the LLM, like what large language model we want, and we provided the vector source, like the vector search solution in this case, provided the retriever argument. So this is put into, so now it knows like, okay, this is where you submit your, get your chunks from, and this is the large language model you use for generating the final output.
Nice.
Then we call this with the query that we provided, and basically you get this result. So in this case, the result is GPT-4 scores 19 percentage points higher than GPT-3.5 in reducing hallucinations. So again, like, you know, less than 10 lines of code, and you have a pretty high performing, pretty decent search already. And then with, like, you know, MongoDB has a bunch of customizations with these LangChains where you can use pre-filters, post-filters, really tap into that power of MQL to build, like, you know, combine it together with these large language models to build really powerful experiences.
Yeah, and the MQL, so the aggregation pipeline stages, there's a vector search stage, so you can combine that, do stuff before and after, correct? Like, there's so many possibilities with this.
Yeah. We recently announced dollar vector search stage and last week, and we already have integration updated on LangChain, which uses that dollar vector search stage.
Nice.
So yeah, we are very invested in these frameworks. We are going to be, like, you know, continue improving and iterating on those. But yeah, post filter, like, you know, with this dollar vector search stage, you can really tap into those rich semantics of different operators like equal, less than, etc., to be able to combine with your filters that we talked about in the beginning.
Nice. Yeah. So if you stuck with us through the entire stream, the beginning part was the hard part.
Awesome. We are on for our next session now, and I've been joined by one of the MongoDB champions and a great forum contributor, Ninad. Ninad, why don't you introduce yourself?
Yeah, hi Harshit. Thanks for having me here. So I'm Ninad, a senior software engineer in a company called Fatvi. We provide legal services to companies to help them go international. Like services like company formation, bank account opening, trademarks, patents, bookkeeping, accounting, compliance, everything legal that they would need. We help them with that, and we make sure that the process is as smooth as possible and as cheap as possible for everyone.
Awesome. And a bit about your journey with the forums and being a champion, like, yeah?
Yeah, so actually I started in a freelancing, you know, and I started in JavaScript ecosystem. So I was working with Angular on the front end and Node.js on the back end.
Okay.
And when I started with relational databases because that is what they are teaching us in college.
Right.
But 5-6 years ago, I discovered MongoDB.
Yeah.
And that was completely new philosophy that changed everything for me because it was a perfect fit for a JavaScript ecosystem. For the first time, I didn't need the mapping layer where I would say, okay, this column from this table have to map to this property of a JavaScript object, right?
Yeah.
Now, like, I would construct my entities in my code, and I would know that that is exactly how they would be saved in the database, and vice versa. You know, like if I would fetch something from the database, I would know that is exactly how my JavaScript object would look like. So that is like the main point that I loved and like that
Amazing.
Makes me use MongoDB after that exclusively. Another point was the flexibility of schema, because as you know, when you develop new applications, like you cannot know all the requirements immediately. Some things you discover as application evolves.
Yeah.
And when that happens, like you have to change some things in the code, obviously.
Right.
So usually you would have to change some models in your schema for the database as well. And MongoDB made it like as easy as possible.
Yeah.
Just change some property, remove it or add it, and it is as easy as that. And before, you would have to write some complex migration scripts and be careful and worry about everything. And now, like, everything is done immediately. So that was another main point for me. And after that, when I discovered MongoDB, I never ever used relational databases again. If you would ask me now, I would not even know how to write a SQL query anymore.
Oh God.
Yeah.
I mean, yeah, very true. The flexible schema makes it very interesting for, as well as the working with something that is like as similar as to in your code and then in your database as well.
Exactly. Perfect fit. Direct mapping, everything. Yeah.
Right.
Especially JavaScript ecosystem. I would expect the other ecosystems to be the same, but in JavaScript, a perfect fit. Perfect.
Awesome. No, thanks for sharing your journey and thanks for sharing about how you have come up here and how you got into MongoDB and I know you shared a bit about MongoDB and how it fits into the mix of things and how it works perfectly for developers. But just going step back a little and see from the top, how do you think MongoDB fares with a relational database nowadays?
In my opinion, like MongoDB will just go up. There is no way it will go down. It will only go up. It is perfect for all the modern applications. The only way I think it is falling back against relational databases is because all the CTOs are now like, I don't know, 50 years or more, and they were born and they worked with relational databases from start. So they are hesitant to switch over to something new. Yeah. But new generations will always, in my opinion, always use something for the modern applications, and all new applications will keep using some modern databases as MongoDB. All the people I know, and I am in the startup ecosystem for like 6 years now, everybody is using Mongo, and I never had to use relational databases for any type of the application ever since I started with Mongo. And I worked with many different sectors like e-commerce, legal, HR, recruitment, analytics, like everywhere the Mongo is used nowadays.
And it has done the job.
Yeah, perfectly.
Awesome,
yes.
Awesome. I will go into some other direction right now, which is basically you are a MongoDB community champion.
Yes.
You are a MongoDB user group leader. You are contributing on the forums of MongoDB and helping people out. What motivates you to do that? What motivates you to give back to the community? And for the listeners today, how can they contribute to the community? Yeah.
Got it. So when I started, as I said, I started in a freelancing, so I had to learn as much as possible to be competitive on the market, right? Yeah. And usually all the developers visit Stack Overflow at least once in a day. I was visiting multiple times in a day, and when I got enough knowledge to know a lot and that I can share with others, I started writing answers. Wow. And when I started writing answers, I discovered that I was learning the more than I expected by just writing answers. Usually, I would know how to help somebody, but there was like a missing pieces that I would have to cover for their specific use case. So I had to discover these missing pieces initially in order to give them the complete solution. And then, like, that is where the dots are fitting in your head. You know. So I would suggest everyone start with Stack Overflow, and then obviously with MongoDB community forums. That is like, for people that don't know, that is like a Stack Overflow, but for MongoDB exclusively. Then I started my own blog. I was writing articles on my own blog. Then I was invited to write articles for MongoDB blog, where like it was like the most amazing thing ever, because like MongoDB is read by millions of people. So it gave me like a big exposure. That is like the best thing you can have. Also, when somebody tells you thank you, you know, that means a lot. When you help somebody, when you know that you helped somebody, that is like a big thing. So yeah, like you can contribute, you can join the community. There are local MongoDB user groups everywhere. So we started one in Serbia 3 months ago, and we are having like another meetup this month about AI and new RAG systems and vector search and everything. So I would invite everybody to join their local communities, get to connect with other people, meet like the experts from the field, and get enhance their knowledge.
Yeah. No, thank you so much. I think just to summarize what Ninad mentioned, Ninad mentioned that we should start learning by helping others. He had a similar journey. He went on to forums. He made sure that he's trying to answer everybody as well as in that process learning something. And he suggests that you should go to your local meetups, meet the community, interact with them. If you are in Serbia, Ninad leads a meetup in Belgrade, and he will be, he'll be running a meetup next month. This month, sorry. A meetup this month. It's October already now. And he'll be running a meetup on AI, RAG, and building vector search systems with MongoDB. Yeah. Awesome. Ninad, one last question before we head for the day. Which is something around this event and MongoDB 8.0. If you have been hearing about it, what is that is keeping you most or exciting you the most?
Oh, for 8.0, I would say credible encryption. That is like the feature I like the most, because now you don't have to worry about like most of the compliance to be in regulation with GDPR and all the legal stuff in various countries. If you need to encrypt your data, you can just now, you don't have to worry about the business logic on your side, on the application side. You can just leverage the MongoDB client that do everything for you, and like you can even query the encrypted data. That's amazing, and that's like unique for MongoDB.
Yeah. We are very excited about that as well. Yeah. All right, thank you so much, Ninad. It was great having you, and it's been great being with you and other champions here this week. And we hope to see you contributing more and learning more with us. Thank you so much.
For having me.
Thank you.
It was a pleasure. Yeah.
Hi, my name is Luca Napoli, and I'm a consultant for industry solutions at MongoDB. In this video, we'll see how insurers can streamline the claim adjustment process with AI, easily comparing photos using a vector database, saving time and enhancing accuracy. Let's get started. When an accident occurs, a car crash for instance, insurance companies need to determine the payout for their customer, which in the industry is usually referred to as the loss amount. This process is carried out by the claim adjuster, and it is typically done by hand. The adjuster has to gather all the information necessary to determine the entity of the damage. This means searching for insurance guidelines, related photos, accident notes, contracts, and more. The documents are usually contained in several different systems and repositories, making the quest slow and error-prone, as the adjuster might forget or miss a piece of relevant information, which results in an inaccurate loss amount estimation and a potential loss for the company. In addition to that, some of the data can be unstructured, which makes it difficult to index and search. Just think of how hard it is to find information in PDFs, audio files, or videos. Today, we'll see how MongoDB helps insurance companies speed up the process thanks to Atlas Vector Search. Claim adjustment can be streamlined in 3 steps, with a growing level of complexity and delivering value at each step of the journey, leveraging the document model, adopting vector search, and lastly by building a retrieval augmented generation system, or RAG in brief. Let's go through each of them. The first step is to store our claim data in a MongoDB collection. In this example, our document contains information about the claim, such as the loss amount, some notes about the accident, and the reference to the photo. Now the data is easy for applications to access and query. Let's now move on to adding Atlas Vector Search to the mix. This MongoDB feature lets us index and query arrays. The first thing we need to do is create a vector search index. The slide shows how to configure it in the Atlas UI. It's as simple as editing a JSON where we specify the dimension of the array to be indexed, the similarity measure we want to use, and the name of the field that contains our vectors. After the index creation, we need to generate the embeddings of our photos. This is done by passing our pictures to an embedder that will convert our files to vectors that represent the objects in a vector space. This process is external to MongoDB and can be performed with the model of choice of the user. Ultimately, the vectors are stored back into our collection. We see how the schema has been augmented with a field name embedding, which contains the vector representation of the image that our model generated. At the end of the video, we'll jump into code examples and we'll see how this works in practice. At this stage, we have created a search index and stored our vectors into the collection, and we are ready to query the data. As shown in the diagram, the first thing we need to do is vectorize the query image and pass it to Atlas. The query syntax is also shown later on when we'll go through the code. So we have interrogated Atlas and boom, we got 5 images back as the answer. The most similar images to our query image, representing the closest thing to a damaged windshield we have stored in our collection. This is a very different kind of response we're used to getting from a database, which is typically an exact answer to our query. If, for instance, I ask MongoDB to return me all the persons whose names start with A, I get all the documents corresponding to that, precisely that, not names of people that are similar to that. This is the fundamental difference between exact queries and vector search, which will return objects that are semantically similar. This opens the door to many new use cases. If something can be vectorized, now we can query it. So now we can leverage unstructured data.
All right, we are almost midway through the .local London here in Paddington, near Paddington and Hilton Metropole here. And we have some exciting updates being shared today this morning in the keynote. And right now we have been joined by Elijah. She is the staff product manager on our MongoDB University team. And before I go ahead, Elijah, why don't you introduce yourself?
Sure. As Harshit said, I am staff product manager for developer education here at MongoDB, with extensive experience around technical education and really supporting developers where they are, when they need it, with what content they want to learn.
Awesome. I think before I get into like asking some of the questions about what university is bringing here today as well, I know there are a lot of learners, listeners here today who don't know about MongoDB University.
Yes.
So I'll act someone as if I don't know anything and ask you these questions from their perspective. Yeah. So we'll start with, of course, what is MongoDB University? Is it a college? Do we need to pay? What type of courses do you have? And what can I learn as a developer of different skill set?
Great question. So you do not need to pay. We are a free online learning platform that when we offer a variety of content so that you can learn any content anywhere at any time. We have a solid library of foundational content for developers, DBAs, for data modeling, and for Atlas administration. So it's a really good starting point. And we've really structured that foundational knowledge to then serve as a jumping off point for additional advanced content. So we're starting to build out more around many of our features such as Atlas Search, Atlas Vector Search, et cetera, to kind of keep leveling up and providing the opportunities for our developers to learn what they need to grow.
Interesting. So there's a big landscape, and anybody at any stage of their career could enter in and learn from different courses that you have on the MongoDB University.
Yes.
All right, one more question there. So is it just I have to go through videos and listen to someone, or the learning becomes exciting with some labs and hands-ons, and what happens there?
Yes, no, great question, and yes, the answer is we have a variety of modalities. We do have videos that you can watch and follow along, transcripts in different languages, which is really helpful for just opening it up globally. We also have multiple choice questions to check your understanding, just so you know that you're learning. And then, as you mentioned, we have these hands-on labs, which really provide a safe practice space to learn, basically practice what you're learning. So you're learning while you do, which is one of our theories underlining our design.
Interesting. I'll wear my MongoDB hat again, and I'll tell you the hands-on labs are absolutely amazing. They let you know that how you need to really implement the concept you have been learning, and let you really try it out in various ways as well. So thanks for sharing that, Elijah. Yeah. I know that when these learners they get onto these platforms, they are learning something. They are looking for some accreditation to understand that, yes, am I doing well? Am I going ahead well? I've heard there are some university learning badges coming up.
There are, yes. We're very excited about this new education product. We currently have a set of certifications, which are longer learning experiences that lead to a certification exam that you do need to pay for, but that validates in a proctored way that you understand what you've learned with certification.
Okay.
What we wanted to do was design some educational products that are shorter, that are low stakes, meaning like you just take a quiz at the end, an assessment at the end to get a badge, and it can be done in 2 to 6 hours rather than 20 hours. So it really does allow some flexibility, and they're stackable. So if you take one, for instance, our first building Gen AI apps with MongoDB, when you finish that one, you can take our next one, which is deploying and evaluating Gen AI apps with MongoDB. So they build on each other, and it allows us to stay very current with what's happening with our features and capabilities as we grow as a company.
That's really interesting. I'm looking forward to get some of those badges. And if you are getting those badges, please share on social media and let us know that how are you progressing with your journey. One last question, Elijah, which is going to be based upon, I know AIs, chatbots, RAGs, MongoDB is building a lot in there. And I know you have a cool solution on the university education side that is helping our learners to go on the website and interact with the some of the AI concepts that we have implemented.
Yes.
Could you share about the Docs chatbot, which
Yes.
has been a hit?
Yeah, so we wanted to build a Docs chatbot with our own vector search. So we started out with the chatbot on documentation and really tested it and did a lot of POCs with it, honing it in order to basically reach the level where then we could put it on Dev Center and we could put it on University. So now when you visit documentation, University, and Dev Center, you can use our chatbot to find answers to the questions you want, to ask about what courses we may have, what topics we cover in University, etc. So it's a really exciting way to both partner with our search tools, but also then we have our chatbot. So we're excited for everyone to use it.
That's amazing. I know sometimes you want to, you have a complicated question and you can just go into the chatbot, ask the chatbot, and you'll get the right direction from there.
Exactly.
Which is the best part.
Yes.
All right, Elijah, thank you so much for being with us today.
Absolutely.
And hope you're having a good time at the event.
I'm having a great time, and I hope everybody comes to University and learns more and more about MongoDB.
Awesome. Thank you so much for joining us today.
Thanks,
Thank you.
Harshit.
Have you heard of the fourth industrial revolution? The first was mechanical, the second was mass production, the third was automation, and the fourth, we're in the middle of it, it's artificial intelligence. There is a fundamental change happening in the way we live and the way we work, and it's happening right now. While AI and its application across businesses are not new, recently generative AI has become a hot topic worldwide with the incredible success of ChatGPT, the popular chatbot from OpenAI. It reached 100 million active monthly users in just 2 months, becoming the fastest growing consumer application. The closest to this was TikTok, and it took 9 months, which is still really fast. So what powers ChatGPT? Large language models, LLMs. In this video, we're going to talk about how you can leverage the power of LLMs on your private data to build transformative AI-powered applications using MongoDB and Atlas Vector Search. We're also going to walk through an example of building an application that uses semantic search, machine learning models, and Atlas Vector Search for finding movies using natural language queries. For instance, to find funny movies with lead characters that are not human, that would involve performing a semantic search that understands the meaning and intent behind the query to retrieve relevant movie recommendations and not just the keywords present in the dataset. Using vector embeddings, you can leverage the power of LLMs for your use case, like semantic search, a recommendation system, anomaly detection, or a customer support chatbot, which are all based on your own data. Now, to do that, we first have to understand what vector embeddings are. Well, a vector is a list of floating point numbers representing a point in an n-dimensional embedding space, and that captures semantic information about the text that it represents. For instance, an embedding for the string MongoDB is awesome using an open source LLM model called
AllManyLM L6v2
would consist of 384 floating point numbers, and it would look something like this. Now later on in this tutorial, we're going to cover the steps to obtain vector embeddings just like this. So now we know what a vector is and vector embeddings. Well, what is vector search? Well, vector search is a capability that allows you to find related objects that have a semantic similarity. That means searching for data based on meaning rather than the keywords present in the dataset. Vector search uses machine learning models to transform unstructured data like text, audio, images, and other types of data into numeric representations called vector embeddings. And these capture the intent and the meaning of the data. And then it finds related content by comparing the distances between these vector embeddings. Now, the most commonly used method for finding the distance between these vectors involves calculating the cosine similarity between two vectors. But that sounds way too complicated for my brain to comprehend, so I just want something that can just do this for me so that I don't have to think about it. And this is where Atlas Vector Search comes in. Atlas Vector Search is a fully managed service that simplifies the process of effectively indexing high-dimensional vector data within MongoDB and being able to perform fast vector similarity searches. With Atlas Vector Search, you can use MongoDB as a standalone vector database for a new project, or augment your existing MongoDB collections with vector search functionality. Having a single solution that can take care of your operational application data as well as your vector data eliminates the complexities of using a standalone system just for vector search functionality, such as data transfer and infrastructure management overhead. With Atlas Vector Search, you can use the powerful capabilities of vector search in any major public cloud like AWS, Azure, GCP, and achieve massive scalability and data security out of the box. So let's move on to the tutorial now. We'll be using a movie dataset containing over 23,000 documents in MongoDB, and we'll use the
All-Mini-LM L6v2
model from Hugging Face for generating the vector embeddings during the index time as well as query time. But you can apply the same concepts by using a dataset and model of your own choice as well. You will need a MongoDB Atlas account and a Hugging Face account for a hands-on experience. When we're looking at a movie database, it may contain various types of content such as the movie description, plot, genre, actors, users' comments, movie posters, etc. And these can all easily be converted into vector embeddings. Now, in a similar manner, the user query can also be converted into a vector embedding, and then the vector search can find the most relevant results by finding the nearest neighbors in the embedding space. Now, for our first step, we'll need to set up and connect to our MongoDB instance. If you don't already have a MongoDB Atlas account, it's completely free. There's a link in the video description below. And if you need help getting your first cluster set up and running, there's a great video right here that can walk you through that. Now, for this tutorial, we'll be using one of our sample datasets, the sample_mflix database, which contains a movie collection where each document contains fields like title, plot, genre, cast, directors, etc. And we're going to use Node.js, but if you'd rather see examples in Python, there is a written version of this tutorial linked in the video description that uses Python. All right, so I have an empty directory here, and we're going to initialize a new project. So npm init-y to accept all the defaults. Now we have our package JSON. Let's also npm install MongoDB. Now I've created a main.js file. We're going to require MongoDB. We're also going to use .env to use environment variables. I know that this is built into Node.js now, but in case you're using an older version of Node.js, you will still need to use the .env package. And in fact, I forgot to install that. So let's do npm install .env. And then we're going to get our URI, which is going to be our MongoDB connection string. Now to get your connection string in Atlas, just go to your database and click connect. And then under drivers, we're using Node.js. And so this would be my connection string. You'll need to copy yours because yours will be unique to you. So I'll copy this back in VS Code. Let's create a .env file. So I named this MongoDB connection string, and then I'll paste in my connection string. I'll also need to enter my password here. So I'll do that and then save it. And next we'll create our client by creating a new Mongo client and using our URI. And then our main function is just going to test to make sure that our connection is working. So it's an async function. We're going to await client connect. And then we're going to await an admin command called ping1. And if that is successful, we should see that we have successfully connected to MongoDB. After that, we'll close our connection, and then let's just call this and use catch and console dir if there is an error. So let's save that, go into our terminal, and let's run node main. And there we go. We've successfully connected to MongoDB. So for step 2, we need to set up the embedding creation function. And there are many options for creating embeddings, like calling a managed API, hosting your own model, or having the model run locally. In this example, we're going to use the Hugging Face Inference API. Now, Hugging Face is an open source platform that provides tools for building, training, and
Welcome back to the show floor again at MongoDB.local London. It's great to have you. Shout out to our sponsor Cohere as well too. Thank you very much for your support for everything that we do today. Another guest, we're back to a MongoDB guest. We have Evan Roseley, who's a lead product manager. And Evan, how are you? Welcome to the live stream.
Good, how are you doing today? It's been great here at MongoDB Local. We're learning a lot of good information with all the talks and sessions, so it's been great to see.
Good, good. What have you seen outside of the things in the keynote that were announced? Have you seen around the show floor anything that's exciting you?
Seen around the showroom floor a little bit. I've been trying to focus on a little bit of talks and then talking with the different interactions with customers, which has been really good. Just learning, being able to see them face to face. In this world, we don't get to see that much anymore. So it's been great to really have that human connection.
The serendipity of the conversations, they just don't happen online.
Yeah.
Like, it's the type of sidebar conversations, the hallway conversations, those things are brilliant, Evan. Tell us a little bit about your role in MongoDB, the day job, as it were. What products are you looking after?
Yeah, absolutely. So I'm a lead product manager here at MongoDB. I look after a couple of different areas, but my main areas are all of the backups within MongoDB.
Okay.
So that's our on-premise and also our cloud offering of MongoDB Atlas.
Mm-hmm.
And then also what we call our Ops Manager and Cloud Manager products, which help our customers in the Enterprise Advanced world deploy Enterprise Advanced on their own premises. So it's that automation, management, backup layer that comes for those on-premise.
And what have we announced that's new for Ops Manager here or recently?
Yes, so for Ops Manager, we actually announced today that we have Ops Manager 8.0 coming out. And the big thing of that is that helps you support, deploy, automate, do everything that you can normally with Ops Manager with MongoDB 8. So there's a lot of great aspects there, but really it's just ensuring that you get all of the latest, greatest features and functionalities with MongoDB 8. And you don't have to worry about deploying it on your own. It's all built right into the Ops Manager on this version.
Excellent. And Sahir in the keynote said it's the best MongoDB ever, so it's benefiting from all of those under-the-hood performances.
Yeah, absolutely. So it's benefiting from all of that as far as the database itself goes. And what we really wanted to make sure with this release is that it was on time with the MongoDB 8 release, so that it helps customers that are ready to get that performance upgrade and all those different features quickly. So right now you can go onto our download site within MongoDB Download Center, and you can download that right now, and you can start deploying a brand new MongoDB 8.0 cluster, or you can start upgrading your existing one, and Ops Manager will know how to do all of the same things that those customers are used to, but doing that in MongoDB 8.0.
Okay, and keeping, bringing these new features, how much of a task is that for the team that you manage and look after? How long is this in development?
Yeah, so we really work all year on the development of Ops Manager. It's very, very consistent. We have probably about 8 different engineering teams that are tied into that. We actually brought a new one recently on to also add some more resources to the Ops Manager aspect of it. So we work all year to get this going. We obviously have a lot towards the end to make sure it's tested and everything with the newest and latest release. So everything's been fully tested with MongoDB 8, and that's been a real focus in the last 2 months. But a lot of other development has happened in the beginning of the year. A lot of that is in some of our older Ops Managers, so our Ops Manager 7 and even some of our Ops Manager 6, the 2 other versions that are still supported. So we try to do as much as possible to put some of those features in those older versions as well, so that they don't have to wait all the way till this time of year. But there's a lot of constant development going on there.
Okay. So in your introduction, you also spoke about backup. We were chatting before we came on air about, you know, historically backup is the thing that you think about once you have to have thought about it, so something went wrong.
Right.
But I know we've got a huge amount of tools in that space. And talk to me a little bit about the things that a developer needs to be considering with regard to their backups, and particularly with the context of MongoDB Atlas.
Yeah, so that's a great talking point, because as you mentioned, people know they need backups. They hope that they never actually have to use them.
Yeah.
But they know
that's why it doesn't get the attention it deserves, because they're going, I don't need this.
Right. So we have a lot of things within MongoDB Atlas that are provided for that. I like to try to call it a one-stop shop, so to speak, as far as the disaster recovery and backup recovery aspect. But I think the important thing for folks to know is that you should configure it to something that fits your actual requirements. We do have things out of the box that are automatically turned on when you turn on a cluster in MongoDB. We have things like our point-in-time recovery, which we call continuous cloud backups, that allow you to restore to a very specific point in time. You can go as granular as a specific timestamp of an operation.
Wow, okay.
And all that's great. That's on by default out of the box. You can turn that off if you need, but
so that's really helping you if you've deployed something, all of a sudden it's not working in the manner to which, so you roll back.
Right, exactly. So you basically say, hey, we had a deployment at 12:03. I would like to go back to 12:02 and 59 seconds, right before that. So I'm not losing any information, but I can know where that is. So it's really making sure that you can pinpoint exactly what you're doing and where the most recent data is, but maybe not the corrupted, or when you accidentally deleted something, or.
And I know you probably, by way of example, it was 59 seconds, but what's the granularity of that? Is it to that?
Yeah, it is actually to the timestamp that you can recover to.
Wow.
Yeah. So we give you as granular as possible. Basically, you can go into your operations, figure out what timestamp that operation that you deployed something was at, and then you can say, I want to do the timestamp right before that, and go back and recover right there in MongoDB Atlas. And that's all either through the API or the UI. It's really well built.
So a massive level of confidence in that respect alone. What are the other features of backup that developers should be concerned about and be thinking through?
Yeah, so the number one thing that I always tell people when I'm talking to them about what they should be looking at with backups is figure out the right type of schedule for you.
Right.
So what that means is in MongoDB Atlas, you can schedule, I want hourly snapshots, I want monthly snapshots, I want weekly snapshots, and it'll all trigger and happen for you. Now, what a lot of customers also want to consider is that cost efficiency with that. As you store more data, that's going to cost more money. And I think all companies, especially right now, are looking to optimize those costs. So don't just take the default schedule that we give you. It's a great one. It will cover you in a lot of instances. But you should really be looking at what are the real business requirements for your company. How long do you have to store backups? If you're looking at that point in time.
There might be a legal requirement for that, kind of a jurisdictional requirement.
Absolutely. A lot of countries have their own requirements. A lot of industries have their own requirements. There's things like AppJ for the financial services that they have to usually store data for about 7 years.
Okay.
And it has to be what is called immutable, which means that basically, no one can delete it, or you can't change the actual backup information. So you need to understand what that is first. It doesn't make sense to just say, I'm going to put 7 years for everything, right? Because there's a cost aspect to
Of course there is. These things build up and add up, certainly at scale, right?
And then there's other aspects that you can customize more. Some companies need to be able to show that they are having their data in multiple regions.
Okay.
So, if your main region goes down and that's where your backup lives, well, guess what? You can't recover because your backup was also in that region.
Yeah.
So within MongoDB Atlas, we have the ability to copy your backups across different cloud regions. Right. So if you're in, Europe 1 or Europe West, you can copy that to Europe East. And then if all of Europe West goes down in whatever cloud provider you're in, you still have your backups.
And does that also work multi-cloud across cloud providers as well too?
It only stays in the main cloud provider that you're taking the backups on. But you can export those backups out as well, or download those backups, and you can store them anywhere that you want. So you can export to either AWS S3 or Azure Blob. We actually are working on GCP for that feature as well. That'll be coming probably later next year. But you can export that out and hold that data wherever you want. We also export it out in a JSON format, so it's usable outside of MongoDB if you ever need that region. And that's also some regulations too, is to have it outside of MongoDB if they need it in
Yes, transposable basically.
Exactly.
And this is kind of regional policies and geographic. Is there other policies that come into the realm of backups?
Yeah, so we had one that we released about 1.5 years ago, actually, and it's called our backup compliance policy, and it's really focused around what I mentioned for that app.j immutability. It's a lot of more other requirements and regulations there too, but essentially what it allows you to do is it allows you to set a predefined period in your schedule where backups cannot be deleted by anyone in your organization. Doesn't matter the role, doesn't matter what access and privilege they have. They cannot delete that before whatever time period you set. So you don't have to worry about accidental delete or ransomware or anything going in and attacking that. You'll always have your backups.
Okay. You talk a little bit about ransomware there. Yeah. Tell us, the scenarios that you might encounter or hear from people and been able to recover from attacks such as that.
Yeah, every attack is unique, right? So, and people come to me because I'm on the recovery side and the backup side, but what I tell them first is look at the prevention side. Okay. You want to understand how to lock down that system well enough so that you never have to recover. The ideal situation is that we never have to recover any data and that nothing's ever get lost, right? We want that protection in the beginning. So always look at the prevention. We have a lot of white papers on our website of how to set up different features, things like queryable encryption. Hey, I can encrypt all the data, but I can still use it. Yes. So there's a lot of protection there. And then, also make sure that you have recovery. You never know what's going to happen. People make mistakes, honest, mistakes on our developer side. So we want to be able to recover any of those scenarios, whether it's ransomware or just an accidental mistake by a human.
Excellent. Well, listen, I know it's been a short 10 minutes, Evan, but this has been a really good overview as to the reason of backups and also the benefits of Ops Manager. So thank you for highlighting that for us and the review. Where do they go to find out a bit more? Is it on our docs site, etc.?
Yeah, absolutely. We have it on our docs site for the actual backup itself. It'll walk you through all the features there. We also do have a white paper that talks about data resilience. So if you search MongoDB data resilience, that'll lead you to a page where we have a white paper that's about 12 pages long. You can go through all the details.
Excellent. Evan, thank you so much for joining us. It's been great. We'll be back in a few short moments. We are leaving LinkedIn, unfortunately, so we're remaining on YouTube. So if you've been watching on LinkedIn, please jump across to MongoDB's YouTube channel. You can catch up with the rest of today's conversations until the end of the day at .local London right there. Thank you very much for everyone on LinkedIn.
Thank you so much.
Hello and welcome to this afternoon's talk on application modernization with Relational Migrator. To talk to you a little about how to migrate your application workloads across from traditional relational database designs into the NoSQL universe, we've built and invested in a very unique tool designed to bring your relational workloads to MongoDB with confidence. This Relational Migrator tool does three things. It helps you design an effective MongoDB schema that is a modern and very tech-savvy and agile design. We help you migrate the data both in a test environment and then to do a production-grade migration of all of your source data with the transformations if you want to embed content. And finally, to generate code artifacts and the specialist task of converting SQL, custom SQL contained within your stored procedures across to MQL, these aggregation pipelines. We're able to apply a range of sources and basically to pull in data from Postgres, an old Sybase instance, your Oracle production data, and bring them to Atlas, to your on-prem environments, either as a one-time snapshot where it takes the existing setup and then ceases, or a new capability that we'll be talking about today, which is the continuous sync, a long-running sync that continually syncs the changes from a source database across into your new MongoDB format with all the transformations. And this is available out of the box today, a new capability that we've been building out. With this, we're going to start a database sync. And these database syncs are going to bring all the previous data that's in there, the current data set, but then we're going to transition to a live database monitoring, continuous monitoring, and this can be running for as long as you need. And it's great for when you have a migration with one of those complex tables I showed you before. And so here, this is going to be a live data migration. And on top of that, we're going to make some edits to see that actually work in real time. So what we're looking at here is the running migration job, which is just transferred. There you go. Thank you. Transferred about 3,000 rows. We're actually able to handle a much larger set of data if we want, but it's now switched to monitoring, and it's going to monitor the database for changes. The Relational Migrator tool allows you to generate new access code based on your MongoDB schema to convert the previously mentioned stored procedures, triggers, and views. And something that you just saw demoed or mentioned in the previous keynote was the ability to translate that data access code, the entity framework, across to work with MongoDB. And this is a fantastic set of capabilities because it's completely free and you can try it. Let's go use this live GenAI query converter and you'll be able to see how this works in a prod environment. So I'm connecting, in this case, to the source database. My Postgres sampled Northwind environment has a range of stored procedures and views. And I'd like to show you how this tool can automatically translate them from SQL to MQL in near real time. So what I've got, if you look on the left here, is a set of stored procedures and views, and we're actually going to just start translating them. So here, I've got a couple of different languages that I can pick as a source. And so I've got a few supported languages. This one I might send over to C. This one I might send over to C#, or to Java, I should say. And we're going to convert a bunch of these queries in real time. You can already see some of the results are coming in, and we can see that it's produced automatically based on the actual mappings provided of the before and after, a suggested.
And you're very welcome back, now only to our YouTube viewers, but you're welcome. Hopefully those watching us on LinkedIn earlier jumped across to our YouTube channel. There was a lot of announcements at the keynote earlier this morning, but one of them was app modernization and relational migrator. And I'm joined now by Sanjay, who's a services delivery enablement engineer. Sanjay, you're very welcome to the MongoDB.local live stream. How are you?
Thank you, I'm good. I'm so excited to see so many people. It's been just packed auditoriums all throughout, and some really interesting topics being covered as well.
Yeah, it's great to see it so busy. We talked a little bit earlier with the previous guest about, meeting in person, having the sort of conversations that you wouldn't normally have when we're scheduled Zooms and all of that sort of stuff. So it's brilliant. You have a talk later on, Sanjay. What time is that at?
It's at 3 o'clock.
Okay.
Yeah. It's in Kensington upstairs.
Perfect. So when Sahir was on stage at the keynote, Relational Migrator took up a good chunk of that keynote time. I know a little bit about it, but you're the expert. So from a developer perspective, and for those considering, modernizing their app or, using MongoDB for the first time for an existing application, talk to me a little bit about the features of Relational Migrator.
So actually this is something that Sahir brought up on the keynote as well, that a lot of our customers are actually stuck in status quo because the challenge of moving on to MongoDB seems too daunting. There are a lot of aspects to it. Getting the schema design correct, because you don't just lift and shift. You don't just move the tables as collections. There's a fair bit of amalgamation that goes on because you want to store data where you're consuming it. And that's the power of document model. And if you don't know MongoDB, that in itself is the first challenge that a lot of people struggle with.
It's a barrier, right?
It's a strong barrier. Yeah. And we've been trying to educate people for a while. I've actually been a consultant engineer for 6 years now, and I've spoken to so many customers who are wanting to, who've been working with MongoDB and still don't fully understand it. So for somebody who's coming from the relational world, it's actually a whole different scenario. They're used to dealing with data in a certain way, and then they come to MongoDB, they want to come to MongoDB, and they just see that it's completely different. Because if they just do lift and shift, it's not going to perform. It's not intended to be used like that. No, it's structured wrong.
There's a whole lot wrong with the lift and shift mentality. You know what I mean? In doing that.
Yeah.
And it doesn't make any sense. So a relational migrator guides them through the process of this and suggests where there could be performance improvements and enhancements made to their data structure, right?
So it's actually a very visual tool. What it allows you to do is, right off the bat, using the relations that it can see on the existing schema. So you can connect it to your current database, relation database. It's going to analyze the schema, and it's going to figure out the relationships. And based on that, using some Gen AI-powered magic, it's going to convert...
We love that term, yeah.
Yeah, so it's going to convert it into what it thinks is a good schema for MongoDB. It might not be the case, it might be really close to it, but it might also be a little bit far. It's still AI at the end of the day. So what you want to do is you want to understand it, want to iterate over it, maybe make some tweaks, because you understand your data better. And once you're ready with it, you can actually use the relational migrator to migrate all of your existing data into MongoDB.
Okay, so you've migrated the data into MongoDB. What about the query?
Good that you asked that. That's actually one of the recent features that we've been working on, and it's very new, but we're actually very close to giving you a complete, well, I say complete, but a lot of modifications, a lot of the artifacts, aside from the data, the structured, the stored procedures, your custom SQL queries, the triggers, all of that also needs to be brought in, like you rightly pointed out. So the tool now today does have, again, Gen AI-powered ability to convert existing artifacts and give you code snippets that you can directly copy and paste into your code base. So that's already available today, and you can play around with it. And again, the idea is that you do this iteratively, get more and more confident, and that you've de-risked your migration plan, and then go for it. You release your POC and maybe move into MongoDB.
Excellent. So obviously, you can do your POC, as you say, and people can say, well, look, I'll take a little bit of my data across, I'll test it out, etc. But we have a real-world example with Bendigo Bank that was used in the Keynote at scale. Talk to me a little bit more about their use case.
So it's not just Bendigo, that was definitely brought up at the Keynote. There's also Nationwide here in the UK itself. These are our customers who wanted to move their relational applications into MongoDB, and it was still, for Bendigo, actually it was really hot off the press, relational migrator. It was really initial stages, but they were really happy with the product. They worked with us iteratively, and they were able to, they're actually still on the roadmap to it, but they made significant progress with their move into MongoDB. And same for Nationwide. They have a bunch of applications. One of them they've started with, and so far it's going well, and hopefully we can have a lot more of their applications also coming over into MongoDB using relational migrator.
Excellent. And obviously, traditionally, this would have been really a long-term, large project for companies to engage. And as you said, there were barriers going, it's too big, we don't want to do that.
Yeah.
How has Gen AI helped in this process in terms of speed and time? Do we have any statistics around some of that?
Well, not statistics. I do have some anecdotes that I can share with you. So I worked with a customer, this was a big telecom giant in the Middle East, who wanted to, they were really excited about MongoDB. They were super keen on getting their main ERP system into MongoDB. And I was involved with them as a field consultant, and I had spent over a year having various discussions, finalizing their plan. When I walked away from them, I had left them with an 18-month roadmap to get them onto MongoDB. So it was more than 2 years net invested into it. And today, using Gen AI-powered enhancements of the tool, we can actually bring that really down. And in fact, in my talk, I'll be giving actual demos where live, within a few minutes, you can convert your existing schema into MongoDB schema, existing queries and stored procedures and all of that into Mongo query language artifacts. So it's really fast. I don't really have a baseline to compare against, but it used to be a many month-long project, which can now be much faster. And the biggest USP of using Gen AI is that the customers don't really need to scavenge as much as they needed to earlier for technical capabilities in-house. For MongoDB, they would need somebody who's super skilled.
I like that word, scavenge. So they were looking for people who would help, and maybe with some of the legacy projects, looking for people who understood how that was built.
Because you need to understand all the information that's being consumed, and then you need to understand how better to structure it for MongoDB's consumption. So you need both the technical prowess. And yeah, it was not an easy task, and that's something that GenAI actually makes it much simpler, because all of that is built into it. And today we are already supporting about 6 source data relational databases, and 3 languages that you can create your code artifacts into.
Okay. So, and what's I suppose the end goal here, using GenAI and using our experience, is to remove any of those last remaining barriers for people wanting to move from a relational database across to MongoDB.
Right. The end goal here is literally that if you're just stuck because you're just too scared, there's just too much risk, there's too much investment needed, and you're not sure whether that investment will bear its fruit or not, then this is a tool which allows you to iteratively just get your feet wet, just figure out whether it's the right approach, whether you're and fine-tune that plan and get there a lot faster. And yeah, the end goal is literally just to make sure that the customers have the confidence to be able to move from their archaic legacy RDBMS systems into the modern world of MongoDB.
Okay, and so less resistance, more potential customers for MongoDB, quicker projects, less mundane work for developers as well too, right? It's taking care of a lot of the more mundane tasks under the hood.
Right, so I mean, if you are somebody who knows Mongo really well and you're just involved in this kind of a project, I would imagine it would be a really boring task to just go through all the queries and convert them into Mongo query language. And probably not the best.
Not proper use of your time.
Exactly, of an expert's time.
Yes, totally.
So yeah, there's better things you can do. And yeah, this just makes it, all of that mundane task will just be handled by the tool itself.
Okay, so for anybody joining us and interested, where do they go to get Relational Migrator? How do they activate it? It's free to use, right?
It's a free tool. It's already available. Version 1.9 already has 6 supported databases, 2 of them in public. Preview, you can go to MongoDB's website. I think it's mongodb.com/relational migrator. And yeah, you can just go ahead and download it on your local machine, on your dev environment, and just get started with iteratively getting the confidence that this is actually going to enable the migration and get you onto MongoDB.
Excellent. I don't see why they wouldn't want to do that if it's going to help them out and be quicker. Sanjay, it's been a pleasure to have you on talking about Relational Migrator. Thank you so much.
Pleasure's all been mine.
Take care. Enjoy the rest of the show, and we'll be back shortly in a few minutes with another guest.
Welcome back to the show. My name is Michael Lin, and this is the MongoDB podcast. I'm super excited to welcome our guest today, Kenny Gorman, head of streaming products at MongoDB. And without further ado, let's bring Kenny right on to the show. Kenny, welcome back to the podcast. It's great to have you on the show. How are you today?
Thanks, Mike. Yeah, I'm great. Doing great. Excited to chat.
Yeah, terrific. So last time we spoke, we were taking Atlas Stream Processing to private preview. I want to get to where we are today and what kind of changes and what kind of experience that's been for the product team. But before we do that, for folks that are not familiar, maybe explain what Atlas Stream Processing is.
Sure. Yeah, this journey, I'll just tell you in story format. This journey started a couple of years ago, and I came on at MongoDB, and we wanted to build out stream processing capability. And the use cases that were starting to appear and the problem points and pain points that were starting to appear had to do with data in motion or streaming data. And so that's data for use cases where timeliness of the data matters, things like IoT sensors where we're trying to measure and react to certain things, certain conditions very quickly, where the value of the data is diminished the longer that it goes on, the older the data gets. Things like manufacturing, real-time manufacturing, things like marketing, even actually marketing systems where they're trying to give you deals or incentives within applications. Just a whole host of use cases, modern use cases that need this kind of fresh and timely data. And customers were struggling with the document model and wanting to use the document model within streams, but not really having a good interface. And a couple of years ago, we started to have this idea that, hey, MongoDB, first of all, is a great platform for doing this. We're the MongoDB database. We're obviously the document model as our core. And the aggregation framework within MongoDB, if you're familiar, is a pipeline operation. And so it gives you different stages within an operation. And those stages are they're analogous, they work very nicely with stream processing. So you can put different stages in there and you can build your computations and do stream processing in a very Mongo-esque way. We already had the primitives to work with the document model, and we already had a huge user base that was using this. So it seemed like a natural fit from the get-go, and that's where we picked up.
Yeah. So Atlas Stream Processing surfaces to the developer through the same idiomatic tools that they're used to today, right? Through the aggregation framework, through additional operators.
Yeah, you nailed it. Exactly. So what we did was we said, let's try and leverage what developers have been doing for many, many years. And let's let them continue to have the tooling that they've always used for many, many years. Okay, cool. So we did that, and it's sort of interesting as we went through this, and I'll talk about this as we get further into the conversation, but as we went through the private preview, we actually had customers just take their existing aggregation statements and say, hey, can you help us make this into a streaming aggregation statement or a streaming pipeline? And to be honest, all we had to do was change the source from like a database source, a collection source, to a streaming source, something like Kafka. And then we just changed somewhere to put the data, like a merge operator at the end, into the collection. And boom, we have a continuously running pipeline that can process data from source to sink, and it runs the same business logic or same computation that they had before. So the mental model, the leap customers had to take from one to the other was very low, and that seemed to really help adoption.
Yeah. So for folks that aren't using stream processing today, what are some of the reasons that they might want to look at Stream?
Yeah, it was interesting when we first started thinking about this. We obviously, I told you a minute ago, all the different use cases that are involved here, but customers actually have those problems, but they also have another class of problems, which was just kind of like data manipulation problems. How do I build this report and have it constantly updated? Or how do I take data from my main system and move it to my secondary system for offline use or something like this? And how do I keep it up to date, constantly up to date? And so Atlas Stream Processing fit in really nicely there. You can just jump into Atlas. You can go ahead and create a processor. You just define your Atlas source and you say, oh, this collection here, it'll read the change stream. You can aggregate the data and maybe do some filtering or whatever that might be, some math or something, and then push it to another collection within Atlas. And it's super seamless. It just takes a few seconds. And that continuously runs in the background, and now you have these up-to-date collections across your enterprise. So those little handy wins were where people started to get started and started to get familiar with it, and then they said, okay, I see what I can do with this. This is powerful. Let me use it for some other things.
Welcome back to the show floor here at .local London. It's getting busier again. Lunch is over. People are coming back on the show floor. So it's interesting to see all the activity all around us. As you can see, it's been busy most of the day as people nip in and out of sessions and come down to talk to our partners and indeed our MongoDB folk here on the show floor. In the keynote earlier with Sahir, we obviously discussed a lot of things, but one of the things that stood out was streaming. So I am joined by Joe Nimick, who is the Senior Product Manager for streaming here at MongoDB. Joe, welcome to the live stream.
Yeah, thanks for having me. It's great to be here.
Good, good. So it was mentioned, as I said in the keynote, it's something that's relatively new for MongoDB. For our audience who aren't familiar with our stream processing, tell us a little bit about what it is and how it helps developers and what are the use cases, Joe?
Sure. So I think the most simple way to think of stream processing is that you're able to take an aggregation framework query that you're used to writing. So if you've been writing aggregation queries in the Mongo database and running them, now what you can do is you can take that same query and you can run it continuously forever in perpetuity. So instead of running it at an interval, like maybe if you're like me and you're back in the day, you used to use cron. Maybe people nowadays don't use cron.
Still do.
But you would run that query in the database every so many minutes or hours or night, every night, something like that. Now what happens is because it's continuously running, as new data shows up at the database, or from a system like Apache Kafka where there's an event stream, it's just continuously processing it and outputting the results as they happen.
Okay. And what do we do for longevity there? We're only interested in the new stuff that has been aggregated in the stream processing? What do we do with the historical data? What happens there?
Yeah, so at that point, it's kind of up to you with whatever your business logic is. You might want to materialize that data into an Atlas collection so that you have a constantly materialized view that you can always query and is always up to date, right? I always think of the use case of like that executive that wants his dashboards to always be up to date. He doesn't want it.
We know a few of those.
Yeah, you know. We all have to work with them. And so this gives you the ability for those updates to be constantly applied rather than being applied at an interval. Or you could have sent it to a system that's Kafka compatible, and then you can syndicate that to potentially many other downstream applications that are able to read from Kafka that you might be running.
Okay, so that's the underlying methodology and technology behind it. What's the use case of streaming data? You know, previously we would have had guests on and we talk about maybe for fraud detection, these sort of things as well. Outline a couple of real-world use cases for me there, Joe, to put it in the context for developers who mightn't be familiar.
Sure. I mean, everyone has a fraud detection use case. Maybe we'll skip that one.
Yeah,
right?
exactly.
But,
yeah, give me a new one.
Yeah, so for example, we have some oil well pump manufacturers down in Texas, right?
Right.
And what those
There's
folks,
a lot of them there.
There's a lot of them there. And what they're effectively doing is they're monitoring those pumps continuously in real time so that they can detect when there's something starting to go wrong on that equipment, right?
Okay.
And then they're able to not only report continuously what's happening so they understand their yields that they're getting, but when those yields start to drop off, they know that they can dispatch a maintenance crew to go and do that in a very quick and effective manner.
Okay, okay. So that's one and a very kind of mechanical example. Any others there?
Oh, there's tons of different examples. The energy industry, right? We're all doing this smart grid stuff now.
Yeah.
So they have many different IoT sensors out there that monitor the health of the grid, basically.
Right.
And that stream of data from all of those devices can overwhelm a lot of systems, right? You might not need all of the individual raw data points. And stream processing lets us read that event stream in because it's all in-memory processing.
Sure,
so it's real fast
okay.
and snappy. And what you can do then is you can pre-aggregate that. So you might turn 100,000 events into maybe 100 events that then match kind of the query that you want to run in batch. So you persist that then to your collection, and you reduce the load on the database to run those queries. Those queries now are faster because there's less documents for them to have to scan and go over.
Okay, so in that instance, in the IoT space, this is helping pick out that anomaly in the myriad of data that gets streamed from these connected devices.
Yeah, absolutely. You can do the needle in the haystack type workload if that's what you're interested in. You could just pre-aggregate it into a materialized view that you know is kind of what you're after. Some of the more simple things that we see customers start with is typically they've been like Kafka Connect users.
Right.
So Kafka Connect lets you read from Kafka and write it into a Mongo collection, or you can read the change stream from Mongo, write it into your Kafka topics, right? It's just really a simple integration type capability. But it doesn't allow you to do aggregations, right? It doesn't have a lot of transformation capability to it. So Atlas Stream Processing, you can get started very easily doing a Kafka connector-like use case by just reading from Kafka, writing it to Mongo, or the other way around. But then as you grow, now you have all of those aggregation framework capabilities at your fingertips, and so you can start transforming the data, you can start windowing it and doing aggregations over periods of time, and really building in more business logic to that transfer.
And how do people get started with this now? Where do we go? Where do we learn? The docs, obviously, et cetera, et cetera.
The docs are probably, the simplest place. Obviously, there's also
Developer Center.
Developer Center, yes. The Developer Center does have quite a number of tutorials available that you can go look at there. Or you can just hop into Atlas, and right on the left you'll find under Data Services Stream Processing. You can go ahead and get started. You can create an instance very easily. You don't get charged for creating an instance. You only get charged when you're running processors. So if you want to play with it just a little bit and then stop your processor, you're not going to continuously be charged.
And do you need to be familiar with aggregation pipelines before doing this, or does it matter? You go in, if you've never done an aggregation pipeline on MongoDB before, can you just start with stream processing?
There is a tutorial in the documentation for a quick start, so if you're unfamiliar with ag, right, and kind of some of the other nuances that come with stream processing, you can just follow the Getting Started tutorial. It's linked right there. If you go into the Atlas UI, it's one of the 3 options that'll take you directly out to the tutorial, and you can read about how to get started.
Perfect. Well, that makes it super simple. So, in terms of stream processing, what was new that was announced today, or what's new out now or recently? So new regions, etc. as well too.
Absolutely. Yeah. When we GA'd back in May, we only had 1 region.
Oh, fair enough.
Right?
So that's good, right? We've more regions. Tell us where are those, or
absolutely. Well, we added 10 more regions, so we're at 11 now in AWS, and they're across all the major zones.
Okay.
So you can spin up in APAC if you're interested. In Europe, you know, if you have GDPR concerns, you're able to easily run stream processing there now, and then in the Americas as well.
Okay, and I saw VPC support as well too. Tell us a little bit why that's important for developers.
Yeah, so in many production use cases, folks don't want to connect to their Kafka clusters over public IPs.
Yeah.
And I don't blame them. I totally get it, right? That's the way of the world. So what VPC peering lets us do is now you can peer your Atlas Stream Processing instance to wherever you're running your Kafka cluster. And that allows us to have private networking capabilities and keeps you off of the public internet.
Okay,
and
which is important for many industries, right? Yeah, you don't want to be on the public internet for a lot of that.
Yep, and somebody out there will ask, well, what about Private Link? Private Link is coming soon. It's next on the list of support for private networking capabilities.
Yeah, you heard it here first. Expanded Terraform support?
Yep. So now you can use Terraform operators for every part of a stream processing workload. So you can create instances, which are just like when you deploy a MongoDB cluster, you have SP10, SP30, SP50 type instances. You can create the connections, which let you connect to Atlas clusters or to Kafka clusters. And now the big change is we've added support in Terraform for stream processors themselves. So now you can deploy and manage your stream processors with Terraform, giving you the ability to do everything in your production environment via Terraform.
Excellent. You mentioned Kafka earlier. We got some expanded Kafka capabilities as well too with the new announcements.
Yep. So we've added support in Kafka for things called Kafka keys and Kafka headers.
Okay.
And so now, Kafka kind of has 3 pieces to it. It has headers, keys, and values. A lot of people use values as the predominant way to transfer data, but there are other use cases where keys and headers are really important for customers and their use cases, and so we've exposed those in stream processing for you to use.
Excellent. Well, it sounds as if the stream processing team have been pretty busy, Joe, so it's great to hear about all these advances. I always learn a lot when I do these interviews, so I've learned a couple of new things. Joe, thank you very much for explaining all the new stuff in Atlas Stream Processing. It's been a pleasure to have you.
Oh, thank you for having me here.
Take care. We'll be back shortly again with some more guests, this time back in the Gen AI space talking about vector search.
Henry is the product manager for Atlas Vector Search. Welcome, Henry. Thank you for joining us.
Happy to be here, Jesse.
Awesome. So to get us started, let's maybe you could share a little bit about your background with our audience. What got you into machine learning and AI stuff?
Sure. So I first kind of encountered machine learning and AI when I was in grad school at Stanford in 2019. So this was sort of the onset of a lot of these things that are now large language models. The Transformer paper had recently come out, and there were a lot of these, like the BERT model was starting to become very widely accessible. I was in an NLP with deep learning class, and I, fine-tuned BERT on a small Reddit data set, kind of saw the potential for it. But I was in grad school for robotics, actually. So I worked at a robotics and machine learning startup called Osaro for a few years after that. And eventually made my way into sort of like the data engineering world, which brought me to Mongo as a software engineer, and then recently expressed interest in us putting forward a vector search product and got involved with that. So that's sort of wind-about way into this search world now.
Nice. Okay, so robotics. My first thought is, are you going to build a robot with AI? How are we going to do that at MongoDB?
Yeah, it's. I think that our CTO, our former CTO Elliot, is like working on that kind of stuff now. He's working on a robotic platform. So who knows? Databases, robotics, machine learning. These are fundamental building blocks. I think there's probably some commonality between all these things that drive people that are interested in like systems and to be very compelled to work on them.
Nice.
It's very hand wavy, but I like to think that there's a common thread between these things.
I think so. I think they all go hand in hand for sure. That's pretty cool stuff. So before we get into why we're here, I like to do this little icebreaker thing. It's just a fun little game that I want the audience to participate as well. So it's gonna be really quick. I'm gonna say ask a question, and the first thing that pops in your mind, say it. Audience, get ready on the keyboard. All right. Android or iPhone?
iPhone.
Okay. Windows, Mac, or Linux?
Depends on what I'm doing, but probably Mac. Yeah.
Mac. Okay. All right. I go back and forth between Mac and Windows. Not much of a Linux person though. Sorry. All right. Your favorite code editor or IDE, and this could make or break our friendship here.
If I'm working on a big project, PyCharm is pretty nice. If I'm like hacking together little scripts, I really like Sublime. But pretty much anything with like basic syntax highlighting and code search is good for me.
Okay, I'm the OG Sublime text editor guy too. Right now I love VS Code obviously, but that's great. So when you're actually coding, tabs or spaces?
Tabs.
Okay. Generally, I'll just go with whatever Prettier, throws out there. But yeah, pretty much tabs is so much easier. Okay, last one. Coffee or tea?
I wish I could be a tea person. I feel like they've got like this like Nirvana vision of the world, but I'm a coffee person.
Yeah.
1 a day now. Used to be 2 a day. So at least I'm growing in that respect.
Okay. Yeah, I have to have my 1 in the morning, and then sometimes I'll skip the
And you're very welcome back. It's still me as the host. We do have other hosts coming up as well too, so you will see a change of scene, change of host. But for now, we're doubling down in our Gen AI space, and I'm particularly looking towards last year, MongoDB launched MongoDB Vector Search. We've done a lot with that over the last year, and one of the key people involved in everything that we've done in this space is Ben Flass, Director of Product Management. Ben, welcome to the show.
Thanks, Shane. Good to be here.
Good. How have things been so far?
Excellent. We had our talk earlier today where we announced quantization, and we had Nomic, one of our portfolio companies for MongoDB Ventures, join and talk about their quantization-aware embeddings, which was super exciting. I then went through kind of the new capabilities that are available inside of Atlas in both kind of the ingestion of the reduced representation of vectors as well as the automatic quantization capability. So 2 really exciting capabilities to help you drive down the cost of vector search, and super exciting.
Excellent. So obviously, vector search at .local last year in New York, we launched it. People are getting to grips with vector search. People are getting to grips with Gen AI overall.
Yeah.
Quantization, what does that mean for vectors? What does that mean for developers? What does that mean to our customers?
Yeah, absolutely. So when we launched this last year, we were focused on making the capability available, right? And making it available within existing paradigms of MongoDB. You insert your BSON array, which is your vector, you create an index on top of it, you have your $vector search query, and you go. And we've seen great success with that. We've, found ourselves in the various AI application frameworks that are being built and using vector search as a key component of retrieval augmented generation. We're seeing ourselves pop up in agentic workflows. A lot of excitement there. That said, with our initial implementation, using kind of the standard MongoDB primitives, et cetera, there are certain places where that wasn't optimized for the vector workload. And so what quantization is focused around is these larger workloads that we're now seeing coming on to vector search, making sure they can do so in a cost-effective manner.
Right,
At the early days, people were experimenting with smaller workloads. They're starting to grow, and quantization is really focused on making them much more cost-effective.
Okay, and what's the mechanism underneath this, or why this solution for reducing those costs?
Absolutely. So quantization is a technique to reduce the representation. So today, if each of your dimensions inside of a vector is a float 32, tomorrow you can make those a int 8 or a bit. So that allows us to just take up less memory and less storage when it comes to storing and querying those vectors. And that's why this is a really powerful capability. And the impact is really quite dramatic. So with going from float 32 to int 8, you can see a 4x reduction in the size of your index.
Okay.
And going from a float 32 to a byte vector, you can see a 96% reduction in the size of your index. So massive cost savings for the index, which is important because the index needs to all be in RAM, and that's really the expensive part. And so by reducing the size of the index, we're dramatically reducing the cost of serving the workload.
Is there any trade-off in reducing the size of the index in terms of precision?
Yeah, so in short, when you use this technique by reducing precision of the vectors, you are trading off what we call accuracy.
Right.
And all of this is done inside of HNSW, the algorithm we use for our vector search, approximate nearest neighbor. But what's great is, or the reason that memory is kind of the cost driver is because HNSW all needs to be in memory. But HNSW has a lot of really good properties around tuning recall and kind of making it perform exactly how you need to.
Okay.
And so we've stuck with HNSW, but just reduced the memory consumption.
Right.
And to your specific question around what's the impact to recall, when you reduce precision to int 8, we actually see a somewhat minor impact to recall, and so we don't have to do anything additional.
Right.
But if you want to take advantage of binary quantization and get that 96% reduction, then we see that re-ranking is really crucial, which is the concept of re-ranking is basically taking the results of the initial query off the index and then re-ranking those results just based on the full fidelity vectors that you initially inserted.
Okay.
And so that's the approach to kind of preserve recall and make your answers still accurate.
So they're still full fidelity. Understood.
Exactly.
So obviously there's a cost reduction both in storage but also in the query time, etc. too?
Yeah, so where the
processing?
Yeah, so the cost reduction is in two places. So one is in the amount of memory that you need because you have to have the entire index in memory and the index is much smaller. The other cost reduction is in the amount of storage you need because along with these we've introduced a new BSON type for storing vectors, which is more efficient, using bin data type 8. And so those are two reductions. In terms of performance, we actually do see the same or better performance than the original, even with that re-ranking, because fundamentally at the end of the day, we're moving around less data. And so we get efficiencies there. And so even though we have to re-rank those results using those full fidelity vectors, it still translates to the same, if not better performance for queries.
Okay. And is this limited to specific models that are, do better with quantization?
Yeah, so there are quantization-aware models that do better with quantization. Our partners who we had at the talk were Nomic, and they have some quantization-aware models. Companies like Cohere also produce quantization-aware models, and so those are great. We've seen good generalized performance, though, with quantization, in particular because of our re-ranking approach, right? Which is, at the end of the day, you're re-ranking those results anyway. So from our perspective, you can use any model with us for the automated quantization with re-ranking. On the other hand, if you're just planning on storing quantized vectors, you probably are better off using a quantization-aware model.
Okay, so Cohere and Nomic now, others will be added in time as well too. have we rolled this out fully? How does a developer start using quantization?
Yeah, absolutely. So today, we made the announcement for all of our capabilities that are coming here. The thing that's available today, though, is the storing of quantized vectors for float 32 and int 8, along with the efficient representation in the database.
Okay.
Along with that comes support in the Python driver for writing these efficient representations into the database. The other drivers will come in the coming weeks. Sure. In addition, for storing efficient representations of vectors in the database and in the index, with int1, that support will come in coming weeks as well. So that covers kind of the first set of features and the driver support there as well. The second set is the automatic quantization, which is just a parameter that you'll set inside of your index definition, and that will be coming in coming weeks as well. Probably and so we announced and made available int 8 and F32 support today, along with Python support. And then, for the rest of that will be kind of the efficient representation for int1 and other driver support, and then automatic quantization will be a fast follow to that.
Okay, excellent. So developers can start using Elements today, and we're going to, that sounds like we're swiftly following up with everything they might need to leverage this as much as possible.
Yeah, this will come in quick succession.
Okay. And given that vector search is a year and a bit old for MongoDB, you've been involved in all of that. You've seen all of the Gen AI integrations that we do.
Yes.
I didn't ask this of any guests earlier. What's your view on AI in the future and everything like that? And you've got about a minute or less to answer this one, Ben. We could be forever, but yeah.
Yeah, I mean,
how are you seeing it help developers?
Yeah, I mean, with helping developers, I think kind of the Copilot experiences, things along those lines are, obviously having a tremendous effect on developers' tooling and productivity. I would say the thing that I personally am very excited about is more agentic flows. AI starting to do things for you so you don't have to think about it. Really kind of an asynchronous experience.
Sure.
And we're focused on, doing everything we need inside of MongoDB to make sure that you can have your LLM memory with MongoDB. And whether that's your vector search queries, your lexical filtering, or your regular database transactional queries, we want to make sure MongoDB is available to store all the data and retrieve all the data needed to build those kind of really transformative experiences that are, primarily right now in the future, but agentic in nature and, really differentiated.
Excellent. No, I very much look forward to that. And look, this has been superb. Obviously, quantization, it's a huge thing, and it's great to see it out there. It's great to see such a short roadmap for everything that you need. Ben, thank you for so clearly explaining what is otherwise a difficult word to say, let alone a difficult topic to get around. It's been a pleasure to have you.
Thank you. Pleasure here as well.
We'll be back very shortly again with another guest. Do stay tuned on our YouTube stream. We do appreciate your attendance. Thank you very much.
Honestly say, when I saw time series, I thought the multiverse, because that's about as close as I get in my universe. But I am here to introduce my colleague, Sahi Mudiala, who is going to take us through this. So Sati, over to you.
Thank you. Hi, everyone. I hope that you've been enjoying .local NYC. Michael and I are really excited to talk to you today about implementing time series in MongoDB and practical use cases across multiple industries. But before we kick it off today, just by a show of hands, how many of you use a health tracker of some sort? Okay, so a good number of you. And another quick question, how many of you view your health data over time? Okay, so quite a few of you there too. So that's an example of time series data right there. And I don't know about you, but I like being aware of whenever I'm having an anomaly in my sleep patterns. And similarly, I'm really new to investing in stocks. So I like being able to see a forecast or prediction of what a certain stock may be. Today, I'll be giving you an overview of time series, what makes it special, and I'll also be giving you an intro to time series collections before I hand it off to Michael, who will be telling you more about time series collections in depth before telling you about some of the new time series features with the 7.0 release. So without further ado, let's get started. First, what is time series data? Time series data is a sequence of data points collected over time in which insights are typically gained by analyzing changes. And so this means that we usually want to retrieve or work with all of the data points for a specific time period or for a time period from one or more specific sources. And time series workloads generally have a few key properties. So to start it off here, data normally arrives in time order. It's mostly immutable.
Hello, welcome to everyone. My name is Matt Acey. I run developer relations here at MongoDB, and I'm here with Asya Kamsky, normally only known as Asya.
That's right. There's only one of me.
There's only one of her. I was going to say, and it's more than enough, but
sometimes too much.
We'll get into it. In theory, we're going to be talking about time series improvement.
That's the theory.
8.0. Why don't
we'll work that in there somehow.
Well, I was going to say, because Asya and I were talking beforehand, if somebody were an alien or whatever were to drop in 2014, the first MongoDB world.
Yep,
I know we don't call it anymore. And then they went up and then came back down and came down in 2024. With regard to time series, what would be shocking to them?
I mean, I don't know about shocking, if shocking is the word I use, but 2014, we actually had a track where we presented reference architectures, so implementations that we did ourselves of common use cases. Like I was very closely involved in Socialite, which was for like social feed. Everybody was trying to add a social feed to their application. Everybody was making the same mistakes, so we kind of made a reference architecture to help them. One of them was, we called it high volume data fields. And it was literally like how to handle high volume data fields. It would be manually bucketing things by time ranges, and it made very similar assumptions to what we then basically eventually went, you know what, everybody's doing this, nobody even remembers where the reference architecture is stored, or maybe they don't know how to adapt it to their own thing. And so, 5.0, I guess it was 5.0, 3 years ago, yeah, that we introduced the time series collection type. Which is kind of interesting because, you know, a lot of people are like, MongoDB is schemaless. And like 2014, we're yelling, don't call it schemaless. And here we are, 2024, we're still saying, don't call it schemaless. But schema is defined differently than in a traditional, relational structured database. Time series is one where you actually are required to specify, this is my time field. And these are the things I want to bucket on. These are like sensor IDs or some other kind of IDs, and you get to specify what granularity you want the data in. And it's also that we can then figure out behind the scenes how to group the data in order to both minimize write amplification, maximize throughput, maximize efficient queries, etc.
So 2014, Asya, when we were doing this interview, you effectively could have been talking about time series data, using MongoDB for time series data.
Of course.
I don't know if we would have called it that at the time. But now in 2024, with 8.0, we made some improvements.
Yeah.
Talk about that for a second.
I mean, in 2014, you were relying on how well you understood what you can do to make things faster. Right, you have to understand how to group things to have your queries still be fast, relatively speaking. And it probably was, challenging. And it wasn't that we wanted to sell you professional services, but it was just, yeah, you can make MongoDB do anything, which means you have to know how to make it do anything. Here, since we introduced time series collections, it basically says this is what it's optimized for. It's optimized for, you have lots of data coming in. You have very few or no updates because that's just the nature of time series data is, you have stuff coming from a sensor, or you have market data coming in, or you have, and the queries we tend to know are going to be how are things changing over time, or for a particular time period, what were the metrics on, what I told you were metrics I care about, right? So it was always, behind the scenes. So it's handled sort of like a view. So, views in MongoDB generally is just, you create a pipeline on one collection, and the result of that pipeline is like a view. So it's similar to relational. Here, all of view manipulation is happening under the hood. So you just say, I'm creating a time series collection, and we're saying, okay, we're going to create a collection that has big documents that represent buckets that have certain range of your data, and we know that information, so that when you query, you just make a regular query, and then we figure out which buckets do we need to get. And there are two things about 8.0 that make the improvements, the performance, massively better. One is just better compression of buckets. So what's behind the scenes is like a super optimized columnar format of these metrics, and utilizing better compression means you might have up to 10 times as much data in the same, using up the same amount of cache or the same amount of RAM.
Sounds like a good thing.
Right? So that's going to make anything faster, right? When the Keynote and they say, 60% faster queries, they're talking about just any query, simply because more data fits in RAM. Ingest is going to be faster, right? Insertion rate is going to be faster because you have more things available in RAM. You don't have to go to disk for things. But the other really huge, order of magnitude kind of improvement is, we use our regular query system for time series data. And our regular query system is actually optimized for OLTP use cases. You and I were talking about earlier, like what use case is MongoDB good for? Any use case, right? Any use case you can represent your data however you want, and then you can query however you want, right? The typical, transactional workload where you're doing finds and updates and inserts, you're dealing with documents one at a time. The challenge for time series is when you're running analytics queries, or actually for any analytics queries, you're not actually wanting to look at documents one at a time. You want to look at a whole slew of data, everything in a particular bucket, everything in a particular range. And what we used to have to do under the hood is essentially materialize this one at a time, documents that our query, the pipeline could then work on. And in 8.0, we now have what we call a block processing, where essentially the query subsystem has the ability for certain parts of the pipeline for the type of things that everybody's doing, match, dollar group, right? Which is like the bread and butter of, for this range, I want to see this type of aggregation. It's able to now process it a block at a time. And that's where some of our benchmarks are showing 10 times faster, even larger improvement in some cases, because before it was just the wrong approach for the type of data that you have in a massive time series collection. And so for the highest cardinality workloads, the performance improvements from that are going to be the largest.
I want to double, or have you double down for a second on something that you said. We come out, we say, use MongoDB for time series data. We come out with vector search, we say, use MongoDB for vector embeddings. We keep coming out with these different things as a way to tell the market, you can use MongoDB for
anything.
For anything. Yeah. But that's always been the case.
It has. I spent almost 20 years working with relational databases before I first encountered MongoDB, and my first thought was like, oh, this is cool. It just kind of doesn't get in your way. You just persist your objects. I was working with Python at the time. It's like install PyMongo, from PyMongo, import whatever. And suddenly my dictionaries were the documents that got stored in the database. And queries were kind of the same, right, where this is equals, or the range queries, or not equals, whatever's. And indexing is the same. And I used to joke when I used to give admin training in the old days, the people who got it the fastest were always experienced relational DBAs, because they would immediately understand that their job hasn't changed at all. It's still make sure there's enough physical resources. Make sure that the dumb developer who tested things on 20 meg of data and never heard of indexes didn't just toss things over the fence into production without creating indexes. Because that happens in relational databases and that happens in MongoDB, right? Developers like to think about their world, and they don't really like to think about what goes on underneath the hood. And one of the things that hasn't changed, and maybe this is something that I think if an alien came back this year would be surprised at, is like how come everybody isn't obsessed with making the developer life easier? There's a lot of companies trying to write like no-code platforms, a lot of them using MongoDB behind the scenes because of the flexibility. But like, how are other databases not going, our APIs stink, right? Like, why are people still, like, okay, people understand SQL if they understand, they know the math of it, whatever, but it's still strings you have to work into your code. That's just so, not just not secure, it's unnatural, right? And you remember Dwight's old Leaf? The whole Leaf thing was it just feels natural. And, you know, developers understand APIs. They don't think about, you know, a lot of times people are like, oh, people just use MongoDB because they didn't learn SQL or they don't want to learn SQL. I'm like, it has nothing to do with SQL. It has to do with the APIs and the fact that it's just so much easier. And frankly, if a developer is not going to bother to learn anything about the database, I've always joked that I would rather they be working with MongoDB because they're less likely to do damage than not knowing anything about a relational database. And, you know, because there's one right way to do things in a relational database usually. There are a lot of right ways to do things.
I think that's interesting, if I could play it back for you. Some of the things, many of the things that you can do in MongoDB, you can absolutely do in a relational database.
Yeah.
But it might be a lot harder, or you lose some of the flexibility in terms of, like, you have to know your schema from the start, evolving it over time becomes harder.
And, you know, I've said this for over a decade now. You know, for 80% of the use cases, you could use either a relational database or MongoDB or maybe some other NoSQL database. It just depends which one do you know better, it's going to be easier, or which one do you want to learn, right? The way you learn a new technology is by picking it for a particular use case. And 80% of the time, it'll work just fine, right? But it will be more flexible, and people who try it realize very quickly how much easier it is to use because of the drivers for the language and the driver APIs being idiomatic, and it just being a lot easier to grok, you know?
So that same thing, and back when I joined MongoDB in 2012, developer convenience, productivity was the
thing, and it still is.
And it sounds like it still is.
It still is.
The database itself, ACID transactions, etc., all these other things have gotten better, but the core value of developer productivity has remained the constant.
Yeah, because I feel like if we lose track of that, you know, nobody's going to want to use this, right?
Asya, thank you so much.
My pleasure. My pleasure. It's fun. Bye, everyone.
So, as I say, this is going to be a very exciting learning release because we're going back to my love of C# and .NET, and we're going to be shining a light on one of the best things that we've released in a while, which is a new provider for Entity Framework. So, if you've talked to me or anything, or you know from seeing me at talks and stuff that I've given on .NET and MongoDB, it's brilliant, but it does. Lots of people say to me, oh, do you have Entity Framework support? Well, now we do. And I'm thrilled to say that on this month's Learning Release, I am joined by James and Damien, who are both, especially Damien, an integral part of creating this. So we're going to have a lot of fun going through it, trying to build something, and you can get all your questions in to talk about the driver, the roadmap. I do request that all questions are kept relevant to the topic. If you want, this isn't an Ask Me Anything. If you've got any technical queries that aren't related to the new provider or C#, then please use our community forums. So with that, I'll bring on our guests. Hello, and how are you both today?
Doing well. Thanks for having us.
That's good. So where is everyone watching from today then? I'm watching from the UK, where it may or may not get dark during the course of the stream. Who knows?
I am from Calgary, Alberta, just on the east side of the Rocky Mountains in Canada.
And I'm quite close to the UK. I'm in Guernsey, which is
somewhere between England and France.
Yes, yes, yeah. It's British but closer to France, isn't it? Or was that Jersey?
You can see France on a clear day, yes, but we prefer speaking English.
Yes. Well, I grew up in the part of England right down in the southeast where you could also see France on a clear day.
Cool.
So we've got some people popping in chat already. So we've got France, Mexico. CodeStacker is here. So CodeStacker, aka Jesse, is the reason why we fixed our technical problems. So thank you, Jesse. You are our savior of the stream. We've got more UK. We've got New York. Nice. We've got a good spread of people here today. Costa Rica, all very cozy. Nice. Awesome. So what we're going to do today is we are going to go through a sample app. So I actually recently created a tutorial which I can share. So if I go to screen share, I'm going to. Oh, we've got Colombia, Dubai. Nice.
India as well. Costa Rica.
So I'm going to share that screen. Hopefully. Oh, my other laptop's gone to sleep. So if we have a look here, we have a. Can everyone see that all right? It's I can't see what you can see. I just need to. I need to make it smaller so I can see, but I don't want to. Yeah, so I want to share the actual window, not the whole thing. It's right. I'll sort it in a second. Let me just. Yeah, you can see it. All right. Let's go back to making it bigger. So. There we go. Nope. Press it too many times. This is such a Friday afternoon feeling. So yeah, so we've got this. I've got this application. So I wrote a. Just make this a window. So if I go to here, I recently released a tutorial on. Make sure everyone can see all right. On this provider, so it talks you through how to get started. Now you don't need to go through that at the moment, but I can share a link. Hey everyone, so welcome back to the live stream here from the Expo Hall at .local London. I'm Luz Carter, developer advocate here at MongoDB, and on and off been one of your hosts today. So I am very, very happy to say that I am joined by one of our amazing community champions, and you may have heard from some of our community champions already today. We love everything that they do for us, so it's always great to have them on. So I am joined by Nilesh, one of our champions who's travelled quite a long way to be here today. So Nilesh, would you like to introduce yourself?
Sure, thanks for having me here. Myself Nilesh, I work with MoEngage as a technical architect and recently been MongoDB community champion, so it's really great to be here in London. Like enjoying the trip as well.
Is it your first time in London?
Yes.
How have you found it?
It's really nice. The weather is really nice. Like I like to wear a lot of clothes. So.
Yeah. Have you? When did you arrive?
Sunday.
Oh, nice. Have you been able to do any tourist things, or have you just?
Yeah. I'm going to Scotland.
Oh wow! I love Scotland.
Yeah.
So how do you use MongoDB at the moment? Obviously, normally our community champions, you tend to discover us through working with it. So
MongoDB I have been using since 2014, but in the recent organization, it's like we just like in terms of the DB, we have MongoDB left and right. So most of the use cases are on the MongoDB, and it's like one of the highest scale in India.
Oh, wow.
Yeah, so it's like we have a lot of clusters across data centers, probably 50-60 clusters. And though we are using community edition, but we get a lot of help from the Atlas and the Mongo teams and even the enterprise support as well.
Oh, wow. That's pretty impressive. Yeah, it's 50 or 60 clusters. I'm sure we have customers with more than that, but I think that's probably the largest I've ever spoken to directly, so that's awesome.
Yeah. So... yeah, I mean, like being experienced with almost 10 years with the MongoDB, and like this company gave me a chance to use that at very high scale, like billions of documents, scale at millions RPM, etc.
Oh wow, that's amazing. So, what would you say at the moment is your favorite feature of MongoDB, or something that you've used recently at work that's really helped from MongoDB?
Yeah, sure. So I think one of the recent POC I did it personally, and it was on the Atlas search. So that was really amazing because till now we're using Elasticsearch, and as I said, most of the data is in MongoDB itself. So the kind of pipeline which connects from MongoDB to syncing the data to Elasticsearch, that pipeline is a huge, big, and complex. It involves a lot of tech stacks, which probably I'll explain in detail. But that's like the complexity goes away when I use Atlas. It was like, okay, just configure the index and it's done.
Yeah. I love that as well, because I think we've seen that a lot, and that's why I get so excited about these new products we bring out, like search and vector search, because people have been using another tool to achieve it with MongoDB, and now we're bringing it out, and it's optimized for MongoDB. Like you say, just create an index, and suddenly your life is made so much easier.
Yeah, so that's what I think I'll just go through the tech stack itself involved in the current pipeline, right? It's not just Mongo. So after the Mongo, we have a Debisim connector, then there's a Kafka pipeline, then Kafka consumer groups, writing to Elasticsearch. Then, now if those whole pipeline has some issues, right, we have Spark jobs to remediate that issues. So a lot of tech stack involved, which goes away with just a config. So
that's amazing.
Yeah.
So, and as you mentioned Kafka, so do you do anything with stream processing or the Kafka connector, anything like that as well? Because we have so many, we call it a developer data suite, and it's so true because we have so many products that help with so many different problems.
Yes. So, as I said, right, even from oplog to writing to Elastic, that's a part of the stream itself, right? So likewise, we have a lot of streams on oplogs based, and I think we are also looking to go with chain stream. But that's in the plan, not yet expert, but we have our own, all the custom pipelines, which is similar to the stream use cases.
Wow. And so I think you touched on it a little bit before about some of the benchmarking you did to see some of the improvements you got from using MongoDB. Can you tell us about that?
So,
I love hearing about benchmarks and our beautiful, I don't know if you saw in the keynote, the beautiful graph about the performance improvements in 8.0. So I love benchmarks and performance. So tell me all about it.
Sure. So as I said, I did the POC myself. The POC was at, again, scale because at our company, most of the things are around the scale as we talk, right? The POC was simply to run 1 million RPM search. So, running 1 million RPM search over 300 to 400 million documents.
So, for those that don't know, what's RPM search? What do you mean by RPM?
Requests per minute.
Okay, yeah. People want just to make
sure
understand.
So it's like requests per minute. So if you convert to the seconds, 16,000 requests per second, something like that. Yeah.
Wow. Yeah.
So, and that's true for the search, right? Our earlier pipeline. So I think that was the amazing part. Being a code developer, I don't trust easily, the tech when they say that something's really, really good. Have to test it.
Yes.
So. When I tested, as I said, that scale, I think our P99 latency, P99 is the 99th percentile of the latency, it was around 80 to 90 ms. Our earlier pipeline had around 120 ms, milliseconds.
Wow. Yeah.
Right? And the delay between the sync, right? Because now Atlas Search is a package product with the MongoDB itself, right? So there's no pipeline, the sync is managed by the Atlas itself. And the sync delay was less than a second, while we had a sync delay of around a minute.
Wow, that must have, at the moment you first saw that, you must have been like, oh wow,
yeah,
where's
exactly.
this been all my life?
Yes. So it removes the pain of maintaining all of those tech stack as well, your SLA, everything is managed by the Atlas. Now the good part is the cost.
Yeah.
So the cost of my current system and this system was same. And that is pretty amazing because you are getting a managed service or the same cost which you are, when I say cost, my infra cost equals my managed service cost. That's really amazing.
Oh wow, that's incredible. See, I have loved hearing stories like that, and I think in my role I create a lot of content and I learn new products, and I'm very lucky about learning these new products, but I don't necessarily see it in like enterprise. Like I'm not doing it directly, so I always love hearing stories about these amazing things that people discover. Like, oh wow, I switched to it and it like went from all this long delay to under a minute. Like that's incredible. Have you ever thought about blogging about your findings? Like actually writing an article about your
I will be writing. As I said, I mean the POC was done almost 2 months back.
Yeah.
We are still into the production finalization.
Yeah. But it sounds amazing. So if you're ever interested in writing, obviously we have a guest author program and we love our champions. So if you ever want to write about your experiences, I'd love to work with you and write that and help you write it, because I just love getting stories out there like that.
I mean, I have like one more use case which I did recently, like recent, 2 weeks back. It was a coupon distribution, and that was also amazing. Like I think one of the things that I don't know, people would be knowing about the operator find one and update.
Yeah.
Right. So that operator works so well, like your use case of select and update in your SQL kind of thing, right? So coupon distribution was like you have all the coupons data, you just want to distribute it uniquely, atomically. Use that operator, done.
Yeah, there's so many stories like that, isn't there? You just try something and it's like, oh, well, that was easy. Like I've done some demos on some things in the Microsoft space around like with C# code, and I'm like, well, how am I supposed to demo this for half an hour? Because it's one line of code and then it's all done for you, and it's like, oh, I love this.
So as I said, like I mean, I think I'll come back to the point that pipeline and all the tech stack, right? I think I mentioned the tech stack. Debezium, Kafka, Kafka consumers, Elasticsearch, Spark job, Airflow to run the Spark jobs. Okay, so now all of this gone away. Now the other part which helps the company is you don't need to train your engineer, or you don't need to hire the engineer who knows a lot of things.
Yeah,
so
even better.
That's like one of the most amazing part of it, right? That you don't really need so much of technological stack, and everything is now, if we talk about even the index, right, that's a config. So now MongoDB itself has become a single, I would say, technology where you can manage a config also in the MongoDB itself.
Yeah, so it's great.
Yeah.
And so obviously we've only got a few more seconds, but is there anything, is there one sort of learning bite or bit of information that you've either learned today or you learned from that POC that you wish more people knew about?
I think, as I said, from the POC is very important part is when we talk about the search, we know OpenSearch, Elasticsearch, all of those things, but I think Atlas Search is not that famous probably.
Yes.
Right? So probably people should explore Atlas Search, as it's like very easy, scalable, and cost effective. So that's really amazing part of it, and of course like you get it like completely managed, so that's one of the things I would say people should know.
Amazing. Well, thank you so much for coming to speak to us, and hopefully we'll be able to hear more about your POC in the future and even more amazing things that you've discovered. Amazing, right, thank you.
Thank you so much.
Also, for the next awesome session from Daniel Kapal, Staff Developer Advocate, he's going to be walking you through the methodology and principles of data modeling for MongoDB. So if you're new to MongoDB, if you've already worked with MongoDB, these are not just tips and tricks, it's the principles of. So please enjoy, please give him a warm welcome and your attention, and thank you very much. And Q&A will be after, so have your questions queued up.
Hi everyone, I'm Daniel Kupal. I've been at MongoDB for 10.5 years. Over that period I had different jobs. I currently help our strategic account customers with their data models. This is the best job ever. My team and I work with many banks. A lot of our big customers are banks, as a matter of fact. So interestingly enough, they offer very similar services, as you may guess. Therefore, they have a lot of similar applications. These applications are subject to the same regulations, at least in the United States. One example is the Bank Secrecy Act. This is some of the text of the act. Obviously, I'm not going to have you read this, especially after lunch. In simpler words, what we have here, it means that financial institutions are required to assist the US government in detecting and preventing money laundering. Why am I saying that? It's because we're going to use this example for one of the applications that we see in many of the banks. So it basically translates to many banks building applications to track transactions. So let's imagine such application for this presentation. We're going to call this application a transaction logger, or TL for short. No, TL may mean tough luck if you're a bad guy. The system helps you catch you and prevents you from stealing money from the good guys. But if you're a good guy, it means tender love. Okay? So the system is here to help us. As a side, let's assume the bank is asked to track its customers. If an involved party is not a customer, the bank is still required to report them, but they don't have to include as much information. So if I were to model a simple version of this system with a traditional relational database, it may look like this. We have a customer that makes one-to-many transactions. Each transaction receives or sends the money to another party that we will call a payee or a payer. So the payee is involved in one-to-many transactions. So the interesting thing about this entity relationship diagram is that if I was going to ask you to do that, each of you would come up with the same solution. Because there's only one solution that respects the third normal form. Now, if I was going to ask you to do the same for MongoDB, you may want to model it like that. We could map the tree tables to tree collections. However, this is usually wrong. We see these schemas sometimes, and it's not optimal way to design a solution in MongoDB. You could still profit from some object to organize the columns and having a sub-object for the address, for example. That gives us a bit more flexibility and clarity. Another solution could be, let's embed the payee in the transaction. If we do this, we create a sub-object, we move all the information about the payee. This solution has one less collection. That may be good. But we can also have a different solution like this one, where we take the customer and we embed all the transactions for that given customer. By the way, this is not the right model. If you want to see a better solution, don't leave yet.
Okay, hello to everybody at home. My name's Mark Smith. I'm just taking over for this slot, and I'll be back along later for an interview. And I'm here with Daniel Kupal, which is fantastic. I was so pleased when your name came out of the hat for my interview.
Oh, I'm happy to do that. It's so cool.
So before we get talking, why don't you say something about yourself? What's your role, and what kind of stuff do you do day to day at MongoDB?
I've been at MongoDB for a while, over 10 years. My current role right now is to take care of the strategic customers, like the 50 biggest accounts. We go see them, and we do events a little bit like this one, where we do a bunch of presentations, and then we have a second day where we do one-on-one design reviews with them on their data models. And it's pretty cool. We love doing those. I'm sure we can elaborate a little bit more on that topic. Do you have you want me to elaborate now on that, or?
So, well, I guess that was going to be my next question. So we're here to talk about the design reviews and the sort of data modeling side of things. So what exactly do you mean by design review, if somebody hasn't been through that?
Yeah, it's a bit misleading because you have a design, but really what we're trying to do is help you on your data model in your design. And when you work with MongoDB, it's a little bit different than what you may have done with a relational database if you have a lot of experience in these other technologies. So you have to start thinking a little bit differently. And we want to be sure that you're going to be successful with your first models, especially in these large customers. We're very bullish. I'm sure, like me, you believe MongoDB is by far the best database out there. So
absolutely,
if we make you successful in your first projects, you're going to come back for more. So that's the intent, and if someone asks how much is that going to cost me, it's a free service that we offer. Again, So we want to be sure things are going to work and you won't have any issues.
So that generally people come in with their own design model that they have already or that they're considering putting into
That is
place?
a good question, absolutely. We get kind of a range of different scenarios. You can come at the beginning of your project and you want to see if MongoDB is going to be a good solution from a model. Can I do that with MongoDB? And we're going to be really honest with you. If MongoDB is not a good fit, we'll tell you. We'd rather that you don't use MongoDB if it's not good.
That's great. I love
and
that.
having a bad experience, and then that bad experience, being transmitted to other people in the organization. But you may be at the middle of your project where you have a data model, but you have questions. Things don't seem clear. You want clarification. You may be further in your model where you're close to going to production and you want the validation that everything is okay. Obviously, if we're going to tell you it's not, you need to ensure you have enough buffer time to change things. So do it a little bit earlier is probably better in that case.
Yeah, the opportunity to get clarity is really nice. I certainly remember going through that part of the journey myself where I just wasn't sure. I had something, seemed to work, but was it right? And it's very difficult to kind of get that.
Yeah, and it's going to be really useful. We may find things. But the one thing to also understand with MongoDB is if you have to do changes later, you can still do them without downtime. Now, if your model is right at the beginning, you're going to save a lot of effort doing right if you can. But the requirements change, and they should. If you have a successful project that's going to last for many years, things are going to change. The workload's going to change, the number of operations, and maybe even requirements. Things that you have to start adding to your model. And we're going to point out how you can do some of the modification over time without downtime.
That's great. So I guess maybe an interesting question for the people at home. What's the most common design mistake you see when you're doing design reviews?
Yeah, the most common or the worst mistake?
Maybe both. Give us both if they're not the same.
The one we don't like is show me your ER diagram, and then we see 20 tables, and I'm like, okay, and what's your first draft for your collection diagram? And then we have 20 collections. No, this is not working.
Yeah, just relational modeling in MongoDB.
No, we do the other lookups, we support the joins, but you don't want to do that on the most important and frequent operations. So, yeah, I would say that's probably the worst mistake. And this is where you need to change your mindset and get, thinking a little bit different. And we can guide you, through that. Yeah.
So, I mean, that really comes. What's the solution to those companies? I get that there are many solutions depending on what their model kind of really is, as opposed to how you would model that in a relational database. But kind of what's the overall rule for sort of remodeling?
Well, how you get there in terms of training, or some basic rules that if you think if you apply those, you'll be in much better shape.
Yeah, I was thinking the latter.
Yeah, when I do my presentation, it's something I like to say is, what you're going to be using together in the application should be stored together in database. I think that's the main principle. There's a lot of the design rules that come out of that. When you look at some of the pattern, that's exactly what you're doing. We're not embedding everything, or we're not referencing. We're trying to be in between, because these things are used together, but not all of them. Yeah, that'd be the main thing that you should apply. You should start thinking of when you.
I've heard whole rooms full of people chant that like a mantra. What you query together.
That's a good idea. I haven't done it, but I think I'm going to try that next time. I'm going to repeat it many times in the 30 minutes or 45 minutes.
So I think my first exposure to your work at MongoDB was actually in a series of blog posts on design patterns. Which I think is something I recommend in pretty much every live stream I ever do. Every time I give a talk, it's if you're using MongoDB, go and read. You have to go and read these posts. So there's, I can't remember how many, 12 or 13 patterns?
Yeah, there was 12 in the series, yeah.
So what would you say is the most, I don't know whether to go with interesting or kind of useful design patterns in there? What do you think the most illustrative of?
Well, the one I use often in the reviews, the two I will say that come back the most often would be the extended reference and would be the computed pattern. And in a very short description, when you model with MongoDB, you always have the choice between embedding or referencing entities. But sometimes you're in a case where it's in between. You say neither of those is the perfect or right solution. So what should I do? And then the extended reference is a good pattern for that, because basically what's going to tell you is to bring embed a little bit, but not everything, but embed whatever you need to avoid doing those costly join on the important information. And if you need more information once in a while, go fetch it. But you're not going to fetch all the time, so you can save a lot of resources. So that's the first one. The second one is in the case with what you're trying to model is either a UI or an application that send response to API calls. What's important in those cases is the latency. You want to build that answer as quickly as possible. And one mistake that you could be doing is having to do operations that are often the same, and I'll go a little bit more into that, all the time, at the time that you're trying to provide the answer. So if you have the leisure to spend a little bit more time at right time to prepare the data in a form that the UI will make only one read and everything for that page, then it's going to be much faster.
Yeah.
So in one of the signs also you get when you should apply the computed pattern is you're going to have a high ratio of read operation versus a write operation. So if you have something like that, it means, let's say I have 1,000 times more reads than writes. In average, I'm computing the same thing 1,000 times.
Yeah.
So why not doing it at write time?
Yeah, and relational databases don't generally give you the ability to do that pre-computation and then store it back in a database, because you're usually doing those joins and creating.
Yeah, you can store it, but you'll store it sometimes in another table. You still have to do a join. MongoDB lets you put it in the entity that you query all the time. That's the important entity that you want to retrieve.
Yeah, it's interesting to see that the sort of engineering has sort of relearned this over time.
Yeah, you need to start thinking a little bit differently. Start thinking with these patterns. You get it after a while. It's just a matter of practice. And
yeah. So if somebody was trying to go into data modeling, they've maybe been using MongoDB for a little while, but they want to get better at data modeling specifically within MongoDB. What's the best way, would you say?
Well, we have all the reference, we have the blogs, and I'm going to put my plug here. I did write a book that has all the patterns, and it's a bit more up-to-date.
What's the book called, if I need to Google for it later?
Yeah, and I can sign it. One of the best resources we have is the university courses. So we do have a path for learning data modeling, and there's a certification associated to it. But another plug is on Monday, October 14th, we're starting a new series of webinar on data modeling, where we're going to display very short topic, 10-15 minutes, and we're going to ask the audience what they want to see in the next session. So it's going to be my whole team doing it, rotating. But we're going to also try to model live some of the problems that some of our audience going to bring. So that should be fun. And basically what I'm saying is if you attend a design review session, you're going to be learning how we do it. You're going to see the question we're asking, and basically repeating those questions yourself on your own project. It's going to be a way to learn a lot about data modeling. Also.
Yeah, that sounds fantastic, and especially that length as well. It's almost like there's no excuse really not to sign up for that. So I'm guessing those webinars, if I was to Google for that, it would come up on the MongoDB sign up page for that.
I hope so.
Oh, that's great. So. Yeah, I kind of run out of questions. It's not very good, is it? Not very professional. This is my first interview that I've ever done. So this has been a great conversation. And I really appreciate your time. Thank you very much.
Well, thanks for having me. It was really cool.
This is going to be an amazing talk, so I'm really glad you're all here. Just a couple of quick notes as we head into the afternoon's agenda. You'll see QR codes come up on the last slide of the speaker if you want to give some feedback, capture that. There'll be a little quick survey. They're also going to send one out by email to all attendees towards the end of the day, so you can rate the overall event and give us some awesome feedback. You'll see some great sessions up here throughout the afternoon, as well as back downstairs where the keynote was. So just take a look at those agendas and pick some great sessions to be in on. There'll be a coffee break mid-afternoon as well, and then ultimately a reception at the end of the day. It is my pleasure now to welcome to the stage Ken White. Ken is a security engineer whose work focuses on networks and global systems. He currently leads applied encryption engineering in MongoDB's global product group as security principal. Ken is co-founder and director of the Open Crypto Audit Project and led formal security reviews on TrueCrypt and OpenSSL. He currently serves on the Black Hat Security Conference Review Board, leading the cloud and platform security tracks. He tweets about biscuits, his dogs, good curry, and sometimes security at Ken White, 2 N's. Please give a warm welcome to Ken White.
Thank you. Appreciate it. All right. All right, well, let's dive in. Let's talk about the trust problem, particularly in the cloud. So I have a sensitive application. I've got user information, I've got contact information, maybe credit card data, maybe billing data, PII. Where can plain text get exposed? That is, where in a system, if you're thinking from an architecture perspective, where can sensitive data potentially be at risk, right? So the most obvious thing is somewhere between where your web service or application sits, or frankly, where your end user sits, over the network to the database, right? The second is, in the context of a database, there's physical files somewhere, and those live on disks. Maybe they're cloud storage, maybe they're local NVMe volumes or SSD volumes, but in any event, there's physical files that underlie a database, right? So what about those? Well, it's sort of standard in modern applications, right? So in transit, we think about that, and on disk at rest, we think about that. So we traditionally use something like TLS or HTTPS for network encryption, and that does a pretty decent job in terms of intercept or surveillance from point to point. In terms of the disk encryption or on disk, depending on whether we're talking about the cloud context or a data center, where you're managing your own systems, typically volume encryption is enabled. I mean, on most desktops, it's a single click, right? When you first install the application, it's pretty straightforward. With MongoDB, on Atlas, for example, in the managed database service, we use encryption at rest just by default. You can't disable it. So every cluster that you start up, even if it's like the most toy basic sandbox kind of free instance in the developer tier, there's 3 underlying VMs that get spun up, and each of those have volume encryption. So that entire disk is encrypted. In Atlas, you can also say, well, I want to have a little more tight control over data lifecycle governance. So I'm going to use my own keys. I'm going to create a really narrowly scoped identity role.
Welcome back to the show floor here at .local London. We do hope you're enjoying all the conversations and all the guests that we've had today. Thank you for staying put with us throughout everything that we're doing today. Now, earlier on today at the keynote, again, expanding on what we learned briefly at the keynote, queryable encryption came up. I am joined by Ken White, our security specialist here. And Ken, queryable encryption, what's it all about?
So queryable encryption is a way to protect our customers' most sensitive workloads. So we see a lot of this in the banking world, and in the energy fields, in the DoD, but really everyone has sensitive data, right? Everyone has some kind of crown jewels that they want to protect. And so the idea with queryable encryption is that you can save records in an encrypted format, but the database doesn't learn what that is, and it doesn't have keys. And so if there's an attack, there's a compromise on the database side, if there's someone comes up and blackmails one of our senior engineers or holds a gun to our CEO's head and says, "Give me this data from Bank X or whatever," we say, "Fine, here's a copy of the data, but it's all encrypted. Good luck with that." So that's the basic premise.
That's the short version, because I think it was at a prior .local in London that we launched queryable encryption a couple of years ago. Right?
It was, yeah. We take the stuff really, so there's a lot of things in the cloud world where you can kind of iterate and move really quickly and sort of move on the fly. With cryptography and with security, you want to be very deliberate and really have really rigorous engineering practices. You want to analyze things very properly. You want to have lots of third-party reviews. You want to be very careful about what you do. And so we had it in preview form for about a year, and then we GA'd it last year. Excellent. So what we've just announced today is that range support. So being able to do searching for everyone over 25 to 50, every financial balance it's between $10,000 and $1 million. Okay. Every audit record, every sales transaction that happened between this date and that date is supported, but in a way that the database never understands what's being asked for. And even if you have DBA level privileges, you don't learn anything.
This is the thing that, and I don't know what event we were at, but I shared a booth with Cynthia, who was a prior PM, or probably still is the PM in the space. And I remember poking her all the time going, how does it work? How does it work? How does it work? To me, in that entire query round trip, nothing is exposed. It's like magic. It's still being able to query, but nothing is being exposed, and your data is secure in transit, at rest, and within the query itself, correct?
That's right. So even if, even if the network is compromised, even if TLS is broken, even if someone gets a copy of the disk and steals it, or encryption at rest was compromised, it doesn't matter, because it's similar to end-to-end encryption like you'd find in WhatsApp or Signal, where the idea is you've got two parties communicating.
Right.
Anyone that eavesdrops over the network, if I haven't turned my phone off and you've sent me a message, that message is sitting on a server somewhere, but it doesn't matter, if I don't log on for a little bit, if they had access to the server, they still can't see it. So it's a very similar idea to that. What's unique about queryable encryption is it was built from the ground up for high-performance database search. So there's all kinds of encryption sort of libraries and techniques out there, but very few are meant for generalized search for operational workloads. There's a lot in the kind of academic world that are kind of toy type use cases where I've got 100 records and I've got one laptop and one database server, but as soon as you get into distributed systems, as soon as you get into I've got threaded web services, I've got high concurrency, I've got tons of users, those things break down. And then also there are some encrypted search techniques that may take seconds or minutes to get an answer back. Well, that's just not realistic for an operation like that.
And I suppose a testament to how serious we take this is that we have a research group for cryptography.
That's right.
And have built this, and when we put it out first, we also open sourced our method, right? Because it needed to be up to scrutiny.
Yeah, exactly. So we worked with a group out of Brown University called the Encrypted Systems Lab when we built our first generation client-side encryption. And what they did that was really useful was they helped us think about the model. What are the promises we can make? What are the things that we can't guarantee? It's important to understand what you don't get from this particular security control. That collaboration was really, really positive. And they were working on a lot of other sort of advanced tech. Pardon me.
No worries.
And so about 2 years after we launched, they had a major breakthrough. We talked to them about it, and then eventually we acquired the company. So today we have an in-house cryptography research group. It's headed up by Seni Kamara and Tariq Moataz, people who have been in the field for, in Seni's case, over 20 years.
Wow.
He literally pioneered the field of encrypted search when he was back at Microsoft Research. And so a lot of the knowledge, the basis, the sort of formalisms have been out there for 15, 20 years.
Yes.
What we were able to do is to operationalize that into a practical database and put things in place that made it easier for developers to use. Because a lot of times, tech products put a huge burden on the developer. They have to become cryptography experts. They have to understand different encryption modes and key sizes and all this sort of thing. And we said, well, what if we made this very opinionated, based on conservative, sort of cryptographer-approved values, so that basically you set up a little boilerplate code, and then as a developer, if you want to insert a document, you just write an insert statement like you used to. If you want to query a bunch of documents, you should be able to query without having to think too much about the underlying crypto. And so, after that acquisition, we've recruited more cryptography researchers. I think there's like 5 PhD cryptographers in the group. Wow. Okay. They're publishing papers. They're leading, academic conferences. We now have like visiting scientists and student interns. I mean, it's a proper, full-blown R&D group.
It's wholly strategic for us, given the clients that we have. I mean, I know that certain institutions and certain industries, financial, medical, etc., are reluctant to go to the cloud, or were reluctant to go to the cloud. But with this approach, essentially, it's pretty much the last barrier in being able to say, we don't want our data being shipped around like this, correct?
Yeah, that's right. And so while we started with some pretty sophisticated use cases, everybody's got crown jewels. Everybody has some kind of PII data or sensitive data they want protected. But our sort of more high-end, sophisticated customers said, look, this isn't some James Bond or science fiction scenario. We have entire nation states that are targeting our platform.
Sure.
When you're moving hundreds of billions of dollars a day through capital markets, that's not fiction. You really do have to kind of think about that. And none of that to say that we've sort of developed some magic silver bullet that'll cure all problems, but rather that we took a very disciplined, careful approach of confidentiality, of keeping your secret, keeping the secret from us. You don't have to trust us that we'll do the right thing, because there's the sort of hackers, there's the hacker side, but then there's the what happens if I'm compelled as a service provider? Sure. What if we get a court order or some law enforcement thing, or you're under litigation and a judge says, I need a forensic hold, MongoDB, give me a copy of this customer's data. Fine, we'll give you a copy of it, but it's encrypted. Good luck with that. But what it really means is that the customer controls their data, full stop. Yeah. Unless they supply the decryption in their keys, it doesn't matter whether, again, our CEO is held hostage or
we've no root in whatsoever.
That's right. Even if someone had root level privileges on the virtual machine, even if they had hypervisor level access, it's not. They're not seeing the clear text data, and they don't have access to those keys.
It's super secure. So we announced range queries. Before that, it was exact match.
It was.
Yeah. So range queries allows, as you said, a couple of examples. Right. Search for transactions between this value and that value, etc. As well too. Is there more to come? Full text search, for example?
Oh yeah, absolutely. So queryable encryption is a platform for expressive search.
Okay.
So we're hoping in the first half of next year to introduce text support, prefix, suffix, substring support. We'll GEA that after some reasonable amount of time, and then then it's open. We're potentially considering vector. We're potentially considering geocode. It's an expressive platform, so we're super excited about it.
Excellent. And where do developers go to find out more, Ken?
Sure.
Where would they go today?
Yeah, so just query MongoDB queryable encryption. We've got docs and tutorials and code snippets you can copy and paste. If you Google the MongoDB cryptography group, lots of technical papers. If you want to look at the formal proofs, you want to understand the underlying math, that's your source.
Excellent, excellent. Well, listen, Ken, this has been an eye-opener. I can't say that I still understand how it's done. It looks like magic to me, but it's great to see it advancing and what you've added with the range queries, and I look forward to seeing what more. Thank you very much for joining us on the MongoDB live stream.
You're very welcome. Thank you.
Excellent. And from the show floor, we will take a short break, and we'll be back very soon with another guest. Thank you.
There have been some amazing updates, so let me show you what it can do. At a high level, the extension allows you to navigate your databases, collections, and documents in MongoDB. You can get a quick overview of schemas and indexes. You can use playgrounds to aggregate and to write scripts. It's great at rapid prototyping. You can edit documents and save changes to the database. It has intelligent auto-completions. The MongoDB shell is built in, and you can even export queries and aggregations from your playgrounds to other programming languages right from inside VS Code. First, install the MongoDB for VS Code extension if you haven't already. You can search for MongoDB in the Extensions panel in VS Code or use the link in the video description. After installing it, go to the new MongoDB tab on your sidebar and let's connect to a database using our connection string. Now, if you need help setting up a new MongoDB Atlas cluster, take a look at this video, which is linked in the video description. You can also connect to a local or self-hosted MongoDB database. Now that we've connected, we can see all of the databases associated with this cluster. We can expand one of these and we can see the collections in it. This collection, for instance, has 24,000 documents. And we can quickly see how the documents are structured by looking at the schema. This is extremely useful when you're trying to build out a query, since it lets you quickly identify which fields you can query and what the field types are. Now, the schema is inferred from a subset of the documents in the collection. You can also see indexes on each collection and even add indexes without leaving VS Code. This makes it easy to ensure that the query that you're writing is covered by an index. We can even open one of these documents right here in VS Code to get an idea of its structure, and we could update and save the document back to the database if we wanted. And we can also easily see the different types of collections based on their icons. Here I have a time series collection alongside other regular collections. But one of the best features of this extension is the MongoDB Playgrounds. Playgrounds are JavaScript environments where you can run any MongoDB shell command, and they're really great to prototype queries and aggregations. Playgrounds also play nicely with JavaScript tools like ESLint and Prettier. So let's go ahead and create a playground. Now, this is just a file, and it comes with a template that shows examples of how to use the playground. So again, this is using standard shell commands. So here we're using the MongoDB VS Code Playground DB database. Now, I don't currently have that database in this cluster. We can go over to the MongoDB tab, and we can look at this cluster and see that it's not there. So when this playground is run, it will create this database for me. And next, we're going to get the sales collection and then insert several documents. And then we're going to execute a find and then console log the sales count that occurred on April 4th, 2014. And then finally, we're going to execute an aggregation pipeline, which looks at all of the sales for 2014, and then we'll see the results for that. So let's go ahead and run this playground by clicking the play button in the top right, and then we're going to get a confirmation message that pops up. Now, this is going to run these commands on our actual cluster, so we do need to be careful. We'll go ahead and say yes here, and we'll see the results. So we can see our console log here that there were 2 sales, and then we can see the results of our aggregation, which shows all of the sales. Now let's say that we want to actually implement what we've written here in another language. The MongoDB for VS Code extension makes that really easy. Now all you have to do is select the bits that you want to convert to another language. For example, I want this aggregation pipeline here. Now I can open up the command palette and then search for MongoDB extract, and you can see I can choose from Node.js, C#, Python 3, Java, Ruby. So I'm going to select Java, and I'm going to get the Java code now that I can use in my Java application. That's so cool. Now the playground template is nice to have when you're first getting started, but what if you want to just start off with a blank template? Well, we can disable the template in the VS Code settings. In settings,
Okay, hello again, everybody. If you've been watching the stream all afternoon, you may have seen me about half an hour ago interviewing Daniel Kupal, and I'm back, and this time I'm with Max Marcon. Max, why don't you explain what you do, what your position is, and kind of what you do on a day-to-day basis?
Yeah, so I am a director of product at MongoDB. I lead developer tools. That means the Atlas CLI that you saw a lot of today, Compass, MongoDB Shell, ID extensions, a few other things, AI, developer tools. That's what my team does.
Just a really small list.
Yeah, exactly.
Excellent. And you were on the Keynote this morning.
I was.
Congratulations.
It was fun.
That went very well.
Yeah.
It's great. So yeah, tell us about, we're here to talk about the Atlas CLI and the kind of the GA of Docker support with the Atlas CLI.
So as Melissa mentioned in the keynote this morning, this is a functionality that we announced in public preview last year here in London. And in this past last year, we've been working very closely with a number of customers to see how we could support them best when they develop with MongoDB locally. And locally means not on the cloud, not on a server that's somewhere, but most likely on the developers' laptops. And then when it comes to testing, that could also mean in CI, in your continuous integration server, in your GitHub Actions, and so on. And the primary reason for providing this new experience for Atlas is that we really want to give developers a very short feedback loop. So think about it, you're writing code, you put some data into MongoDB, you run some tests, and you want the result right away. You don't want to wait for a deployment, you don't want to wait for a cluster to spin up somewhere. You want to insert data, read data, and do that very efficiently. And that is a fundamental capability when you are building an application. It's even more important when you're testing an application. So if you run a suite of tests, like 1,000 tests, and you want to be able to do that before every commit, you need the environment to be fast, you need the environment to spin up quickly. So having it locally in a Docker image means that it's going to be fast. And you can throw it away, and you can create a new one, and so on.
Fundamentally, the tighter you can keep that feedback loop, the faster developers can get stuff developed. It's probably the biggest thing you can do, I think, to keep developers productive. I have to say my own personal experience bringing up Atlas with the CLI, just kind of running a command, and I'm running Atlas on my own machine. It's absolutely incredible.
And I love it personally. It's the way I used to write applications, develop applications. We've seen a lot of success with both offering to the CLI as well as with Docker. Customers love the idea that they have Docker already for everything else. They use Docker Compose for their application stack when they build code, when they write tests, and now we can give them the same experience for others, and I think that's just amazing.
So you mentioned that there, like getting into the details. So this is one of the new features in with the Atlas CLI, is this integration with existing Docker tools like Compose, right? So if I'm already using Compose, I can add configuration in there to bring up the Atlas.
So the Atlas CLI is just sugar around the experience. So, but you can go and get the Docker image directly and insert it in your Docker Compose file. And when you have that, you can spin it up with the rest of your services, but the CLI still knows about it. So if you want to look at what local environments are running, you do Atlas deployments list. Those will still show up. If you want to put data in those environments, that you can still do with the normal tools that you use. If you want to create search indexes, then you can still do with the Atlas CLI.
That's very cool. And once I've kind of set up all this environment locally, then when I'm moving to production, do we have anything in there that kind of helps with that lift and shift?
Not right now. We've been talking to customers. We know that there are opportunities, for example, in the area of lifecycle indexes. Think about even what we showed this morning in the keynote. Like you build an application, you realize that there is an index missing. Maybe your IDE tells you. Now you go create an index locally to make sure that the MongoDB responds in the right way when you create your queries, but then you want to eventually move that index to production. You can do it manually, obviously. You can write a shell script that copies the configuration from local and applies it to production, but maybe over time it makes sense to expose this type of capability already as part of the local offering.
Yeah, that would be pretty amazing. Given how fast we're moving on developer tooling, it wouldn't surprise me if we see that soon.
I mean, for the last year, we've been incorporating feedback from customers into the product, and we'll just keep doing that. So anybody who has thoughts, they can share them on User Voice. They can get in touch in the community forums, and we'll listen to all this feedback, and we also talk to customers directly, obviously, and all of that informs our roadmap.
Great. So maybe a controversial question, I don't know, but is there a future where people can run Atlas on their own machines? Like this becomes kind of a pathway to self-hosted Atlas as opposed to self-hosted MongoDB?
That's a good question. So let me break it up in two parts. So one is can I run Atlas services on my computer, but also in AWS for production use? The answer to that is yes in the future. You saw this morning Sahir talked about search and vector search coming to community. So when that will be available, in the same way you can run MongoDB community today for your hobby project or for the early stages of your startup, you will be able to have search and vector search too. Now, the local experience we're talking about today is a completely different offering. So we're not thinking about production use cases. We're thinking about the best ergonomic for developers to get something up and running quickly. And then it's an experience that we control. We know what's inside. We know how you connect to it. We have a very predictable set of services that are running. And that allows us to connect it with the rest of our tooling. And an example that I just gave to a customer in a meeting that really resonated with them is, I control this experience, therefore, if on your same machine you have Compass, you have VS Code, those can automatically discover those local environments because I know what they look like, I know how to look for them. Yep. And so there's no copy-pasting connection strings around. I open Compass and all my local environments are there. And I click and I'm already working with the data on my laptop.
That's pretty amazing. I haven't actually gone through that experience yet, so I guess I have more digging to do.
So that's something we're still figuring out, but,
I see.
It will happen. And that's what we can do because the environment is so predictable.
Yeah. Yeah, so fundamentally, this isn't designed for scale. It's very much designed for developer experience.
Yes, exactly.
I have to say my experience with it so far has been very good. So can you give us any kind of sneak peek of some of the features that we're thinking about adding in the future?
Yeah, so something that will come very soon, and that is again something we are doing because customers were so vocal about it, is including in the image the MongoDB shell, Mongo import, Mongo export, Mongo dump, Mongo restore, and in general the ability to automatically seed your local cluster with data and create indexes. So right now you can do that with the CLI, it's pretty easy, but if we can do it as part of bootstrapping the Docker image, that makes the entire orchestration of your test suite, for example, extremely easy. Yeah. And the team is working on that almost as we speak. So you can expect that will be there soon. And then generally we're looking at what you said earlier, essentially. How can we make the experience of going from local to Atlas smoother? And then also the experience of going from Atlas to local. So if I have my production workload in Atlas, but then I want to build a new feature, can I get a subset of Atlas data into my local environment? So the data I'm working with locally resembles the data I have in production. So all of this is something that we are still figuring out, and there will be a lot of roadmap items going forward around it.
I love this. You don't know this about me, but I used to work in developer tooling within a sort of a big scalable startup.
Oh, really?
So yeah, it's like I've specifically built some of this stuff, and it's hard, especially when you get into data. Like data is the hardest thing to manage within that lifecycle.
It is, and there are important aspects to keep in mind. That's why we don't do it lightly. So there's PII, there's a lot of stuff that is not supposed to be shared when you talk about data. And so we have to be very careful with how we build this type of features.
Yeah. Every time somebody talks to me about taking a copy of their production database to do development, I go,
are you sure?
Yeah. It's like, how much of a conversation do we need to have about this? Yeah. So yeah, it's good that you're thinking about that in the designing this, design of this tooling. So are there any other what would you say is the biggest integration that you can get now, given that this is Docker native, that people can integrate with their tool?
Yeah, so something we've heard a lot from customers, well, mainly two things. So one is GitHub Actions as part of your pipeline, for example. GitHub Actions, you can run Docker containers there, so the integration with the local offering is just straightforward. And then the other thing is test containers. So a lot of customers use them for testing, and they are based on Docker images. Therefore, you can think of creating a test container for Atlas Local.
Yeah.
Now, someone in the community creates some PRs for that. We'll probably try to foster that relationship so we can make it happen.
I love that. Well, I could have talked to you for another 20 minutes, but sadly we've run out of time. So I'm just going to say thank you very much, and I'm really excited to see all of this new. I'm excited about the current release, but I'm also excited to see what's coming down the line.
Yeah, thank you for having me. Hopefully we'll chat about this again on the podcast soon.
Yeah, I hope so. Take care.
Hi, my name is Carolina, and I'm here with my colleague, Ainoa. We're both cross-industry specialists under the Industry Solutions team. Today, we'll be talking about usage-based insurance, and then running through a fun and quick demo. Let's get started. So let's dive into the numbers a bit, and why you should care about usage-based insurance in the first place. The usage-based insurance market size was valued at around $19.6 billion in 2021 and is projected to reach $66.8 billion by 2026. That means there's a huge market potential in the sector. But you might be asking yourself, why? What is usage-based insurance, and what are the drivers? Usage-based insurance is a relatively new approach to personalized quotes that may soon become a new golden standard for vehicle insurers. In contrast to traditional insurance, UBI relies on current behavior patterns rather than static data like age, location, and accidents reported. The shift toward usage-based insurance can be attributed to the following two factors. One, there's a huge amount of IoT data being produced, and insurers are grappling to manage such data. On top of that, consumer expectations are continuing to gear towards personalized experiences based on driving behavior. Given these two factors, what are the challenges of UBI for insurers? Car insurers have several operational needs that legacy software can't fully cover. For example, real-time data processing, whether you need to calculate a quote or provide customer assistance. It's critical for an insurance solution to be able to quickly process input data from different sources and provide accurate results in real time. Another challenge is data types. Today's roads are filled with vehicles equipped with IoT sensors, telematics, and advanced driver assistance systems. All these technologies gather and generate tons of useful data, like geometric data, vehicle state parameters, and driver behavior data. Yet, not all vehicle insurance solutions can properly handle these types of data. And the last challenge is AI and machine learning integration. If you want to integrate AI and machine learning platforms to your database, you'll be faced with complicated joins. Given these challenges, let's dive into the demo and show you hands-on how quickly MongoDB solves these challenges, and Ainoa will walk you right through it. Let's get started.
Let's step through an example of what a digital data processing pipeline looks like using core MongoDB Atlas features and a machine learning platform like Databricks. Imagine being able to offer your customers personalized usage-based premiums that take into account their driving habits and behavior. To do this, you'll need to gather all of the data from connected vehicles, aggregate the data into a data platform, send it to a machine learning platform for analysis, and then use the results to create a personalized premium for your customers. You'll also want to visualize the data to identify trends and gain insights. This unique, tailored approach will give your customers greater control over their insurance costs while helping you provide more accurate and fair pricing. Now that we have a high-level overview of what the process looks like, let's dive into the architecture of our usage-based insurance model. We'll start with data generation. To simulate the data that we would get in real life, we've utilized mLocust. As you can see in our screen, we start with empty collections. With mLocust, we start to generate our customers' driving behavior, for example, distance driven. Now you can see on the screen all of this time series data coming in. Now if we go back to Atlas, look at all of the documents being generated only in a couple of minutes. A point to mention here is that Atlas offers native support for time series data, such as the one we're using for this demo. This means you can eliminate the need for a time series database, such as InfluxDB. Now let's dive into data aggregation. All of the generated time series data is aggregated at the end of each day.
Hey everyone, welcome back to the Expo Hall here in .local London. I'm Luz Carter, back for another interview, and I'm pleased to say today I am joined by two esteemed colleagues from Industry Solutions, so Jeff and Luca. So would you like to introduce yourselves?
Sure, hey, thanks Luz.
No worries.
I'm Jeff Needham, I'm the Industry Principal for Insurance. And with me is my coworker, Luca.
Hi everyone. I'm a consultant for Industry Solutions.
Amazing. So, what kind of things do you do around insurance then with MongoDB? Like how do we use MongoDB to make something so integral, so valuable?
You know, insurance, Luz, is about data processing. You know, insurance doesn't actually manufacture things. It's just about moving bits and pieces of information around the company. So you can imagine there's a lot of data, a lot of databases. And MongoDB's footprint in the insurance industry is significant, I would say, because everything runs on data in insurance. So everything from policy administration systems, claim adjudication systems, customer administration systems. Primarily, we make data easier to work with.
Well, that's very important. And sort of, I think, if I could ask this to both of you, what would you say that you've seen today during .local and all the announcements that we can now talk about more publicly? What things have you seen that you think probably play the most significant part in the work that you do with our customers and beyond?
Yeah, I think the tide has finally turned, where companies are realizing that developer acceleration is key. AI is beginning to now make its way into applications. Legacy systems, especially legacy systems that run traditional insurance business systems, are now kind of bursting at the seams. We realize that we need to move away from these. So I think we're kind of reaching this critical mass now where MongoDB, moving away from legacy relational databases, we're kind of starting to see in mass now our customers and customers around the world really take advantage of the platform.
Yeah, which is really important. What about you, Luca? Anything?
Yeah, I think it's a renovated focus on the centrality of the document model and how important it is. Mongo really doubling down on investment on making the document model, making the core server more relevant than it used to be.
Yeah, and I don't know, I'm sure you would have seen Sahir's keynote this morning. One of the images at the end he showed was that three-sided cube, and one of the things that was on the cube was that modernization. And that, I know from a company perspective, obviously we're playing a huge part in that, because like you say, more traditional databases are bursting at the seams, and so there's so many things that we can do around that modernization to just help our customers and developers to not take over the world, but just make things easier. From a developer perspective, one of the slogans we use a lot is build better apps faster, and that's what it's about. Whether it's data related or code related, it's so important to just make things easier for them. And so it's great to hear that it doesn't matter what industry it is, we can have an impact.
That's right. Yeah, it really is about developer productivity, and it's really around developer friction. Where in the developer lifecycle, where in the development lifecycle of an application is there friction? There's friction on onboarding, there's friction in building tables in SQL, relational databases. There's friction around querying that data after it's broken out into a number of different tables. And so really the document model brings things together and removes friction for the developers. And I think especially now where we're seeing the ability to the need to bring in so many different more pieces of information than we did 20 years ago in relational databases. And the fact that business applications now are undergoing fairly significant transformation, and what that means is there's a lot more change. There's a lot more data. There's a lot more change now that's happening, not every year, but every month. In every agile release, there's new fields added to the database.
Yeah, which is I think is so super important. I think, and so it's just great to hear all these different stories. I think what kind of things have you kind of seen in recent years that you're kind of excited to see improve, coming up with things that we know are coming out, not just with MongoDB, but in general in the industry?
Yeah, go ahead, Luca.
Yes, I think especially when it comes to AI, which used to be very limited to data science experiments. So now with new LLMs and the ease of deployment, ease of use of, the OpenAI API, and these kind of things, the power is in the hands of developers again. So it's really easy to embed AI into applications. And I think this is a crucial step for making it relevant, because it used to be locked into the analytics space. Now we're able to bring it easily into applications.
Yeah, and I know certainly for me, I'm excited about where AI can come in, because even though in developer relations I tend to make quite simple demos and then teach people how to build those exact same demos step by step, AI plays such a big role, because there's all the different types of AI, whether it's using RAG to actually talk to your organization's data to have a custom context and a bit of additional information, or just adding a sort of chat functionality in, because I imagine in insurance kind of things, a lot of your customers will have websites where they'll have chatbots for their insurance policyholders to go in and say, I want to know this, and I guess AI will play quite a big part in that.
Oh, big time, and in fact, that's what Luke and I actually presented this afternoon, was this notion of this converged AI and application data store, that it's not only going to serve the applications that we've known, but also sort of the AI that makes its way into the applications that we have now or the ones that we haven't even built yet. And having that all that data in one central place. Insurance data processing, when you think about data processing in insurance, there's a lot of unstructured data. There's policy forms, there's claim damage photos, there's accident reports, and at some point, someone in the claim handling workflow, someone in the policy administration workflow inside these organizations kind of pivots away from the business application, and they have to look at an image or read a PDF themselves and ingest that, interpret it, come to some conclusion, pivot back to the business application and enter some information. The clock is ticking, That's friction for the worker. And so now with vector search and the ability to kind of now assign metadata to unstructured data, store that metadata in MongoDB, and then make that data quickly searchable, this is going to unlock a tremendous amount of value for the insurance industry inside of applications.
That's amazing, and and I think it doesn't matter where in the world you are and how much or big or smaller part insurance plays in your life.
Right.
Being able to get an answer quickly is so important. There's a few people in my life recently who've had car-related incidents and had to submit on their insurance, and it takes so long to decide anything. So I think bringing AI into that and vector search is just going to be incredible.
That's right, and little small adds up. That pivot point where the business user has to pivot away for 3, 4, 5 minutes, times 10,000 claims, that really adds up. It's customer friction, like you said, Luz. It's operational, costs to the business. And if I can streamline that with AI, I'm going to save money, I'm going to raise customer experiences. It's definitely a win-win.
Amazing. And obviously all these sessions from .local, I believe, were recorded. Was your session recorded today?
Yes, sure
Yeah,
was.
so in a later date, it's on YouTube. So if you're interested in that AI space stuff, absolutely recommend going and watching it, right? It's worthwhile. And is there any other topics sort of around AI that you wish you could have had time to fit in today or you wanted to talk about?
We're just really excited about helping our customers, I think, bring down the barrier of entry in terms of, we think of AI as this really sophisticated component, and it must be really hard to bring that into my business applications. You might be living on a legacy a legacy architecture, so there's a couple of things I think that we've done today. We've kind of highlighted in the keynote our app modernization program, which will help customers move away from their legacy applications more quickly, move the data that's underpinning those applications so you can build a more modern data experience, build a more modern customer experience. And in the application space itself, I think, again, we've lowered the barrier by showing folks, and if you watch our presentation, there's some QR codes at the end. You can download the demos that Luca has built, whether it's the PDF search example or the damage photo example, basically unlocking unstructured data and being able to query that unstructured data in context of the operational data that's already inside of your business application. That's really what we're the most excited about today, Luz.
That's amazing. So we've got a minute or so left. So Luca, obviously Jeff just mentioned that you built those demos. Can you just tell us a little bit about what those demos are that people can see?
Sure. So there is currently three available demos. First one is vector search, pure vector search with images. So you can query your database of images with your current image. Obviously, that's specific to insurance. So ideally, you're querying by some kind of image of a car accident. Second one is RAG, where you can quickly analyze your claims. And the third one is PDF search, where you can kind of go beyond Command F in a PDF, and you can do semantic search. So you can retrieve relevant segments, you can pass that to the LLM for context, and you can get a structured answer, which is really lowering the barriers, as Jeff was mentioning, especially for business users, which can now use natural language to query their data set.
Amazing. So I definitely encourage people to go ahead and look at that. So thank you both so much for joining me, and it's great. Obviously, you were a last-minute addition, Luca, but you know what? I'm really glad you're here. So thank you both for joining me. And if you're listening to this and you're local, make sure to go to the AI Build Together session going on after this.
Yeah.
Later on this evening.
Thank you for having us.
No, it was great. Thank you very much.
Yeah. Cheers.
Have you ever tried to search for something, but you don't quite have the words? Or do you remember some characters in a movie, but you can't remember the name of the movie? Or have you ever tried to find another tracksuit, just like that one that you had back in the day, but you don't know exactly how to search for it? Are you using large language models that don't have the most current information? If you answered yes to any of these questions, vector search is exactly what you're looking for. Vector search is the capability of searching based on meaning. This technique employs machine learning models, often called encoders, to transform text, audio, images, and other types of data into high-dimensional vectors. Vectors, also referred to as embeddings, are essentially a high-dimensional array of numbers that captures the semantic meaning of a word, a phrase, or even an entire sentence. This is what a vector looks like. To a human, it's just numbers, but to an AI, it's knowledge. These vectors can then be searched through to find similar content based on multiple vectors being near one another in a high-dimensional space. Now, this can be a great complement to traditional keyword-based search techniques, but it's also seeing an explosion of excitement because of its ability to enhance the capabilities of large language models, or LLMs, by providing knowledge outside of what the LLMs currently know. In search use cases, this allows you to find relevant results even when the exact keyword isn't known. This technique can also be useful in a variety of contexts, such as natural language processing and recommendation systems. Now, as you probably already know, MongoDB Atlas has supported full text search since 2020, allowing you to do rich text searches on your MongoDB data. The core difference between vector search and text search is that vector search queries on meaning instead of the exact text or even fuzzy text match. And because of this, it can also search data beyond just text. So what are some of the benefits of vector search? First, semantic understanding. Rather than searching for exact matches, vector search enables semantic searching. This means that even if the query words aren't present in the index, but the meaning of the phrases are similar, they'll still be considered a match. Next, it's scalable. Vector search can be done on large data sets, making it perfect for the use cases where you have a lot of data. It's also flexible. Different types of data, including text, but also unstructured data like audio, images, and video, can be semantically searched. Now, while there are a lot of vector databases popping up during this AI revolution, you'll be able to satisfy all of your data storage needs in one place. MongoDB isn't just a document database, but it's a developer data platform. Not only does it offer unstructured data storage, you can also easily store your vector embeddings and use vector search, along with many other great features. You're going to gain efficiency. By storing the vectors together with the original data, you avoid the need to sync data between your application database and your vector store at both the query and write time. You'll also get consistency. Storing the vectors with the data ensures that the vectors are always associated with the correct data. This can be important in situations where the vector generation process might change over time. By storing the vectors, you can be sure that you always have the correct vectors for a given piece of data. And this simplifies everything. Storing vectors with the data simplifies the overall architecture of your application. You don't need to maintain a separate service or database for the vectors. And this reduces the complexity and potential points of failure in your system. And of course, it's scalable. With the power of MongoDB Atlas, vector storage and vector search on MongoDB scales horizontally and vertically, allowing you to power the most demanding workloads. Now it's show and tell time. Let's see how it works. If you don't already have a MongoDB Atlas account, it's completely free. There's a video right here that you can watch and it'll get you started. It will walk you through setting up your first free cluster. And we're going to use one of our sample databases that you can load, but it's important that you don't load the sample data yet. Just create the cluster. Our plan is to have OpenAI enrich our sample Inflix movie database by adding vector data to each movie. And then we're going to set up a trigger that runs every time a new movie is added to the database. This trigger function will generate the vector embeddings and add them to the document as it's inserted. We'll then set up a search index so that we can use these vector embeddings. And then we'll insert our data and then finally see how we can query our data using vector search. right, so first we're going to create our database and collection so that we can create an Atlas trigger. So here under databases, I'm going to browse collections for this cluster. I'm going to click add my own.
Welcome back to the show floor here at .local London for what is actually the final time. We're pretty much done, Luce.
We are. It's flown by.
It has. It's gone really quickly. 20-odd, 10-minute sessions with guests and different hosts and stuff. How was it for you?
Busy, but really enjoyable. There's been a lot of interesting conversations there, hasn't there? And we've learnt so many different things about things we're releasing that we can talk about now.
It is always good, yeah. It's a bit of an embargo that we can't talk about these things. And then, you know, they get short mention, as I said, on the keynotes. But it was great to dive down in with most of the people who were presenting the detailed slots later on today. You had some of the champions up as well, too. How did that go?
It was good. So I only spoke to one champion, but it was great. And like our community champions are some of my favourite parts of MongoDB because obviously they're external and they're choosing to use their time to do amazing things and advocate for us. So I love giving them a platform to not only hear the stories, the amazing things that they achieve, but also just, you know, talk about what they've done and give an opportunity to hear about it. Because like the interview I did with Nilesh, he was talking about some benchmarking he did for a POC where he replaced Elasticsearch with Atlas Search, and all these delays that were fixed and these requests per second he could do so much better than MongoDB, and it just blew my mind. I was like, wow, we need to write about this and tell people.
Yeah. I know, it's brilliant. And for me in particular, as I was saying to a couple of the guests, you know, I'm in awe of the people who build MongoDB. We use MongoDB in developer relations. We use MongoDB as developers, but it's another level altogether. The people who are building the underhood infrastructure and at the scale that they do it with the performance and the resiliency and everything that Sahir mentioned in that 8.0, right?
Oh yeah, and I'm with you. I'm in awe of so many different parts of the business, to be honest, because everyone plays a part. But like you say, the engineers that build these things and find these amazing performance improvements, or the people in the product side of it who just have this incredible vision and imagination to do all these things. And so, like you say, we sort of use MongoDB a little bit as developers day to day. Like I write code samples, and so lots of the tools that we learned about today, like the IntelliJ plugin and the VS Code Copilot extension, all of that makes my life easier. But I don't always think of these things until someone goes, oh, we've got this new product or feature out now that you can use. And I'm like, oh, I love this.
I know, it's astounding what they keep producing. And with all of the, you know, the .locals we're doing around the world, the kind of stream of announcements that we have at each of them. Like at all of them, there's something new. You know, it used to be a 1 or 2 times a year affair, and we dropped everything. But now it's like we're dripping everything out over the course of the year. And as per some of the guests, I was saying, well, you know, yeah, 8.0 is out. They're already working on the next version. They have been for a long time, you know, so it never ends. What we saw on the keynote, I don't know, I had to write it down. With stream processing, Atlas CLI local experience, VS Copilot you mentioned, integration, IntelliJ, a lot of the Gen AI stuff, more the vector search, quantization there as well too, a little bit of the details of our map program. And then really interesting is the app modernization. You know, taking the relational migrator and everything else that was involved in that and showcasing how that helps developers, you know, do less of the mundane work, how that helps them take their legacy applications and bring them right up to speed.
Absolutely, and as in the interview that I just did with Jeff and Luca from Industry Solutions teams, they were talking about how they've used AI and as part of an app modernization in the insurance industry, and about how not just from a customers on the website perspective, but from the perspective of the actual agents at the insurance company, the way that so much time can be saved by having all these features available to them in their product. So, yeah, and they were saying that data, you know, databases, a lot of them historically relational database, tabular databases are kind of bursting at the seams. So by having all these app modernization things, you can start to move over. And like you say, relational migrator, I did a showcase demo this morning of developer tooling. Yep. And one of the things I showed off was relational migrator. And some people hadn't even heard of it. And I think there's quite a few people in the room suddenly desperately scribbling. And it's like, this thing's amazing. And I was just using, when you open Relational Migrator, you can create a project, but you can do it in different ways, either to a live database or importing a file, or you can actually do it with some sample schema. So if you don't have anything yet, or you don't want to start messing with your data, you can just get MongoDB. Yeah, just test it out, try it out, and can recommend schemas to you. You can visualize the schema. It can make some suggestions. You can edit it as you go. Like, and that's relational migration in terms of the history of MongoDB is quite a new product, and it already does so many amazing things. So, like you say, we've only just released 8.0. We're already starting on 9.0. I don't even know any secrets I can tease you. Like, I don't know anything. But it excites me, all the things that we're going to do coming up in the next year or more, and all, like you say, drip feed over the course of different .locals, and just help developers and developer efficiency and developer productivity, and just make life easier. Because, as I say, I write code day to day, and if I can have a bit of fun making my life easier, amazing.
Well, that's it. I mean, I think Sahir started off with developer accelerations, and that's what it's all about, is making developers' lives easier, more productive, making kind of, I suppose, them just concentrate on the skills that they have, creating the best applications, and taking away all of the, as I said earlier, the mundane pieces. I suppose above all, obviously, our key announcement today was the general availability of 8.0. As Sahir said, it's the best version of our database with the resilience and the scalability and the security and the performance. And so that's the key takeaway. Do check that out. It's available. Check out all the other products. I know for one I'm going to have to watch some of the, I hate watching myself back, but I'm going to have to watch some of the live stream to catch up on all of the bits and pieces that we might have missed. We are nearly done here in London, not quite. We still have an amazing AI build together for 2 hours later on, where we're getting anybody who's interested in creating generative AI applications really in a brainstorming session. So it's like it's a post-it and paper and wall type exercise scenario. So if you are here and you want to join that, by all means do. There's also a small matter of the happy hour that's
we know where you'll be.
going on behind us. So hence the noise has picked up in the room somewhat. But we aren't done with .locals yet. We still have 3 to go.
Yeah, we have quite a few.
So we got Sao Paulo in Brazil. That's in October 30th. Paris in November, the 19th of November. And the last one is Stockholm, towards the end of November on the 26th. So if you're joining us live and you've been on LinkedIn earlier and YouTube with us during the day, if you happen to be based near any of those cities, do try and come along. It might be a smaller version of what you go here, but you're going to see the same access to experts, to great keynote sessions, and great learning with all of our key product managers and everybody else who's presenting, as well as the ability to network with other developers. Definitely do try and do that. I think we're nearly done. I'd like to say thanks to you, Luce, and the other hosts as well too. Last year I had to mostly do this stream all on my own due to poor Mike Lynn getting COVID, so he couldn't travel. So for you, Harshit, Matt, and Mark as well too, thank you so much for joining me.
My pleasure.
Thanks to Jesse and Pedro, who did a lot of the backroom work to make all of this happen and all of the organizing, and they've been diligently been on in the early hours US time, helping us out as well too. And I'd also like to thank Enda and the ITC team who've make this all run so smoothly and make us all look so good, despite a minimal hair and makeup budget here on this side of the desk. But above all, thank you to all our viewers for joining us throughout the day. Do remember to like and subscribe on YouTube. Obviously, got to get the call in.
Absolutely.
Follow us on LinkedIn, because that's where most of these announcements go out as well too. Luce, Richmond, myself, Jesse, Pavel and others live stream very regularly. So if you do like and subscribe and do follow us, you'll get the notifications for the other live streams that we do, right?
Absolutely, and I think we're going to have some of the great guests from today come on as well later to do some even longer segments.
Yeah, I think I've twisted most of their arms to take more than 10 minutes to explain it to us. So look, from the show floor here at .local London, I think that's all. So from me, Shane McAllister.
From me, Luce Carter.
Thank you all, and everyone at MongoDB here, thank you all for joining us. We really had a great day. We have a lot to absorb, but right now, happy hour's kicking off. That's where I'm headed. Take care.